Dear colleagues, I would like to present the results of the improvement and research of the design of piston elements of a drilling pump, which was carried out at the Ivano-Frankivsk National Technical University of Oil and Gas. It should be noted that the reliability and efficiency of the drilling operation in oil and gas fields are determined by the technical characteristics of drilling rings and their circulation system. Drilling pumps are key components of the pumping and circulation complex, which ensure the circulation of drilling mud and the necessary hydraulic pressure. These pumps operate under high hydraulic pressure, cyclic dynamic load, abrasive drilling fluids. Studies show that a significant percentage of drilling pump failure are associated with wear pistons and seals. There are a number of reasons that lead to the failure of cylinder piston assemblies that they are described on the slides. Despite extensive research increasing the durability and reliability of the cylinder piston pair remain an important scientific and engineering task. Solving this problem can reduce operating costs, increase the reliability of drilling equipment, improve drilling continuity and efficiency. The main aim of the research is to increase the durability and operational reliability of the cylinder piston unit of double-acting drilling pump by optimizing the design parameters of the piston, reducing contact stresses, and using effective sealing and reinforcement solution for operation under high pressure and abrasive drilling conditions. Analysis of research by other scientists indicate that the task of comprehensive study the influence of operational factor on piston wear remain relevant in order to further increase their durability. Taking into account the analysis conducted among the research task studies of the influence of piston geometry, sealing elements, and anion protrusions on contact stresses and sealing efficiency were highlighted. An assessment of the deformation of piston components under high pressure operating conditions was also carried out. Recommendations were developed for optimizing the design parameters of piston and operating conditions to increase their service life. The research methodology is based on the analysis of existing drilling pump piston design and the investigation of operational factor affecting the durability of the cylinder piston pair. The study included evaluation of contact stresses, deformation behavior, sealing efficiency, and friction condition under high pressure operating model. Figures show that the design of pistons that are mass-produced and used in the double-acting drilling pumps. The pistons differ from each other in the shape and materials of the sealing elements, as well as in the method of their attachment to the core. The shape of the piston core lip cross-section is important because it creates preload to prevent leakage of the drilling mud at low pressure and ensure the initial sealing process at high pressure. In monolithic design of drilling pump piston, the core was made with ring projections. In monolithic and assembled rubber metal piston design, the core is deformed in the axial and radial direction under pressure and the squeezed into the sealing gap. Research can confirm that the service life of the cylinder pistons assembly depends on the effective iron load of the support section of the sleeve, where peak contact stresses and friction occur. The option solution for the higher pressure is to switch to a module-like design with support ring. This ensures self-centering of the piston, automatic wear compensations, and allows the initial gap between the piston and one cylinder to be reduced to 0.2 mm, which significantly improves tightness compared to monolithic rubber metal piston. Improved design of modular piston using plastic adjustable ring. The most rational shape of the cross-section of the ring is trapezoidal, which ensures a self-centering in the sleeve and is able to automatically compensate for the increased clearance over time. The service life is increased due to the elimination of the compression of the rubber seal into the gap between the piston core and the cylinder sleeve. An analysis of the literature, laboratory, and industrial research has enabled the development of an improvement piston of double-acting drilling pump. The improved collapsible piston shown in the figure consists of a sleeve 4, a core 5, rubber sleeve 3, plastic ring 2, and washer 6, which is clamped with a nut and a lock nut. A conical landing surface is used between the sleeve 4 and the pump rod 7, which ensures the tightness of the pair. The proposed collapsible piston differs from others in that its metal part can be used continuously and only one plastic wash and rubber sleeves are replaced. The most rational shape for the cross-section of the rings is trapezoidal, which ensures the self-centering in the sleeve and is capable of automatically compensating for the increased clearance over time. To determine the optimal value of the bevel angle of the plastic ring of trapezoidal cross-section, the SolidWorks simulation computer program was used, which implemented the finite elements method and supports the use of parametric models. Initially, a three-dimensional model of the proposed design of the drill pump piston and its cylindrical sleeve was built in the program. For simulation modeling, it is proposed to use an axisymmetric model, which simplifies the calculation process itself and has the ability to obtain more reliable results due to the greatest fragmentation of the finite elements mesh as demonstrated on the slide 11. The mesh used for the piston model under investigation was shown in the figure. Also on the figure shows the boundary condition applied to the model under investigation. The material used are steel for the metal part, rubber for the seals, and PTFE for the support ring. The figures show the results of the simulation, deformation and contact pressure, the criterion for the assessing the effectiveness of the proposed piston design is the distribution of contact pressure between the piston components and the cylinder line. Therefore, to facilitate the analysis of these results, the figure shows the obtained graphical dependency superimposed on the piston design. The proposed split piston design has a significant advantage over other designs: increased service life due to the prevention of squeezing into the gap between the piston core and the rubber seal cylinder. The material properties describe the behavior of the sealing cuff of drilling pump piston were taken from literature source rather than determined experimentally, which may affect the accuracy of the simulation result. To improve the reliability of future study, is advisable to perform preliminary experimental testing of the CUF materials to determine its mechanical characteristic and corresponding material constants. An improvement collapsible piston design is proposed with the possibility of reusing metal part and replace only one element. Using the SolidWorks simulation software package, parametric optimization was performed and the optimal angle of inclination of the baking ring was determined, which ensures uniform distribution of contact pressure. It has been proved that for double-acting drilling pumps, the most rational design is composite piston. It allows the drilling fluid to penetrate the friction surface, significantly reducing the temperature regime of the steam. To increase the service life of the piston, it is proposed to use plastic rings with a trapezoidal cross-section and the 3-phi chamfer in its design, which reduces the contact pressure and eliminates the squeezing of the rubber groove into the gap between the core and the cylinder. The use of parametric optimization made it possible to determine the optimal chamfer angle of the support ring based on the contact pressure criteria. The author grateful acknowledged the financial support provided by the ATED project, implementing with the Interact Next Romania-Ukraine program, which covered participation and conference-free expenses. Thank you very much for your attention.
Modeling of effective operating parameters of a two-piston pulsation homogenizer for microemulsions. Kirilla Samychuk, Volodymyr Yalpachik, Dmytro Motorny Tarea State Agro-Technological University, Volodymyr Wojciechowski, Alexander Napnenko, National University of Life and Environmental Sciences of Ukraine, and Olha Mikhailitska, Stepan Gzhitsky National University of Veterinary Medicine and Biotechnologies Lviv. Introduction and major challenges. The production of fine microemulsions through homogenization is widely used in agriculture as well as in the chemical, pharmaceutical, food processing, and other industrial sectors. Homogenizers are most extensively applied in modern milk processing lines and dairy production technologies. Homogenization, which involves the reduction of dispersed particle size, specifically milk fat globules, constitutes a fundamental technological state in the manufacture of drinking milk, cream, fermented dairy products, milk-based beverages, ice cream, and a wide range of other dairy products. Valve homogenizers are the most common type of equipment used at dairy plants. Their advantages include versatility, the ability to process nearly all types of dairy products and mixtures, and high dispersion efficiency, resulting fat globule sizes below 0.8 μm. However, they present significant drawbacks: high cost, substantial weight and size parameters, and extremely low energy efficiency. To address these issues, more than 12 types of new homogenizers with reduced energy consumption have been developed. However, The dispersion quality, degree of homogenization provided by these devices, remain inferior to that achieved by wall homogenizers. Therefore, the hypothesis of this study is that the challenges associated with the development of highly efficient homogenizers can be addressed through the design and implementation of a pulsating dual-piston homogenizer. Aim and research tasks. The device most similar to the proposed homogenizer is a classical single-piston pulsation homogenizer design. However, this type of machine has several disadvantages associated with the non-uniformity of particle size reduction and consequently the uneven fractional composition of the resulting emulsion. Therefore, the experimental design includes a second piston intended to increase the uniformity of processing and the degree of homogenization of the microemulsion. Another known design of a pulsation homogenizer is a two-piston configuration in which the second piston is connected to the first by means of a spring. However, as demonstrated in the previous studies, uncontrolled oscillations of the second piston increase the homogenization efficiency only slightly, by approximately 10 to 20%. Therefore, the objective of this study is to determine the key operating parameters of a pulsation homogenizer, specifically the optimal distance between pistons required to achieve the highest dispersion quality. To accomplish this objective, the following tasks were formulated. To perform computer simulation of hydrodynamic processes in the pulsation homogenizer in order to investigate the influence of piston spacing and pulsation frequency on flow characteristics. To experimentally validate the obtained results by determining the degree of dispersity of the milk emulsion. Research methodology. The performance efficiency of the pulsation homogenizer was assessed using cow's milk as a working medium, which represents a natural microemulsion consisting of milk fat dispersed in an aqueous phase. To determine the velocity of milk flow during pulsation homogenization, numerical simulations were conducted using the universal finite element analysis software ANSYS R18.2, specifically employing the CFX module designed for computational fluid dynamics (CFD) modeling. Based on the results of earlier investigations, a three-dimensional model of the pulsation homogenizer working chamber was created using the SolidWorks computer-aided design environment. The developed geometric model was subsequently imported into the CFX solver within the ANSYS R18.2 software platform. The computational setup in ANSYS Workbench incorporated the geometric characteristics of the pulsation homogenizer together with the physicochemical parameters of milk. The boundary conditions applied in the simulation included atmospheric pressure at the outlet, 1 atmosphere, and a milk density of 1030 kilograms per cubic meter. In addition, the computational mesh structure, turbulence model, and rheological properties of the fluid were selected to ensure the closest possible representation of real milk flow behavior. An experimental prototype of a double-piston pulsation homogenizer was constructed at Dmytro-Motorny Tavria State Agri-Technological University. The homogenization device comprises a working chamber fitted with impact-type piston elements that are set into oscillatory motion by an impulse drive operating through a crank mechanism equipped with an amplitude adjustment system. The primary impact piston is rigidly mounted on the rod, while the secondary piston is coupled to the main piston via a spring element. Both impact pistons are fixed on the rod assembly. During the reciprocating movement of the rod, the liquid medium is alternately displaced from the right and left cavities located within the homogenizer housing. As the emulsion flows through the piston orifices, it undergoes significant acceleration. The resulting high-velocity flow generates intense hydrodynamic stresses in the vicinity of the milk fat globules, which leads to their fragmentation. As a consequence of these processes, effective homogenization of the milk emulsion is achieved. The main geometric parameters of the working chamber and the piston equipped with conical orifices are presented in the figure. For effective homogenization, a key role is played by the pressure and velocity gradients generated in the narrow sections of the piston orifices. The magnitude of the gradient is proportional to the change in flow velocity and therefore determines the degree of homogenization. Consequently, these hydrodynamic parameters were the primary values evaluated in ANSYS R18.2. Results. At the first stage, the hydrodynamic parameters of the emulsion inside the homogenizer chamber were simulated for different distances between the pistons, ranging from 12 to 36 mm with a step of 12 mm. This made it possible to assess the distribution of pressure and velocity in the most critical dispersion zones, the constrictions of the conical piston orifices. The data presented in the figure indicate that the pressure drop in the orifices of the first piston ranges from 2.2 to 2.5 megapascal, while in the second piston it is 2.0 to 2.3 megapascal. This reflects changes in flow velocity within the narrow sections of the piston orifices, with higher values observed in the first piston. This is confirmed by the velocity field distribution. In the first piston, the maximum velocity reaches 100 meters per second. However, the area corresponding to these peak values is relatively small compared to the total orifice region. Since velocity increase is proportional to the degree of homogenization, the quality of homogenization in these local zones will be maximal. Nevertheless, only a small portion of the milk passes through the regions of maximum velocity, while the majority flows through zones where the velocity reaches 75 to 85 meters per second. According to studies of similar pulsation homogenizers, such velocities are sufficient for dispersing milk fat globules to sizes below 0.8 μm, which corresponds to the performance of the best modern valve homogenizers. The aim of the performed simulation was to determine the optimal distance between the pistons of the pulsation homogenizer. Analysis of the results shows that piston spacing has an insignificant effect on the mean velocity values within the piston orifices. The variations lie within the range of 0 to 7%. A similar pattern is observed for maximum velocity values. In the case of minimum piston spacing, 12 mm, zones with peak velocities up to 100 meters per second appear. However, due to their small area, the resulting improvement in homogenization efficiency does not exceed 2 to 4% compared to spacings of 24 and 36 millimeters. At the second stage, the key operational parameter influencing homogenization quality and energy consumption was evaluated: the oscillation frequency of the rod. As the oscillation frequency increases, the velocity in the critical regions of the piston orifices also increases. At 6,000 rotations per minute, the velocity in the first piston orifices reaches 73 meters per second. At 9,000 rotations per minute, 104 meters per second. At 12,000 rotations per minute, 128 meters per second. However, the peak velocity zones account for only 15 to 25% of the total orifice cross-section. Therefore, the degree of homogenization is more accurately characterized by the mean flow velocity within the orifices. To verify the simulation results, experimental studies were conducted on the laboratory prototype to determine the dependence of the average fat globule diameter on the piston pulsation frequency. The results indicate that an average fat globule diameter of 0.8 μm, equivalent to that achieved by high-performance wall homogenizers, can be obtained at a piston pulsation frequency of 8,500 to 9,000 rotations per minute. Slightly better results, by 3 to 6%, were obtained at a piston spacing of 12 millimeters. Conclusions. The analysis of technological equipment intended for the dispersion of fine emulsions has identified a highly promising solution: the double piston pulsation homogenizer. Numerical simulation of the pulsation homogenization process performed in ANSYS R18.2 made it possible to evaluate the influence of key operational parameters, including the distance between pistons and the pulsation frequency of the rod, on the hydrodynamic behavior of milk emulsions and the resulting degree of dispersion. Thus, the conducted research demonstrates the high potential of the two-piston pulsation homogenizer. Future studies will focus on investigating other geometric parameters of the homogenizer design that may influence its homogenization performance and energy efficiency. Upon completion of the research cycle on the pulsating homogenizer, it is expected that this design will be widely industrialized and adopted in dairy processing plants. Thank you very much for your attention.
Hello everyone, my name is Olga Ostrukhova and today I will present our research devoted to evaluating the force parameters acting on a carbide cutting tool during wheelset profile restoration on KZH-20 underflow lathe. Railway transport used in open-pit mining requires reliable maintenance and regular restoration of wheelsets. One of the industrial solutions used for this purpose is the KZH-20 underflow lathe, which allows wheel set profile restoration without removing the wheel sets from the locomotive. This approach reduces repair time and maintenance costs. However, efficient operation of the process requires reliable milling cutters and accurate evaluation of the cutting forces acting on the cutting elements during machining. Cutting force modeling for conventional machining processes has been widely studied, but there is still limited information about carbide milling cutters operating on KZH-20 machines. Therefore, this study focuses on experimental evaluation of the tangential cutting force component Pz and evaluation of the influence of the main machining parameters of the cutting force. The main aim of this research was to evaluate regression dependencies of the tangential cutting force component Pz on cutting depth, feed rate, and spindle rotational speed. To achieve this aim, one-factor experimental studies were carried out under controlled laboratory conditions. The study also evaluated the relative influence of each machining parameter on the cutting force during wheel set profile restoration. In addition, the obtained regression models were analyzed to identify which parameter has strongest influence on the cutting process. The machining parameters used during the experiments were selected according to technological recommendations and allowable operating conditions for the machine's surface quality. The research methodology was based on experiment planning, statistical modeling, and regression analysis. 3 separate one-factor studies were conducted: dependence of cutting force on cutting depth, dependence on feed rate, and dependence on spindle rotational speed. One-factor experiments were selected because they allow independent evaluation of each machining parameter while keeping the remaining parameters constant. This makes it possible to evaluate the individual influence of every parameter on the cutting force component Pz. To improve reliability and reduce the influence of random errors, each experiment was repeated 3 times. This slide presents several types of special milling cutters used for wheel set profile restoration on different industrial machines. The study focused on carbide milling cutters used on KZH-20 underflow lathes. One of the important practical tasks in such machining operation is optimization of cutter geometry and machining condition in order to reduce tool wear and improve machining efficiency. Therefore, experimentally evaluated cutting force parameters are important for further improvement of the restoration process and increasing operational reliability of the equipment. The obtained experimental data were processed using regression analysis implemented in the Mascad software environment. The methodology included calculation of regression coefficients, the determination of experimental variance, verification of coefficient significance using student's t-test, and adequacy assessment using Fisher's criterion. These statistical methods made it possible to verify the reliability and adequacy of the obtained regression equations. As a result, reliable mathematical models describing the dependence of cutting force on machining parameters were obtained. This slide shows the experimental and calculated dependence of cutting force on cutting depth. It can be observed that increasing cutting depth caused a significant growth of the tangential cutting force component Pz. This behavior can be explained by the increase in the contact area between the cutting tool and the material during machining. Larger cutting depth leads to higher mechanical resistance and therefore higher cutting forces. The obtained results also demonstrate good agreement between the experimental and calculated values. Among all investigated parameters, cutting depth showed the strongest influence on the cutting force. This slide presents the dependence of cutting force on feed rate. The results show that increase in feed rate also caused an increase in the cutting force component Pz. However, the influence of feed rate was less significant compared to cutting depth. The experimental and calculated values demonstrated a relatively good agreement, which confirms the adequacy of the obtained regression model. The graphs also clearly demonstrate the overall tendency of gradual increase in cutting force with increasing feed rate. This slide presents the influence of spindle rotational speed on the cutting force. The obtained results show that increase in spindle speed contributed to a reduction of the cutting force component Pz. This behavior may be explained by improved cutting conditions and reduced resistance during material removal at higher rotational speeds. The comparison between experimental and calculated values again demonstrates acceptable agreement of the regression model with the experimental data. The purpose of this study was successfully achieved. Regression dependencies of the tangential cutting force component Pz on the main machining parameters for Carbide 4 milling cutters operating on KZH-20 machines were evaluated. The results showed that cutting depth has the greatest influence on cutting force, feed rate has the smallest influence, and increase in spindle rotational speed reduces the cutting force. The obtained regression models can be used for optimization of cutter design and machining parameters during wheel set profile restoration. In practical applications, these results may contribute to reduction of tool wear, improvement of restoration quality, and increased operational efficiency of railway maintenance processes. Thank you for watching this presentation.
Greetings everyone, I'm Daniel and today I will present the preliminary findings on generative models as a tool in mechanical reverse engineering. So on short will be about the models like Trellis 2 or Hunyang 3D. Those are generative 3D models, very general, using general data was training. So this is a most of like observation about how they generate the models and everything. Like an introduction, reverse engineering is about reverse engineering. It's the most labor intensive part in mechanical cycles. Also designing is one of the challenging. So traditionally we can start from basic shapes and extrude them in the software, in CAD software, or use 3D scanners, high-end 3D scanners. But they also struggle with shiny reflective surfaces or different factors, so needs to be taken account. So in this we try to explore the image to 3D, pictures to 3D. However, there are many challenges in this. So the context, as I said, is reverse is slow, struggles with shiny metals, especially now with image to 3D being very popular and very facile alternative. So yeah, we put all the questions. Will the models, AI models output still serve as viable route draft for precision CAD modeling despite these limitations? Will the trained model on consumer data will have an organic bias? As we know, a lot of models are trained for smooth surfaces or organic objects. So where we have precision or sharp mechanical feature like the gear teeth will be able to be translated in this way. And are the results, I mean the meshes and everything that it generates, usable even as a reference in a structure and a lack of real-world dimensions? So to get everything, the aim is to investigate this model, Trellis 2 and Hyang 3D, and see if they are good as a raw draft generator for mechanical components. We'll try to assess robustness against high specularity, I mean shiny objects, surfaces, observe the organic bias versus the sharp precision, and also analyze the scale ambiguity in normalized unit space. So before we start, we need to, what we'll scan? We'll try to scan. For this, we choose pretty basic polished steel spur gear that is made from carbon steel. It's like 15 millimeters in the pitch diameter and 20 teeth. So yeah, usually the problem with it being steel is shiny, has a lot of highlights and shadows. This picture were actually better high quality of the parts and multiple angles. Tools will matter next. Also, now let's talk about the models. We choose to work with two models, Trellis 2, because the results are very consistent, and Hyang 3D because it has multi-view reconstruction. And let's compare a bit. Trellis 2 use a single view reconstruction, meaning you use only a single picture. In the case of Hyang, we use multiple picture of the states, like right, left, as we've seen before in the previous picture. These are the settings that we expect the output, like the resolution of the voxel grid, the textures, the faces. Also for Hyang, we have inference steps. Each steps to do each time it tries to take the parts of the 3D model and make it again. That's the step, and also the tree, and also fixed it for reproducibility. To mention that both models are reconstructing the geometry in a canonical unit box. I mean, this is not created in millimeters or inch. It's just points, decimal points. Analysis criteria. For analysis, you look at the visual versus geometric, the normal maps to detect if detail is real geometry or just paint and texture, topological stability for checking for non-manifold edges or logical triangulation flows, especially in Blender or another CAD software, and also how they scale each component to each other and how do they measure. With this said, let's look at the results. As for results, the first one, this is the Trellis 2 model being shown in plane. This is the recreation of the 3D model after everything. Here we can see a big win for the model. Despite the gear being very reflective, he achieved a very watertight recovery of the surfaces and also approximation everything. We can count the teeth, we can see the highlights. However, the model understands that highlight is a surface property, not a geometric void. This suggests high utility for digitizing shining parts without using anti-glare sprays or coating the part to be perfect pictures, the perfect environment. So this is a good thing when we don't want to have problems with this. This is the second model by Hyang 3D. So here we can see a bit of deformation, especially in parts like this, where the first model didn't have any problem. We can see deformation on the teeth, and also the center is deformed. Also, we can see a little bit of organic bias. As said before, everything looks a little bit melted. So the model interprets sharp creases as smooth ondulation. This is because the models are trained in specific data, more organic, like animals or furniture, so the model applies a smoothing prior to everything else. And also is deformed, very deformed based on, even though they had more pictures, they had more data to account for. Like we had the three sides, the front, the back, and the left side of the model. This is not very good to see, especially because if we wanted to use this, will be more work to correct these kind of things. But if we go back to the previous model, you could say it looks almost perfect. But is not there yet, because here we can see the back of the part, and the problem arises from the lack of vision behind. As Trellis 2 had a single view, so a single photo from the front looks exactly one-on-one. But here we can conclude a critical failure. The lacking data for the back of the gear, the model hallucinated hexagonal rods connecting to the hub. So yeah, this is much a classic in generative models, to try to guess the shapes that looks very similar to what he knows, but he doesn't know very specific this kind of models. This proved that the reverse engineering multi-view input is mandatory on better models. Now, let's take this model and look a bit closer, because yeah, you could say, this is an easy fix in CAD, this is more logical. But if we open the wireframe like Blender, we can see a lot of triangle soup. We can see a lot of points in each mesh that shouldn't be, because the model created triangles for every surface trying to mesh the original input, and this results in a 200,000 unstructured triangles. That's not desirable in any way if we work with CAD software in this way, or 3D modeling software especially. And also it's not good for performance of the model or the editable of the model. So mostly it's good as a reference, but the resolution is pretty high. Close to a 3D scan, because mostly a 3D scan is the same, a very high mesh triangles. So it's better if we trace over, especially if we are speaking about precision. We need to get the measurements right. So this is not very good. But if we were to compare the relative dimensions, it's mostly on the same idea with the original. So it's more like a reference that can be worked over than having from a start, than having it a new thing. And now as conclusions, well, the conclusions, we propose the digital sketch. I mean, the models provides the volumetric context and rough blueprint, which the engineering then traces in CAD to bridge the gap. But I think in the future, if models are trained with specific mechanical parts and data specifically for this kind of thing, we could and make a data set specifically for this, we could have better results. Until then, Human oversight is required to calibrate, scale, and fix the melted geometry. Is highly efficient in preliminary and could be very good to be integrated in the workflow, not to be the tool to replace the traditionally way we do this modeling, but to be integrated in the workflow and help solve problems or take faster times. So yeah, I want to thank you for the help from the project Root for Dig that helped this paper. Also, gratitude to the researcher of Trellis and Yun Yang for the open access they did, and this model are open source and can be run. We run on own machines. So thank you for attention. I hope this was pretty interesting, pretty much to take into consideration this kind of workflow and integrate it in the future. I'm now open for any question you might have.
Good day, dear colleagues. We are pleased to participate in the conference once again and contribute to the discussion on current challenges in engineering education. Today, we are presenting the results of our recent study entitled Selection of the Content for the Development of Professional Competence of Engineering Teachers. So, let me start with some introduction points and outline the major challenges for the research. Continuous scientific and technological progress, rapid innovation, digitalization, and the growth of knowledge-intensive industries significantly transform vocational and engineering education worldwide. Modern engineering education increasingly requires stronger alignment with labor market needs, competency-based standards, sustainability principles, and contemporary industrial expectations. In this context, engineering teachers play a crucial role in organizing learning, supporting students, and assessing learning outcomes. However, engineering teachers today face several major challenges: rapid technological change, competency-based education, increasing industry expectations, and the necessity for continuous professional development. Therefore, teachers must simultaneously update their technical, digital, and pedagogical expertise to remain effective in modern engineering education. Although recent studies define engineering teachers' competencies, discuss pedagogy, and propose development models, important methodological gaps remain. There is still no systematic procedure for selecting and structuring professional development content, while practical methodological tools remain limited. Moving on now to the aim and research tasks. The current research aim was to substantiate the technique for selecting the content for the development of engineering teachers' professional competence based on certain scientific approaches, principles, requirements, and methods. Let's go on with the research methodology. Since the subject of this research is directly related to the competency-based approach in engineering education, the first stage focused on analyzing the main provisions of this educational concept. The competency-based approach shifts attention from knowledge accumulation to the development of practical skills, alignment with labor market needs, and harmonization with European educational standards. Accordingly, the research included the analysis of professional and educational standards, scientific literature, and previous studies on engineering teacher competence. Based on this analysis, a taxonomy of professional development goals was developed, followed by the design of a content selection technique. Finally, the proposed technique was validated through a pedagogical experiment. Thus, the study combined conceptual theoretical analysis, literature review, pedagogical modeling, and experimental validation. This slide illustrates the competency-based logic of engineering education in Ukraine. The professional standard serves as the starting point, defining the competencies, knowledge, skills, and abilities required for professional activity. Based on these requirements, the educational standard is developed, specifying the expected outcomes, educational content, assessment requirements, and quality assurance mechanisms. In turn, the educational program transforms these standards into concrete curricula, courses, practices, teaching methods, and assessment procedures. Thus, the educational process becomes oriented not toward the transmit knowledge alone, but toward the achievement of competencies and practical readiness for professional activity. Importantly, this competency-based logic should also guide the professional development of engineering teachers, since teachers must continuously update the competencies required for modern engineering education. Based on previous experimental findings, 9 components of engineering teachers' professional competence were identified and ranked according to their significance. As shown in the figure, instructional, communicative, subject, and methodological competencies received the highest ratings, while environmental and research competencies were assessed as less significant. These findings became the basis for designing the proposed technique for professional competence development. The proposed technique is based on a set of principles and criteria that ensure the quality and relevance of professional development content. The principles include systematicity, humanistic orientation, scientific rigor, consistency, accessibility, and connection to practice. At the same time, content selection is guided by criteria of professional relevance, scientific validity, feasibility, adaptability, and alignment with international best practices, ensuring coherence between teachers' needs and contemporary engineering education requirements. Now let me go on with the results. The core contribution of this study is a 6-step technique for content design. It includes source analysis, content selection, content inventory, filtering and compression, organization and structuring, and sequencing and alignment. Together, these stages ensure that professional development content is systematic, relevant, coherent, and practice-oriented, responding to both teachers' competence needs and contemporary engineering requirements. The effectiveness of the proposed technique was validated through a pedagogical experiment conducted in 2024 to 2025 at a Ukrainian technical college. The study involved 91 engineering teachers, whose levels of professional competence were assessed before and after the implementation of the technique. The assessment covered 5 components: motivation and value, cognitive information, behavior and activity, personal reflection, and emotion and volition, enabling us to identify measurable changes in competence development. The experimental results demonstrated clear positive changes across all competence components. The proportion of teachers who reached the advanced level increased substantially, from 42.1% to 65% in motivation and value, from 27.9% to 50% in cognitive information, from 41.1% to 60% in behavior and activity, from 37.9% to 55% in personal reflection, and from 40.1% to 70% in emotion and volition. These findings confirm that purposeful, structured, and controlled professional development significantly improves engineering teachers' professional competence. The practical value of the proposed technique lies in its applicability for multiple stakeholders. For colleges, it supports program quality, relevance, and alignment with professional standards. For teachers, it offers a structured pathway for continuous competence development and teaching improvement. Industry partners benefit from stronger alignment between educational content and workforce expectations, while students receive more relevant, practice-oriented education. Importantly, the technique is flexible and adaptable to different disciplines, institutional contexts, and emerging technological demands. Despite the positive results, the study has several limitations. It was conducted within a single national context, in one institutional setting, and focused on selected engineering disciplines, which limits the generalizability of the findings. Therefore, future research should include cross-national comparisons, longitudinal validation, and the integration of AI-based tools and digital simulations to strengthen the evidence base and expand the applicability of the proposed technique. Thus, we could make the following conclusions on the findings. To conclude, the study developed a principle-based technique for selecting the content of engineering teachers' professional competence development and proposed a replicable 6-step process for its implementation. Experimental validation confirmed measurable improvements across competence components, demonstrating the effectiveness of structured and purposeful professional development. The proposed technique is adaptable to modern engineering education and can support the sustainable professional growth of engineering teachers in changing educational and technological environments. Thank you for your attention.
Dear colleagues, your attention is presented with a report on the topic, Justification of the Influence of Transmission Type on Changes in Traction and Energy Performance of Tractors. Introduction and Major Challenges. The modern development of agricultural production in European countries is characterized by increasing demands on tractor energy efficiency, reduced operating costs, and increased process stability during energy-intensive agricultural operations. Under these conditions, the choice of tractor transmission type becomes a key factor, determining its actual productivity and efficiency, especially when performing energy-intensive operations such as plowing. The choice between step speed, PST, and continuously variable, CVT, transmissions stems from differences in their operating principles. A key research gap is the lack of a comprehensive methodology for evaluating and comparing the traction and performance of tractors with different transmission types. Thus, the relevance of this study is determined by the lack of a comprehensive methodology for assessing the traction and energy performance of tractors with different transmission types in energy-intensive agricultural operations. Addressing this issue allows us to substantiate the impact of transmission type on tractor traction and energy performance from the perspective of traction stability and economic costs associated with tractor operation in modern agricultural production. Aim and research tasks. To substantiate the influence of the transmission type on changes in the traction and energy performance of a tractor from the standpoint of traction stability and economic cost during operation of tractors in modern agricultural production, it is necessary to develop a design scheme for the mechatronic system of the hydraulic drive of the tractor chassis, develop a strong functional scheme for determining the traction and energy performance of a tractor with different transmission types, analyze the traction and energy characteristics of tractors with stepped and continuously variable transmissions when performing energy-intensive agricultural operations, justify the type of tractor transmission from the standpoint of traction stability and net cost during operation in modern agricultural production. Research methodology. The methodology for assessing traction and energy performance includes computational and comparative approaches. The studies were conducted on 100 kW tractors with both step type and continuously variable transmissions. To study the change in the traction and energy performance of a tractor with a continuously variable, hydrostatic, transmission calculation scheme for the mechatronic system of the hydraulic drive of the tractor chassis has been developed, which makes it possible to justify the choice of transmission elements. To implement the proposed methodology for determining the traction and energy performance of tractors with stepless and continuously variable transmissions, structural and functional diagrams have been developed. The simulation of changes in the traction and energy performance of a tractor with different transmission types was carried out using the Visual Simulator Dynamic Modeling package. Structural functional diagrams allow us to obtain characteristics of changes in the traction and energy performance of tractors with step and continuously variable transmissions for different engine power under operating conditions, and compare their efficiency. The operating principle of both circuits is identical and operates simultaneously. Therefore, Block 1 serves to input initial data for the transmissions being studied. Block 2 is designed for the direct implementation of the calculation method and the construction of traction and energy performance indicators for a tractor with a 4-speed step transmission. The method for assessing traction and energy performance indicators for a tractor with a continuously variable transmission is implemented using Block 3. Results. It has been established that for a step transmission, operating modes with maximum traction power and speed are achieved only with a limited number of hook-pull values. The discreteness of the gear ratios of a step transmission leads to productivity losses, reduced operating speed, and increased hourly and specific fuel consumption in the inter-gear traction force ranges. An analysis of the tractor's traction and energy performance with a continuously variable transmission shows that this tractor, while delivering a nominal tractive effort of 24,078 newtons during plowing, develops a traction power of 97 kilowatts and a travel speed of 14.5 kilometers per hour. Meanwhile, the hourly and specific fuel consumption remained unchanged at 27.6 kilograms per hour and 302 grams per kilowatt hour, respectively. The given traction and energy indicators of a tractor with a continuously variable transmission show that at any value of the traction force on the hook, the tractor is used with the maximum possible values of traction power and speed. Calculations of the traction and energy performance of tractors with step-type and continuously variable transmissions were performed for a 100 kW engine. It was found that for a step-type transmission, operating modes with maximum traction power and speed are achieved only with a limited number of hook pull values. The discreteness of the step-type transmissions ratios leads to productivity losses, reduced operating speed, and increased hourly and specific fuel consumption in the inter-gear traction force ranges. A comparative analysis of the traction and energy performance of a tractor with a stepped and continuously variable transmission, when working on plowing, shows that a tractor with a stepped transmission can work at the highest possible speed and with maximum power only at 4 values of traction force on the hook, corresponding to 24,078 N in the first gear, 19,184 N in the second, 15,166 N in the third, and 11,870 N in the fourth. It is known that the range of traction forces cannot be limited to only these values. Therefore, when using a step transmission, we have a loss of productivity, lower speed, and, as a consequence, an increase in energy indicators, increase in hourly and specific consumption. Thus, it can be concluded that the traction and energy performance of a tractor and its productivity when using a continuous variable transmission are higher than those of a tractor with a step transmission by 13%, according to various indicators. Conclusions. As a result of the conducted research, the influence of the tractor transmission type on the change in traction and energy indicators during energy-intensive tillage operations was substantiated. A simplified mechatronic model of a 100 kW wheeled tractor's hydrostatic drive and structural functional diagrams for determining traction and energy characteristics of tractors with stepped and continuously variable transmissions were developed. Implemented in the visual simulator dynamic modeling environment. For a step transmission, the calculation was performed using 4 fixed gears, while for a continuously variable transmission, the operating points were selected in such a way as to ensure engine operation in the zone of minimum specific consumption. It has been established that with the same traction force on the hook, tractor with a continuously variable transmission develops a 6-13% greater hook power and a 5-13% higher working speed, compared to a tractor with a step transmission with unchanged hourly fuel consumption and a reduction in specific consumption. The areas of appropriation of both types of transmissions have been formulated, continuously variable, for large farms with heterogeneous soils and variable loads, stepped, for farms with relatively stable operating modes, smaller processing areas and limited service and investment opportunity. Thank you very much for your attention.
Good day, dear colleagues. My name is Elena Lannes, and today I am pleased to present our work entitled Structural and Kinematic Synthesis of a Differential Mechanism for Actuating an Inertial-Type Vibration Exciter. We'll begin with the introduction and the main engineering challenge addressed to this study. Vibration exciters are widely used in many industrial machines, including vibrating screens, conveyors, compacting system, and material processing equipment. Their main function is to convert rotary motion into oscillatory energy. Conventional unbalanced exciters are simple, robust, and widely used. However, their main limitation is that they usually operate with a fixed kinematic parameters. In real industrial processes, material properties and operating loads may change during operation. For example, moisture content, particle size distribution, and technological loading condition can vary. Therefore, modern vibration systems require greater adaptability. The key challenge is to control not only the vibration frequency or amplitude, but also the trajectory of excitation. In this work, we focus on circular, elliptical, and rectilinear trajectories. The proposed solution is based on differential gear mechanism, where trajectory control can be achieved through a phase coordination. Let's define the aim of research tasks. The aim of the study is to develop an analytical workflow for the structural and kinematic synthesis of a planar differential internal gear mechanism for an inertial-type vibration exciter with controllable motion trajectories. To achieve this aim, several research tasks were formulated. And then its mobility is verified and the generalized coordinates are selected. After that, closed-form kinematic relations are derived for an unbalanced mass point E. The next step is to define phase coordination laws that allows us to generate circular, elliptical, and rectilinear trajectories. Finally, the synthesized motion regimes are validated using numerical simulation. The methodology is based on a structural and kinematic synthesis workflow. The methodology starts from a structural modeling of the differential mechanism. The mechanism is considered as a planar rigid body system with internal gearing. The mobility analysis confirms that the mechanism has 2 degrees of freedom. This is a key point because it means that the mechanism can be treated as a differential mechanism with 2 independent inputs. The selected generalized coordinates are alpha of t, which describes the rotation of the ring gear, and phi of t, which describes the rotation of the carrier. All other angular motions are derived from these 2 generalized coordinates and the gear geometry. The core methodological idea is therefore a clear sequence. First, the mechanism structure is defined, then mobility is verified, then kinematic equations are derived, and then phase coordination laws are imposed, and finally, target trajectories are obtained. This slide shows the key mathematical idea of the methodology. The first equation defines the orientation of the unbalanced mass. It shows that theta of t depends on both generalized coordinate, the ring gear rotation alpha of t, and the carrier rotation phi of t. It also depends on the internal gear ratio, I. The second equation describes the trajectory of point E. This trajectory is represented as a superposition of 2 circular motions, the motion of the planet center and the eccentric motion of the unbalanced mass relative to the planet gear. The important point is that the prescribed trajectories can be obtained by imposing phase relations between theta of t and phi of t. For circular motion, a co-directional phase relation is imposed. For elliptical motion, a counter-directional phase relation is imposed. A straight line trajectory is obtained as a degenerate ellipse when eccentricity E is equal to L. This phase coordination is a central mechanism that allows us to synthesize the required trajectories. The result includes numerical validation, rectilinear motion analysis, the influence of gear ratios, and experimental verification of rectilinear trajectory generation. The analytical relations derived in the methodology were implemented in Wolfram mathematics. The implementation included the dependent angle of theta of t, as well as the position, velocity, and acceleration of point E. For the numerical validation, the following baseline parameters were used. L equals 10 mm, E equals 6 mm, the gear ratio I equals 2, and the operating frequency is 15 Hz. The figure shows possible trajectories of the point E. Without phase coordination, the point follows a multi-loop trajectory. However, when the appropriate phase coordination laws are imposed, the motion is reduced to controlled circular, elliptical, and straight line trajectories. This confirms that the analytical synthesis methods work as predicted. This slide focuses on rectilinear motion mode. Rectilinear motion is obtained as a degenerate case of the elliptical trajectory. The required conditions are theta of t equals minus phi of t plus sigma and E equals L. Under this condition, point E moves along a straight line. The direction of this line is controlled by the phase parameter sigma. For the numerical case where L equals 10 mm, the peak displacement is 20 mm and the full stroke is 40 mm, the peak acceleration is approximately 177.5 meters per second squared, or about 18 g. This result is important because rectilinear excitation is widely used in directional vibration systems. A key practical result concerns the influence of the internal gear ratio. For elliptical and rectilinear modes, the required coordination between the ring gear and carrier depends on the gear ratio I. When I is between 1 and 2, the ring gear and carrier must counter-rotate. When I is greater than 2, both elements rotate in same direction. The most important case is I equals 2. In this case, the coordination coefficient becomes 0, meaning that the ring gear can remain fixed while the carrier is driven. This is a mechanical advantage because the elliptical and rectilinear modes can be achieved with a simple configuration: a fixed ring gear and a driven carrier. This may reduce the number of active drives and improve stiffness at high operating frequencies. As an additional result, we include experimental verification of rectilinear trajectory generation in a single mass oscillatory system actuated by planetary type internal vibration exciter. The experimental test bench included an oscillating mass, elastic suspension in two perpendicular directions, a drive motor, a planetary type vibration exciter, a control unit, and potentiometric displacement sensors. These sensors measured the horizontal and vertical displacement of the oscillating mass, and the corresponding trajectories were reconstructed in the vertical plane. The experimental results show that quasi-rectilinear motion can be generated with different orientation, almost vertical, almost horizontal, and inclined. This supports the feasibility of mechanically programmed rectilinear trajectory generation. At the same time, the experimental trajectories show slight non-smoothness. This indicates real machine effects such as transmission compliance, local resonances, backlash, or sensor noise. Therefore, the experiment supports the practical feasibility of the concept, but also confirms the need for further dynamic and load validation. The experimental results strengthen the study because they demonstrate the feasibility of mechanically programmed rectilinear trajectory generation. However, they do not remove the limitation of the analytical model. The analytical model still describes nominal target trajectories. In real hardware, deviations may arise due to backlash, compliance, friction, manufacturing errors, motor control inaccuracies, and interaction with the machine body or processed material. The experimental research also shows minor trajectory roughness caused by high-frequency effects and non-idealities, which motivates further refined modeling and robustness testing. Now summarize the main conclusions. A planar differential internal gear mechanism was synthesized for an internal vibration exciter, inertial vibration exciter. The mobility analysis confirmed that the mechanism has 2 degrees of freedom, with alpha of t and phi of t selected as generalized coordinates. Closed-form relations were derived for the orientation, position, velocity, and acceleration of the unbalanced mass point E. The study shows that the phase coordination laws enable the synthesis of circular, elliptical, and rectilinear trajectories. A particularly important practical result is the gear ratio I equals 2. In this case, elliptical and rectilinear modes can be achieved with a fixed ring gear. Finally, experimental evidence from a planetary type inertial exciter supports the feasibility of mechanically programmed rectilinear trajectory generation. The authors gratefully acknowledge the support of Lviv Polytechnic National University, Wrocław University of Science and Technology, and Kingston University. The authors also thank to colleagues and collaborators for valuable discussions related to this research. Thank you very much for your attention.
Good day, everyone. We would like to present our work, Model of Formation of Managerial Competence and Leadership Skills of Heads of Engineering Departments in the Process of Digitalization of Professional Training. The authors are Viktor Nagaev, Yulia Sagachko, Alexander Khridin, Galina Nagaeva, and Minenko Sofia, by State Biotechnological University of Ukraine. Chapter 1. Introduction and Major Challenges. In modern conditions, the problem of training heads of engineering departments who are able to effectively manage production process, make sound management decisions, ensure sustainable development of enterprises, and form competitive advantages based on innovative approaches is of particular relevance. A key component of the professional readiness of such specialists is developed managerial competence, an integral element of which are leadership qualities. At the same time, traditional approaches to the formation of leadership qualities of engineers do not fully meet the modern challenges of the digital economy. This necessitates the scientific substantiation and implementation of new models of digitalization of the process of forming leadership qualities of heads of engineering departments in the context of developing their managerial competence. Under these conditions, we see the development of a model of digital leadership of managerial engineering personnel in the process of forming their managerial competence as a problematic aspect. Chapter 2. Aim and Research Tasks. The purpose of the study is to develop and scientifically substantiate a structural functional model of digitalization of the formation of leadership skills of managers, which ensures the systematic development of their managerial competence. The objectives of the research: to analyze the theoretical and methodological aspects of the process of training engineers in conditions of digital leadership, to substantiate the components of the managerial competence of engineers managers and their criterion indicators, to develop a structural and functional model of digitalization of the formation of leadership qualities of heads of engineering departments, to optimize pedagogical conditions and didactic forms of management of the process of forming managerial competence of engineers managers, to carry out a review of the effectiveness and implementation of proposed model of digitalization of engineering training. Chapter 3. Research Methodology. The research methodology is based on the use of modern methodological approaches: systemic, competency, process, cybernetic, axiological, and includes the ascertaining, formative, and control stages of the pedagogical experiment. The ascertaining stage of the experiment, the basic level of leadership skills of engineers and their management training, was clarified, and the level of formation of professional competencies of the future agricultural engineer was investigated. The survey was attended by students of the State Biotechnological University of Specialty 208 Agroengineering of the educational level Bachelor. The formative stage of the experiment aimed to develop a research concept based on the definition of hypotheses, scientific laws, and principles of building a model of digitalization of the formation of leadership skills of future heads of engineering departments, which ensures the systematic development of their managerial competence. At the control stage of the pedagogical experiment, a comparative assessment of the effectiveness of the proposed model of digitalization of the formation of leadership skills of head of engineering department was made, and the reliability of the scientific hypothesis was assessed. Chapter 4. Results. The managerial competence of heads of engineering departments in modern conditions of digital transformation is considered as an integrative professional characteristic that combines a system of knowledge, skills, value orientations, and personal qualities necessary for effective management of agricultural enterprises. An important component of managerial competence is leadership skills, which ensures the ability of engineer managers to influence personnel, form a team, make strategic decisions, and adapt to dynamic changes in the external environment with the systematization of stages for human resource management. Modeling the process of digitalization of leadership qualities of heads of engineering departments should take into account such properties as the current state of the economy, the existing level of the employee motivation system, the balance of remuneration, the level of regulation, informatization and technologization of production process, etc. In the case of enterprises in which students of the State Biotechnological University, Specialty 208 Agroengineering, underwent extensive practical training, we have developed a technology for the development of leadership skills of engineers based on the empirical data. Results, Chapter 1. Technological Foundations. This technology is based on the introduction of management functions into the educational environment, the implementation of the methodology for forming leadership competencies in the system of digital leadership model, which includes the following stages. First, modeling a set of strategic, tactical, and operational goals based on the program goal method. Second, development of the personal management plan with the designated stages of the formation of leadership skills. Third, training of the key task and formation of leadership skills which will support the zones of strategic influx of enterprise. Fourth, emphasizing the goals of leadership in the mind of human resource management which favors promising engineering projects. Fifth, creating a digital model for optimizing personal process in the system of management competence. Sixth, determining the level of business activity of formal and informal leaders based on modeled criteria. Seventh, assessment, analysis, and leveling of the formation of leadership skills of engineers based on modeled process of business activity of the engineering management system. Results, Chapter 2. Digital Leadership Model. Taking into account the above approaches, we have developed a digital leadership model for heads of engineering departments in the Smart Educational Environment System. Please refer to Scheme 1. Management competence within the model is considered as a system of the following interrelated components. Value motivational. A stable motivation for educational and creative activities, internal acceptance of leadership, willingness to take responsibility. Cognitive analytical, knowledge of the basic of leadership, understanding of management principles, ability to analyze information and draw conclusions. Activity organizational, ability to plan actions, distribute tasks, organize implementation, control progress, and correct decisions. Communicative leadership, ability to clearly explain tasks, listen to subordinates, build trusting relationship in the team, maintain morale. Psychophysical, ability to act under stress, maintain self-control, make decisions in situations of uncertainty, withstand significant physical and emotional stress. Digital technological, ability to effectively use communication tools, information system, modern technical means of analysis, and management support. Results, Chapter 3. The process of forming managerial competence. The process of forming managerial competence and digital leadership of the engineers is determined by integrated mechanism of combining content, blocks, and dynamic stages of the digital educational environment, which provides for the following pedagogical conditions. First, organization of digital educational environment for online network contact in interactive mode. Second, creation of a system of electional database of information resources. Third, formation of electronic distance learning complex based on electronic textbooks, teaching aids, recommendations for independent and individual work of students in the network system. Fourth, creation of an electronic diagnostic complex of remote control, electronic logs of attendance of training sessions, accounting of independent and individual work, test control of knowledge. Fifth, development of a regulatory framework for organizing distance learning in the conditions of digitalization of pedagogical process. The effectiveness of the implementation of educational methodological development was carried out according to the following qualitative educational criteria. The ability of future engineering managers to effectively perform managerial functions, the level of creative activity, the development of leadership qualities, the development of digital and communicational skills, systematic thinking, the ability to make decisions in conditions of uncertainty and risk, the ability to self-manage, the level of self-reflection and self-development. Chapter 5. Conclusions. In addition, the development and testing of a digital leadership model for manufacturing and manufacturing engineers is being carried out, which is aimed at shaping their management competence in the minds of digitalization. A model has been proposed that integrates managerial, technological, psychological, and digital components of the professional activity of a ceramic worker, which ensures consistency with the current benefits of engineer master management practices. The result of the study showed an increase in the formation of managerial competence and leadership skills of future heads of engineering departments by 24%. The introduction of the model into the process of training heads of engineering department in the higher education institutions contributes to the systematic development of key components of managerial competence, namely strategic thinking, digital literacy, ability to manage innovations, team interaction, and data-based management decision-making. It is proven that the use of digital tools, platforms, and analytical systems increases the effectiveness of managerial activities and the adaptability of managers to a changing production environment. The results obtained confirm the feasibility of integrating the digital leadership model into educational programs for training heads of engineers departments and the system of advanced training. That's all. I hope you enjoyed our presentation, and thank you very much for your attention.
Good afternoon, dear colleagues. My name is Roman Nosov, and today I will present our research, investigation of cutting cross-sectional area using special foam milling cutters based on developed filter instrument in the LabVIEW environment. This work was carried out at Dnipro University of Technology. The research is devoted to the modeling and simulation of machining processes for locomotive wheelset restoration using special foam milling cutters. Restoration of locomotive wheelsets is an important technological operation in railway maintenance. The machining process is complicated because wheel profiles have complex geometry, large machining allowness, and high material hardness. Special foam milling cutters are used for this operation. During machining, high mechanical and thermal loads act on the cutting inset. This slide presents the technological scheme of wheelset machining. The wheelset is processed simultaneously by left and right special milling cutters. Our study object is the cutting cross-sectional area formed between two neighboring cutting insets of the milling cutter. The main problem is to determine how the geometric parameters of the cutter influence the cutting cross-sectional area. Based on production experience, we assumed that stable operation of cutter is achieved when the cutting cross-sectional area remains within approximately 0.7 to 1 square millimeters. Now about our aim and research tasks. The aim of the study was to investigate the dependence of the cutting cross-sectional area on the geometric parameters of special foam milling cutters, using a virtual instrument developed in the LabVIEW environment. To achieve our aim, we need to complete the following tasks. Develop a digitized algorithmic model in LabVIEW, simulate different cutter profile variants, and verify adequacy of simulation results. Our task is to simplify this process by using LabVIEW environment. Now about our research methodology. In this work, two different methods of computer modeling were used. The first of them, and the main one, is based on the created algorithmic model with software implementation in LabVIEW 70.1. The second of them is a rough analytical method using a CAD system, which was used at the final stage of the study to verify the result of the work. This slide presents the calculation scheme of the cross-sectional area formed by two successive cutting elements. The first cutting element formed one boundary of the removed material layer, while the second cutting element forms another boundary. The material located between these boundaries represents the cutting cross-sectional area. The mathematical model includes definitive intervals describing the geometry of the removed material layer. The cutting cross-sectional area f was selected as adequacy criteria of the machining process. The parameter L, which represents the distance between adjacent cutting elements, was chosen as the independent variable. Other geometric parameters R, A, B, C, and D were treated as model parameters. The developed original digitized algorithm model of the virtual instrument is based on the sequential execution of built-in LabVIEW 70.1 functions. For this purpose, the thread sequence structure was used, allowing the program code to be organized into spread computation stages. Following this simulation algorithm, the result is the virtual instrument. The developed system enables fast investigation of different cutter geometries without performing expensive experimental tests. This significantly simplifies engineering analysis and optimization of machining parameters. The algorithmic model of the virtual instrument consists of three main stages. The first stage performs numerical iteration of function y11. The second stage performs numerical iteration of function y12, and the third stage calculates the final value of the cutting cross-sectional area. The developed structure provides clean separation of computational tasks and improves the readability of the algorithm. This slide presents the first simulation stage. The operator can input geometry parameters of the cutter, iterational limits, and numerical iteration step size. The front panel also displays intermediate computational results, allowing the verification of simulation correctness during implementation. The image shows the first stage of the calculation, the left part of mathematical model. On the slide you can see the second stage. The calculations are carried out identically to the first stage. In the third stage, we obtain the final result in the form of the cross-sectional area as the result of the sum of stage 1 and stage 2. The second front panel with the result of calculation F, you can see on the slide. This slide presents the final simulation results, and they compare with the graphical analytical calculation. A green column on diagram, rough analytical method, blue column, simulation in the LabVIEW result. For all investigation variants, the obtained value demonstrates very good agreement, around 0.01 difference between values. The table presents the geometric parameters of the investigated view profiles. 3 profile variants were analyzed. These parameter sets correspond to standardized wheel profiles already used in industrial production. Therefore, the obtained simulation result can be considered particularly relevant. The result confirms the adequacy of the development virtual instrument and validates the proposed research hypothesis. In conclusion, a digitized algorithmic model of virtual instrument was successfully developed in the LabVIEW environment. The developed systems allows investigate on the cutting cross-sectional area of special foam milling cutters. The main scientific contribution of this work is the development of a virtual simulation tool for analyzing the influence of milling cutter geometry on the cutting cross-sectional area. A digitized algorithmic model of virtual instrument was developed in the LabVIEW environment. A diagram shows the dependence of the cutting cross-sectional area on the variance of geometric parameters. The future instrument obtained in the study can be applied in the design of the new advanced technological processes. Future work will focus on improving the automation capabilities of the model and including additional dynamic machining effect. Thank you very much for your attention. I forgot to answer for your question.
Formation of secondary structures in surface gradient layers of metallic materials, taking into account surface defects, impurity diffusion, and oxidation reactions. By Mykola Denisenko, Olena Devyatko, Natalia Kanivets, Mikhailo Tuzuk, and Leonid Lisovsky. Introduction and major challenges. One of the key challenges facing Ukraine's economy is raising the technical standards of the engineering industry, which determines the productivity, precision, and reliability of machinery. Improvements to machinery depend on the quality of their main dynamic components, tribological systems. The self-organization of turbostructure is most common when machines of various types operate under boundary friction conditions. Self-regulation in this mode manifests itself in the formation of protective secondary structures, which shield the main material of the component from direct contact, seizure, and severe damage. According to the generalized classification of types of surface degradation, one of the predominant processes in surface gradient layers is the influence of the external environment on the structural transformations which occur during oxidative wear. They are determined by the properties of the ultramicroscopic and microscopic volumes of the surface layers formed during plastic deformation of the material and the simultaneous formation of solid solutions and chemical compounds of oxygen and metal. Aim and research tasks. The aim of this work is to investigate the formation and evolution of secondary structures using standardized methods for detecting defects in metallic materials directly at their points of origin. The research tasks are as follows. Analysis of the causes of various types of wear with a determination of the nature of wear in the surface layers. Research into the influence of the external environment on the structural changes occurring in the surface layer of a material at the micro and submicro scale during technical operation. The study of the evolution of the structure and properties of contact surfaces during metal friction and the role of oxygen in the formation of secondary structures, taking into account surface defects, impurity diffusion, and oxidation reactions. Determining the presence of impurities, their penetration into the surface layers, and associated oxidation reactions, which ultimately determine the wear resistance and service life of components. Research methodology. All failures and damage to machine components are linked to one operational parameter or another, such as wear resistance, corrosion resistance, strength, etc., and, as a rule, begin on the surface of the components. The influence of environmental factors leads to changes in the quality of the surface layer of components. The surface adapts to operating conditions. The study of actual contact points leads to fatigue failure of surface layers and increased wear, depending on factors such as the size and geometry of abrasive particles, their concentration, and the hardness of the abrasive. The output parameters are wear, predicted failure, and the coefficient of friction. The process was studied on actual machines, whilst the course of normal mechanochemical wear was simulated under laboratory conditions using standardized methods. The investigation of the influence of individual factors on the patterns of material transformation was carried out differentially, with other factors remaining constant. The surface layers of materials were studied using SEM and EOS methods on a GEOL-JAMP-10S auger spectral microprobe under the following conditions. Primary electron energy 5 kiloelectric volts. Modulation amplitude 2 to 4 volts. Angle between the surface plane and primary beam 90 degrees, and the angle of registration of auger electrons was 45 degrees. Results. Direct mechanical contact between components during operation demonstrates that, under the influence of the external environment, the friction surfaces allow the formation of a uniform layer of deformed, activated metal. The chemical reaction of this metal with active elements in the surrounding environment subsequently results in the formation of weakened secondary structures. An increase in temperature at the point of contact indicates a change in the interaction between components and the formation of weld bridges. The main surface feature determining abrasive wear under static loading is the presence of fine scratches and indentations of varying lengths, which are always oriented in the direction of abrasive movement within the range of 0.01 to 0.02 micrometers. It has been established that the wear resistance of machine components is enhanced by the formation of a layer of secondary structures. In the fracture process of 65G steel, shear processes play a significant role, causing the matrix to gradually break down, whilst iron, titanium, and manganese carbides flake off. In this type of wear, the rate of surface destruction exceeds the rate of other processes occurring on friction surfaces and is predominant. Whereas in abrasive wear, if the processes of slippage and deformation predominate, then the associated phenomena of metal interaction with atmospheric oxygen, as well as the influence of moisture and the chemical composition on the environment, become of great importance. The intensity of abrasive wear due to the diffusion of impurities and oxidation reactions ranges from 0.5 micrometers per hour to 5 micrometers per hour. Secondary structures are thin films on the friction surface that form under conditions of severe deformation at elevated temperatures, which cause diffusion during absorption as well as during various decomposition and assimilation reactions. Under high loads exceeding the elastic limit of the material, the substrate undergoes plastic deformation and the film breaks down. Intermolecular and interatomic forces form between the friction surfaces, diffusion processes are consequently activated, and the material loses its functionality. The working surface of a composite material is characterized by fine-grained fragmentation, with thin films ensuring surface passivation. The penetration depth of these film structures is minimal and typically ranges from 0 to 1 micrometer. Conclusions. An analysis of the formation of secondary structures indicates that the mechanism of material wear within the abrasive particle mass involves various changes, which in turn depend on the ratio of the hardness of the particles to that of the material being worn. The worn surface of a component, when subjected to friction in an abrasive, sometimes becomes smooth and forms a multitude of shallow grooves due to differences in strength. When assessing the dimensions of the damaged surface layer of material deformed by friction, it has been established that damage accumulates, whilst the thickness of the layer accumulating this damage remains constant. According to research, the greatest intensity of surface damage during friction is caused by abrasive particles with a small radius of curvature, sharp-edged particles, ranging from the size of 0.2 to 2 millimeters. The data obtained indicates that the durability of parts and joints under abrasive wear primarily depends on the specific pressure, the friction path, the hardness, and the structure of the friction surface. Thank you very much for your attention.
We present to your attention a report on the topic, Vilian on high requirements for the creation of high precision and high quality mechanical engineering products require a significant increase in the scientific and technical level of metalworking technologies, which is associated with the use of new equipment, cutting tools, and improving the qualifications of manufacturers. This especially applies to the performance of finishing operations, which ultimately form the parameters of the quality and accuracy of products. However, as practice shows, it is quite difficult to achieve high technical indicators during the manufacture of modern mechanical engineering products. For example, during the manufacture of high-precision aviation products and other high-tech products, This usually leads to a decrease in metalworking productivity and a decrease in the competitiveness of these products in international markets. Therefore, the problem of increasing the productivity of processing high-precision products is becoming an important scientific and technical problem that requires an urgent solution. Significant progress has now been made in its implementation. First of all, it should be noted the use of high-performance machine tools with numerical program control (CNC) of the machining center type instead of outdated traditional low-productivity equipment. They allow to increase the processing productivity several times, which significantly increases the competitiveness of manufactured products. However, this is achieved in the previous operations of processing products with blade tools during the removal of significant allowances. At the same time, the final finishing operations, as before, remain without significant changes. They are performed with low productivity using traditional low productivity abrasive tools. This especially applies to grinding processes, which in terms of processing productivity lag far behind modern processing processes with blade tools. Therefore, solving the problem of significantly increasing the productivity of product processing, while simultaneously ensuring high quality and processing accuracy in finishing operations, should be considered a very important scientific and technical problem. To solve it, it is necessary, first of all, to scientifically substantiate the technological possibilities of using high-performance blade processing methods in finishing operations, and first of all, to theoretically substantiate the conditions for their effective combination with preliminary processing operations and reducing machine time and costs for their implementation, while simultaneously ensuring high precision and high quality processing. That is, it is important to solve the current scientific and technical problem of analytical description from unified theoretical positions of blade and abrasive processing processes in terms of cutting force, energy consumption, and processing productivity. This will allow them to be compared in wide ranges of processing parameters and determine optimal processing conditions that will significantly increase productivity, quality, and accuracy in finishing operations. Lilian on research tasks. The aim of the work is to develop a theoretical approach for determining the components of the cutting force caused by the processes of clean cutting and friction of the workpiece with the rear surface of the cutting tool, and on this basis, to substantiate the conditions for their reduction. To achieve the goal, it is necessary to first theoretically establish the regularities of the process of processing materials by cutting, since traditionally the main issues of assessing the efficiency of metalworking are carried out by conducting experimental studies. This allows us to establish empirical dependencies of the technological main processing parameters, which are valid only for narrow ranges of changes in cutting modes and characteristics of cutting tools. Therefore, as a result of experimental studies, only partial solutions can be established, and to solve the problem of high performance, high quality, and high precision processing, more general theoretical solutions are needed to determine the conditions for reducing the cutting force, energy intensity of processing, and increasing productivity. Therefore, based on these theoretical solutions, it will be possible to identify the potential capabilities of technological processes of blade and abrasive processing, develop highly efficient technological processes for processing high-precision products with high performance and quality indicators. This will allow us to solve the current scientific and practical problem of effectively combining the processes of preliminary and final processing into one technological finishing operation, increasing the productivity of processing and manufacturing high-precision, high-quality engineering products. Lilian on. In short, the main research objectives of the work are: Lilian 1. Performing mathematical modeling of the parameters of the processes of material processing by cutting and determining their potential technological capabilities in terms of ensuring high productivity and accuracy in finishing operations. Lilian. Assessing the reliability of the theoretical solution obtained in the work based on the established results of experimental research. Lilian. 3. Developing effective technological processes for finishing using modern blade cutting tools instead of traditional inefficient abrasive processing processes, including grinding processes, to solve the problem of significantly increasing the processing productivity during cutting. It is necessary to conduct a theoretical analysis of the change in the cutting force under different processing conditions. This is due to the fact that the cutting force is the main physical factor of the cutting process, which determines all technological indicators of the process: productivity, accuracy, cutting temperature, etc. The lower the cutting force, the higher the processing efficiency. Therefore, the analysis of the conditions for reducing the cutting force in the scientific literature has always received considerable attention. However, this applies to experimental methods for studying the cutting force. In the theoretical direction, the cutting force has not been studied enough, which is due to the lack of substantiated analytical dependencies for its determination. Therefore, this work proposes a new theoretical definition of the cutting force. It is based on the calculation scheme for determining the tangential stress arising in the conditional shear plane of the processed material, as shown in the diagram above. The calculations have established that the tangential stress varies according to an extreme dependence relative to the conditional shear angle of the processed material. At the point of extreme maximum tangential stress, the angle is determined from the dependence where is the cutting coefficient are the tangential and radial components of the cutting force. This is a new dependence, on the basis of which it was possible to mathematically approach the determination of the components of the cutting force and the energy intensity of processing in a new way. Calculation diagram of the cutting process parameters: 1. Vance processed material. 2. Vance chips. 3. Cutting tool. Lilian on analytical dependencies for determining the tangential and radial components of the cutting force. The conditional cutting stress processing energy intensity. As a result of the analytical calculations, the following dependencies were obtained. Dependencies 1 and 3 were obtained under the condition of changing the cutting coefficient within wide limits, 0 to infinity, which cover the processes of grinding and processing with cutting tools. Lilian on Ilian major challenges, mechanical processing of materials by cutting, and allows us to compare different cutting processes in wide ranges of changes in processing parameters, and to scientifically substantiate the choice of optimal processing parameters. From the established analytical dependencies 1 and 3, follows the complex nature of the influence of the cutting coefficient on the above parameters. Therefore, for their analysis, we consider the relative parameters. Lilian all theoretical analysis of cutting force. Relative parameters decrease asymptotically respectively to the values, and the angle, on the contrary, increases asymptotically to the value. This corresponds to the failure condition of a rectilinear specimen with a cross-sectional area of the slice during its uniaxial compression. In this case, the tangential component of the cutting force is conditionally equal to the force that leads to the destruction of a rectilinear sample, and the radial component of the cutting force is actually equal to 0, since only uniaxial compression of the sample occurs with the force. Therefore, the obtained solution obeys the laws of resistance of materials. Quantities 1 and 2 cutting coefficient and conditional shear angle of the processed material. The figure shows that the relative parameters decrease with increasing cutting ratio and conditional shear angle of the processed material. This indicates the processing efficiency under condition. Therefore, with an increase in the cutting coefficient, it is possible to significantly reduce the components of the cutting force, and the conditional cutting stress, which is get by its physical nature, determines the energy intensity of the processing. This also indicates the effectiveness of using processing with blade cutting tools instead of the grinding process. Since the cutting process with blade cutting tools is implemented under the condition, and the grinding process is implemented under the condition, the effect is achieved due to the fact that the component of the cutting force under the condition asymptotically decreases to 0. Main ways to reduce cutting force. Based on the obtained calculation results, the following conclusions can be drawn. 1. The effect of processing according to the criterion of the smallest cutting force, is achieved under the condition, that is, as a result of a more significant decrease in the relative value compared to the decrease, true point. Effectively apply processing with blade cutting tools instead of the grinding process. 3. The disadvantage of the grinding process compared to processing with blade cutting tools is a relatively large radial component of the cutting force and insignificant values of the cutting coefficient. This is due to the negative front angles of the abrasive grains of the grinding wheel. Directions for increasing the efficiency of the cutting process. Based on the obtained theoretical solution, it is possible to formulate the main directions for increasing the efficiency of the cutting process. 1. Under the condition, it is possible to solve an important practical problem. To significantly reduce the processing error, i.e., the amount of elastic displacement in the technological system where C is the rigidity of the technological system, N slam, which is a promising direction for implementing high performance and high precision processing of materials by cutting down under the conditions, and it is possible to achieve the lowest values. This leads to the lowest values of the cutting temperature and high processing quality, which is important for the conditions for performing finishing operations. 3. Not a fulfillment of the condition is a cardinal direction in solving the problem of ensuring high performance, accuracy, and quality of material processing in finishing operations. This opens up new possibilities for developing effective technological processes for high performance and high precision processing of materials in finishing operations. Next, we will compare the technological capabilities of grinding processes and processing with blade cutting tools. Relationship between cutting force and machining performance during grinding. Under conditions of the grinding process, the dependencies for determining the components of the cutting force and processing energy intensity 1 and 3 to take the simplified form. As can be seen, it is possible to achieve an increase in processing productivity without increasing the components of the cutting force by increasing the wheel speed and the cutting coefficient. The relationship between cutting force and productivity during machining with a cutting tool. Under the condition, the dependencies 1 and 3 for determining the components of the cutting force and processing energy intensity take an even more simplified form. In this case, the processing energy intensity changes little, and the processing productivity increases proportionally with the increase in the cutting speed. This indicates the efficiency of the high-speed cutting process. At the same time, the cutting speed equally affects the processing productivity, both in grinding and in processing with blade cutting tools. Under the conditions of const, during processing with a cutting tool, significantly higher processing productivity can be achieved compared to the grinding process. Conditions for the effective application of high-speed cutting. It is important to analyze the conditions for the effective use of high-speed cutting. 1. If K is more than 1, then the radial component of the cutting force equals 0, and the friction coefficient become what we can see. This indicates significant technological capabilities of high-speed cutting with blade cutting tools, which are valid both in the conditions of preliminary high-performance processing and in finishing operations. However, for this it is necessary to significantly increase the wear resistance and service life of the cutting blade tool, since with increasing cutting speed its efficiency decreases, as practice shows. In this case, the use of modern prefabricated blade cutting carbide and ceramic tools with wear-resistant coatings is effective. 2. Under certain conditions, for example, during high-speed grinding, it is possible to achieve the same high level of productivity as achieved during processing with modern bladed carbide cutting tools with wear-resistant coatings. Evaluating the correctness of the theoretical solution obtained in the work. To assess the reliability of the theoretical solution obtained in the work, a relationship was established between the cutting coefficient and the chip shrinkage coefficient, which is traditionally established experimentally and allows determining the conditional shear angle of the processed material. As follows from the table, with an increase in the chip shrinkage coefficient, an increase in the chip deformation formed during cutting. The cutting coefficient and the angle uniquely decrease. As shown earlier, this solution corresponds to the condition for the destruction of a rectilinear sample, with a cross-sectional area of the cut during its uniaxial compression, and obeys the laws of resistance of materials. Therefore, despite the fact that the coefficients have opposite effects on the change in the angle, so they uniquely characterize the laws of the mechanics of the cutting process, and the theoretical solution given in the work is consistent with the experimental data. This indicates the possibility of effective application of high-speed cutting with blade tools in finishing operations to increase machining productivity. Results of experimental studies of high-speed milling on a numerically controlled machine tool of the machining center type model Picomax 60 of blind holes made in a cylinder block made of Shake 115 steel. The machining was carried out with an end mill with a diameter of 4.6 millimeters made of 2 hard alloy, with a milling cutter speed N equal 1000, 8000 RPM, cutting depth T equals 0.15 millimeters, circular feed 0.25 millimeters /rev, vertical feed 125 millimeters millimin, and a removable allowance of 0.3 millimeters. The diameter of the machined hole is 10 millimeters, and its depth is 26 millimeters. During the experiments, the values of the following parameters were determined. Deviation from the cylindricity of the hole Y, the roughness parameter of the machine surface R, the number of holes Z machined with one milling cutter, depending on the milling cutter speed N. The experimental values of these parameters are given in the table relative to the change in the milling cutter rotation frequency N. Analysis of the results of experimental studies of high-speed milling as follows from the above table. Under the condition of N 4000 RPM, the deviation from the cylindricity of the hole Y takes a value of less than 0.01 millimeters, and the parameter R 0.6 which meets the requirements for accuracy and roughness of processing. At the same time, with an increase in the number of holes Z processed by one tool milling cutter is constantly increasing. This indicates a decrease in the intensity of wear of the cutting blades of the milling cutter due to a decrease in the thickness of the slices and an increase in its service life. The use of high-speed milling fully meets the requirements of the finishing of the hole and does not require preliminary operations of drilling, boring, and final honing of the hole after drilling, as is proposed by traditional technology. As a result of increasing the milling cutter speed to a value of N 4000 RPM, it was possible to increase productivity by more than 3 times. This allows you to combine the preliminary and final operations into one operation and reduce machine time and costs for their implementation. High processing quality is also achieved. There are no scorching and other temperature defects on the machine surface, which indicates a small temperature that occurs in the cutting zone during processing. The experimental values of the parameters Y, R, Z fully confirm the reliability of the theoretical solution obtained. They indicate the possibility of achieving high performance and high precision machining in finishing operations through the use of high-speed cutting. Conclusions: 1. The paper theoretically and experimentally substantiates the conditions for increasing the productivity and accuracy of material processing by cutting and finishing operations through the use of the high-speed cutting method. 2. It has been mathematically established that the greatest effect from the application of the high-speed cutting method is achieved under the condition of a significant increase in the cutting coefficient reduction in the friction coefficient of the processed material with the cutting tool, with an increase in the cutting speed. 3. It has been established by calculations that with an increase in the cutting coefficient, components of the cutting force take on the smallest values. The radial component approaches 0, then the tangential component is equal to the force at which the destruction of a rectilinear sample occurs under conditions of uniaxial compression. In this case, productivity can potentially increase indefinitely, and the values of the deviation from the cylindricity of the whole of the machining accuracy parameters, which are associated with the elastic properties of the technological system, can significantly decrease. 4. It is shown that under grinding conditions, it is much more difficult to realize this effect than under processing with a blade cutting tool, since as a result of the negative leading angles of the abrasive grains of the grinding wheel, the grinding efficiency under these conditions can be increased by significantly increasing the wheel speed or the abrasive cutting coefficient. 5. A comparison of the experimental values of the chip shrinkage coefficient with the cutting coefficient was carried out, and the reliability of the proposed theoretical solution was established. 6. Experimental studies of the parameters of high-speed milling with a carbide milling cutter on a numerically controlled machine tool of the machining center type model, Pico Max 60, of blind holes with a diameter of 10 millimeters, made in a cylinder block made of Sh115 steel, confirmed the reliability of the obtained theoretical solution. It has been established that within the limits of changing the milling cutter rotation frequency of 4,000–8,000 RPM, the main technological parameters of processing, deviation from the cylindricity of the hole, and the roughness of the machined surface meet the requirements of finishing. The processing productivity is increased by 3 times compared to the traditional technology, which includes labor-intensive processing operations with cutting and abrasive tools, drilling, boring, honing. This shows that high-speed cutting is the most promising method of high performance and high precision processing in finishing operations. Thank you for your time and attention. Your consideration on this presentation is greatly appreciated.
LED screws are often used in various modern mechanisms such as CNC machines and robots. As a rule, they must have a specified accuracy, rigidity, strength, and wear resistance. Loading of LED screws and other threaded parts causes significant stress concentration and non-uniform stress distribution in the thread. There are many studies of LED screws using FEA, but there are not many free and easy-to-use tools for effective multi-parameter optimization of their design according to stress and strain criteria. In addition, the technology of manufacturing of threads has a significant impact on their accuracy and other performance characteristics. The thread profile ceases to be rectilinear and receives a deviation in the profile angle if the rake angle and the angle of inclination of the cutting edge of the threading cutter have a non-zero values. On the other hand, non-zero values of these angles are desirable to increasing the machining productivity. The purpose of this study is to develop scientific principles for building automated FEA tools for modeling and optimizing the design of LED screws and their software implementation. We used open source software to create such a system. This is the Python language with its package and FEA solvers and preprocessors. The code of the developed system can be found on GitHub. Using free software, actor models, and multi-agent approach to optimization, a fair system has been developed that is able to detect the influence of various design parameters and thread cutting tool parameters on stresses and strains and effectively search for their optimal values. The Run PCCX2 module builds a parametric finite element model using pCalculix GMesh Calculix. The OPT41 module describes the classes of multi-agent system, which is designed for multi-parameter optimization of a structure based on stress and strain criteria. The results, maximum equivalent stresses, are stored for further analysis. Ray enables parallel operation of agents. Using pCalculix, it is easy to create 2D model. The coordinates of the non-rectilinear profile, which depends on the parameters of the tool, were calculated using a known analytical relationship. The multi-agent optimization algorithm consists in the fact that many agents working in parallel use different and opposite strategies for finding the minimum. This allows achieving synergy of multi-parameter optimization and approximation methods. The created system allows us to identify the dependency of the maximum stresses in the lead screw on the rake angle and the angle of inclination of the cutting edge of the thread cutter cutting this thread, and to substantiate the rational values of these parameters. A geometric and finite element axisymmetric model is shown here. It is noticeable that the standard ideal profile right is not optimal in terms of stress concentration, and the stresses on the root zone of the nut thread are higher compared to the left. An example of operation a multi-agent system is shown in figures. In this example, two parameters x0 equal gamma, x1 equal lambda are optimized. The minimum found is at the point 0, 0, which is shown by an asterisk. This is expected result if the screw profile curve coincides with the nut profile curve. It is noticeable that the values of gamma and lambda along the front between points 0,5 and 1,0 almost do not change the stresses and they remain relatively low. This algorithm does not guarantee finding a minimum, but the probability of finding one increases with selection of a synergistic combination of different types of agents. Conclusions. The results show that using modern open source software, it is possible to create effective FEA systems that are adapted for automatic multidimensional optimization of LED screws and threaded connection. A modular architecture of an FEA system with parametric axisymmetric screw nut transmission model is proposed for automated study of the stress-strain state of LED screws and design optimization. The use of the actor model and the synergistic multi-agent approach to design optimization allow for effective find minima in multi-parameter function with the lowest computational costs. An example of running a multi-agent system allowed us to identify the dependency of the maximum equivalent stresses in the on the rake angle and the angle of inclination of the cutting edge of the thread cutting tool and substantiate the rational values of these parameters. Increasing the rake angle to 5 degrees causes a more dramatic increase in the stresses compared to increasing the inclination angle to 5 degrees. The software is implemented in Python using free programs and Python packages and published on GitHub, which gives potential for development by a broad community of users. Thank you very much for your attention.
Dear colleagues, good afternoon. My name is Vladimir Zavyalov. Our team, a representative of National University for Technology, Department of Processes and Apparatus of Food Production. Dear colleagues, today our team conduct research in the direction of participle intensification of technological process. One such direction is the scientific substitution of vibration extraction process in the solid liquid system. So the topic of my reports is energy optimization of batch vibroextraction from plant raw material, methodology and experimental vibroextraction. Verification, excuse me. Today, the developed industry under new economics condition is characterized by the development of complex systems with the aim to use rationally vegetable raw materials and process them to largest depths, and by the introduction of waste-free and energy-saving technologies. For the most material-intensive food industries, such as the sugar, pharmaceutical industry, and many others, in which 1 million ton raw materials, these problems are particularly urgent. Is connection with the foregoing one the most efficient methods of the intensification of the extraction process consists in using intensive hydrodynamic regimes. Among now apparatus operated in this regime, vibratory extractors and are the most promotion. This picture, excuse me, vibratory extraction is a relatively new technology process. Its general theory complex is and still in its early stage of development. Therefore, the task was to substitution the influence of low frequency mechanical oscillation generated by the drive system on the energy consumption in the conditions of the vibrating extraction of raw material and established regularities of this change depending on the design and mode parameters of apparatus. Allow me to present the result of our study dedicated to energy optimization of batch vibroextraction from plant raw materials. The objective of this work is to develop a methodology for energy optimization of batch vibroextraction from plant raw materials, ensuring a balance between mass transfer, intensity, and energy costs. The research task include developing and step-by-step engineering methodology for calculating energy consumption, experimentally establishing the dependence of specific power oscillation intensity. Experiments we conduct on laboratory bus vibroextractor with flexible membranes. The working volume is divided into cells by membranes plate oscillating in the vertical plane with amplitude from 5 before 20 millimeters and the frequency from before 10 Hertz. The model system use crystal aluminum sulfate hydrate of standard geometry with a T water system for validation on real plant material. Slide 10 present a detailed description of laboratory bus Vibroextractor. The key decision feature in the flexible membranes plants divided the working volume into cells. During oscillatory motion and alternating pulsating flow of working medium is a general stroke plate perforation providing intensive mass transfer through the cell volume, which is especially important for heterogeneous plant raw materials. A step-by-step engineering conclusion calculated methodology has been developed conveying of all power components. One, mass the mixture displayed by n planes, a function of oscillation amplitude, plate diameter, and mixture density. Two, force required to move the mixture mass, accounting for acceleration in both upward and downward direction. Three, work to displace the mixture by all n planes. Plates, excuse me. Four, power for a mixture displacement plus power for moving and plates and drive assembles. Five, power to overcome hydraulic resistance via local resistance coefficient. And six, total calculated power accounting for drive. This first key result is the dependence of a specific power on oscillation intensity. It was established that oscillation amplitude affects energy cost for more than frequency. Increasing amplitude from 5 before 15 increases specific power by 4 before 5 times. The second key result is the dependence of the dissolution coefficient on consumed power. For each amplitude, there is critical power beyond which further energy consumption does not lead to proportional increase in mass transfer. The optimal working zone amplitude 10 before 15 millimeters, power 20 before 13 watt for 5 liters laboratory apparatus. The specific energy consumption of bus Vibroextraction in the optimal range 7 before 9 Hz, 15 before 20 millimeters is 0.15 before 0.25 kilowatt. It's 35 before 45%, lower than in cross-sonic extraction, and 60 before 70, lower than traditional maceration. For industrial implementation, a three-stage operation mode is recommended. Design parameters number of plates number plates 8 before 12 for volume 50 before 100 liters. The methodology is validated for plant material particle size of 0.5 before 10 millimeters, moisture content 5 before 15%, and laboratory 1 before 5 liters, and per pilot 10 before 50 liter scales. Industrial scale exceeding 100 liters requires additional validation while maintaining geometric similarity. Summary. In conclusion, comprehensive methodology for energy optimization of batch Vibroextraction process has been developed. It has been established that oscillation amplitude is the dominant factor, increasing it from 5 to 15 millimeters raises specific energy cost for before 5 times. The highest energy efficiency 97% is achieved at amplitude 10 millimeters, frequency 7 Hz. The developed conclusion methodology has been validated with an error of less than 8%. Thank you for your attention.
Dear participants of the conference, my name is Alexander Kupriyanov, and I am from Kharkiv, Ukraine. The topic of my presentation is using the order statistics for estimating lower and upper size bounds. During the statistical processing of measurement results for a random variable, such as part size, determining its potential value bounds is of significant practical interest. Knowing the upper and lower bounds values for a given distribution law allows comparison with permission limits, enable a reliable assessment of a quality level of a technological process. For instance, the normal distribution most frequently used in manufacturing assumes that random variable values can be arbitrarily small or large, which is practically meaningless. Therefore, the practical application of such distribution law requires the use of a certain probability level for the random variable to fall within a range. In practice, this results in a major methodological problem. While establishing strict bounds for a random variable values, it simultaneously postulates a certain probability of error. The aims of the research is developing a method for estimating the upper and lower bounds of random variable values which is free from such methodological limitations. Finding distribution functions that satisfy the necessary condition for the existence of the mode of both the last and first order statistics for any bounded random variable enabled the solution of a wide range of applied problems in the field of manufacturing process control chart. The mathematical model is very important here. To achieve estimating the upper and lower bounds of random variables values, it is proposed to use the mathematical apparatus of order statistics. On this slide, you can see distribution dependencies of distribution function, which is necessary condition, is the necessary condition for the existence of the mode of the last order statistics for any bounded random variable. The original function for the bounded distribution on the formula number 1, the probability density function in the formula number 2, and the mathematical expectation on the formula number 3. This formula is depend on the number of part is under name n, and the lower bound x0, and the upper bounds of the function is xb. On this slide, you can see the same distribution functions, but for the first order statistics of any bounded random variable. You can see that they are similar to the last order statistics, is small differences. On this slide, you can see the dependencies of estimation the lower and upper bounds of the bounded random variable. On the formula number 7 and 8, this is the lower and upper bounds. Also, the theoretical range to the relation, the theoretical range to the empirical range of the bounds, and the last two formulas expressed in terms of the empirical range and sample size and as follows. To check the obtained dependencies, we choose the experimental results, experimental paths for field equipment. It's a housing and spool. For the qualities of the matching surface is the tolerance of this mating surface shows here. The measurement were taken on the enterprise, and in this table you can see the results of this measurement. 22 parts of each type were measurement, and the scalar division value is 2 microns. On these diagrams, you can see a distribution of the measurement for housing and spool size. This is very important, and maybe the soil of the research. On this slide, you can see the graph of estimating lower and upper bounds for the size values. The solid line in the bottom depicts the graph of the estimated lower size bounds for batches of part with size from 2 to 22. Estimated can be obtained. The solid line on the top depicts the graph of the estimated upper size bound for batches of part with also from 2 to 22. Estimated can be obtained started from the just two values of the random variable. Therefore, the graphs begin at the values of 2 on x-axis. Subsequently, by scoring additional information in the form of part sizes, the lower and upper bounds are estimated more accurately, converging closer to the smallest and largest sample values. Although the two values are sufficient to obtain estimations of the upper and lower size bounds, such estimates are not sufficiently accurate. The accuracy of the estimate increases with the number of measurements. Estimates based on up to 5 measurements size are not sufficiently accurate. Estimates becomes acceptable in range of from 5 to 15 measurements and becomes sufficiently precise after 15 measurements. Therefore, in practice, it is recommended to estimate in batches of 10 pieces. This is a significant advantages of the proposed methods, as classical statistical methods typically requires more measurements. The obtained estimates for the upper and lower bounds of size values can find wide application in production. One obvious application is the construction of control charts with regulation limits for the production process. In this case, bounds for size values can be continuously calculated using a moving sample of, for example, 10 measurements. If a bound exceeds the regulation limits, a decision can be made to intervene in the production process. The development of control charts based on the proposed mathematical framework requires future research. Attention should be drawn to a limitation when the using of other statistics for estimating the upper and lower bounds of size values. Although the distribution law of the part size can be arbitrary, it shall be bounded and unimodal, meaning it has a single extremum. You remember that on the diagrams, the diagrams show that the example has single extremums. For the manufacturing tasks, which is unlikely to be an overly restrictive limitation. Conclusions. The paper investigated a new mathematical apparatus for estimated upper and lower bounds of the sample size of parts based on the first and last order statistics of the limited unimodal random variable without using confidence intervals of the reasoning. As a result of the research, distribution functions were found with the necessary conditions of existence of the mode of the last and first order statistics for any bounded random variable. The distribution of the last order statistics for the mode of the largest value in a sample of size n follows a normal distribution law. Lower and upper bounds have been derived from a sample from a bounded unimodal distribution of a random variable. These dependencies have been established that allows determining the lower and upper bounds of a random variable values without requires additional confidence probabilities for these values or knowledges of a specific distribution. The relationship between the theoretical range and empirical range through the sample size were determined, which allows for the required sample size to be defined based on given accuracy. The theoretical range equals 3 times the empirical range for the sample size of 2. As a sample size increased, the empirical range converges to the theoretical range. The obtained results enable via use for construction control charts with the regulation limits in production process quality control. The application of these results allow for solving practical problems related to extreme values for a given sample size. Practical validation of the obtained dependencies was conducted using the example of statistical processing the measurement results for field equipment part size. Practical application has demonstrated the significant practical benefits of the proposed dependencies. Upper and lower size bounds are relatively easy to determine. Thank you for your attention. I am ready for your question.
The scientific work presented in the article. Factors influencing the effectiveness of training agricultural engineers in the process of forming their professional competence was developed by a team of authors consisting of doctors of sciences: Oleksandr Daman, Gana Romanova, Leonid Romanov, Svetlana Zagorska, and Natalia Kulilayeva. Today, the transition of Ukraine to a competency-based paradigm in higher education involves a significant increase in training efficiency. As highlighted on the slide, the formation of professional competence for our agricultural engineers currently takes place under the extreme and challenging conditions of a prolonged military conflict. Therefore, it is crucial to analyze the driving forces and circumstances that directly shape the quality of this process. The importance of each individual factor and their combined cumulative impact are precisely what require thorough and careful scientific research, which we aim to present today. The purpose of the article is to determine the main factors that affect the effectiveness of the professional training of engineers of the agricultural sector, in order to further increase the level of formation of their professional competence. To achieve the goal, the following tasks were performed. Our research was conducted in 5 key stages. First, we identified the groups of factors that influence the effectiveness of agricultural engineers' professional training. Second, we isolated the main influencing factors within each of these groups. Next, a Google form was developed to survey our respondents. We performed the preprocessing of the survey results and constructed the corresponding histograms. And finally, we carried out the ultimate systematization of the obtained empirical data. Analyzing agricultural education and market trends, we classified the influencing factors into 4 main blocks. To evaluate them, we launched a targeted Google Form survey among our students. This slide highlights Block 1, which covers the educational process. Instead of reading the points, I would like to emphasize these internal factors, ranging from modern curricula and tech-driven teaching to hands-on internships and independent research skills, form the core foundation of a student's professional competence. Moving forward with our findings, a total of 368 respondents took part in this study, allowing us to evaluate the remaining internal factors. As you can see on the screen, Block 2 focuses on the scientific and pedagogical staff. The survey clearly highlights that the teacher's role extends far beyond traditional lecturing. Students highly value mutual respect, engaging and accessible presentation of material, and a teacher who stays constantly updated with the latest technological and scientific achievements. Next, Block 3 represents the personality or subjective block. It reflects the core personal traits that a student should develop during their professional training. Rather than reading the text, I would like to stress that our respondents prioritize 3 intellectual pillars: critical thinking, the ability to express thoughts logically, and crucial for future engineers, the capacity to think outside the box in technical aspects. Through our analysis of development trends in agricultural education and the domestic agro-industrial complex, we classified the key influencing factors into 4 distinct blocks. First, we identified one external block, which captures the social and motivational aspects. Alongside this, our research focused on 3 internal blocks, namely the educational process, the quality of the scientific and pedagogical staff, and finally, the subject block, which relates directly to the student's personal development. As a result of our comprehensive study, we developed the general framework that you can see on this slide. It illustrates the structured system of factors influencing the competence-oriented training of agricultural engineers. As the chart shows, the factors reflecting the educational process emerged as the top priority for our respondents. Leading the ranking, the most critical factor for students is ensuring that academic disciplines meet the modern requirements of their future specialty, chosen by 61%. Sharing the second place are two facts simultaneously, both at 52%. The use of modern teaching technologies and the provision of professional and industrial internships at specialized enterprises. Ranked third, we see the factor of utilizing modern methods and means of organizing education, which garnered 35%. Finally, fifth place, our respondents placed the development of the ability to independently find necessary professional information, at 29%. Our respondents ranked the scientific and pedagogical staff as their second top priority. The distribution of these factors highlights a very clear leader. With an overwhelming majority of 93%, students emphasize the teacher's ability to explain the material in an interesting and accessible way. In second place, with 82%, is the fundamental requirement to treat students with respect. And finally, 40% of respondents noted the importance of a teacher constantly staying up to date with modern professional technologies. This data clearly shows that pedagogical mastery and communication skills are highly valued by today's students. Finally, our respondents ranked the subject block, or personal qualities, as their third priority. As shown in the histogram on this slide, the factors are distributed as follows. Leading this block with 65% is the ability to engage in non-standard technical thinking. In second place, the capacity to logically express an opinion garnered 56%. And thirdly, critical thinking was highlighted by 40% of the surveyed students. These findings underline that future agricultural engineers strongly recognize the value of cognitive and creative flexibility alongside their technical training. To draw meaningful conclusions, we applied a Pareto diagram analysis, which you can see on the screen. This approach allowed us to hierarchically rank the primary macro factors driving the effectiveness of agricultural engineer training. As illustrated, the cumulative impact is distributed across three pillars: the educational process at 48%, the scientific and pedagogical staff at 33%, and professionally significant qualities at 19%. The clear dominance of the first block highlights an urgent need to update course curricula and systematically organize internships within leading agricultural companies. The position confirms that we must reevaluate and elevate teacher competence standards to match current market demands. Finally, the third place suggests that respondents generally view the current system's capacity to develop core personal qualities as sufficient. This Pareto distribution provides us with a clear roadmap for targeted educational reforms. To conclude, I would like to highlight the core essence of our findings. The ultimate value of this research lies in proving that the synergy of these identified and ranked factors directly ensures the adaptability of future agricultural engineers to the rapid technological modernization of the agro-industrial complex. To systematically enhance the quality of training, our strategic focus must be on three main pillars. First, continuously updating the content of educational programs to match industrial changes. Second, integrating innovative learning technologies into the curriculum. And third, providing mandatory professional industrial internships at leading enterprises, while strictly monitoring the development of graduates' competencies. We believe that this holistic approach is the key to elevating the quality and resilience of professional training for the next generation of engineers. Thank you very much for your attention.
Distinguished chairs, dear colleagues, ladies and gentlemen, good day. It is my honor to present on behalf of the co-authors from Sumy State University our recent investigation entitled Peculiarities of Magnetoresistive Properties of the Medium-Entropy Alloy Iron Nickel Cobalt Copper with a non-equiatomic composition. My name is Yuri Volk. I'll be conducting this presentation on behalf of our authors collective. In the next 12 minutes, I shall outline the motivation, the methodology, the principal results, and the main conclusions of this work, and shall be pleased to address your questions afterwards. I shall begin with the specific context and the principal challenges that motivate this study. Conventional metallic alloys are built around one principal element with a small number of additions. Such systems are thermodynamically unstable and tend to undergo phase transformations upon heat treatment, which compromises their operational properties. Over the past decade, an alternative design paradigm has emerged: high-entropy alloys, which contain 5 or more elements in approximately equimolar ratios, and which stabilize simple-phase center-cubic or body-center-cubic solid solutions on account of their high configurational entropy of mixing. More recently, non-equiatomic compositions have attracted considerable attention since they widen the accessible compositional space and permit deliberate optimization of catalytic, magnetic, electrical, and magnetothermal characteristics. Within this rapidly expanding field, however, the magnetoresistive properties of iron-nickel-cobalt-based medium-entropy alloys in thin film form remain insufficiently characterized. The central scientific question that motivates the present work is therefore the following: how does the fraction of non-magnetic copper in the system, iron-nickel-cobalt-copper, govern the crystal structure and the magnetoresistive response across thicknesses and temperatures relevant to device applications? Let me now state the aim of the work and the specific research tasks that it comprises. The aim of the work is to establish, in a systematic and quantitative manner, the influence of 3 independent factors: copper content, film thickness, and measurement temperature, on the magnetoresistive properties of the medium-entropy thin-film alloy iron-nickel-cobalt-copper. To achieve this aim, 4 research tasks have been defined. First, to fabricate the films with total thickness ranging from 30 to 100 nanometers by means of vacuum thermal treatment of multilayer iron-nickel-cobalt-copper structures. Second, to characterize the crystal structure, the phase composition, and the elemental distribution by transmission electron microscopy, electron diffraction, secondary ion mass spectrometry, and energy dispersive X-ray analysis. Third, to measure the longitudinal and transverse magnetoresistance as functions of the applied magnetic field, of the film thickness, of the temperature, and of the copper content. And fourth, to interpret their observed dependencies within the framework of anisotropic magnetoresistance and with reference to the saturation, magnetization, and the magnetic anisotropic constant of the alloy. I shall now describe the experimental methodology in 2 parts: sample fabrication and characterization. Allow me now to outline the experimental methodology. The medium entropy films were not obtained by direct co-deposition. Instead, we used a 2-stage route. In the first stage, a multilayer structure of the form iron, nickel, cobalt, and copper repeated n times on a glass substrate. It was deposited in a vacuum chamber at a residual gas pressure of 10 to the minus 4 Pascal. Copper was evaporated from a tungsten ribbon, while equiatomic iron nickel and pure cobalt were evaporated by an electron beam gun. Each layer thickness was monitored in situ by a quartz crystal resonator with a measurement uncertainty of plus or minus 5%. In the second stage, the as-deposited multilayer was thermally stabilized at 700 Kelvin for 30 minutes under ultra-high oil-free vacuum of order 10 to the minus 6 to 10 to the minus 7 Pascal. These conditions were not chosen arbitrarily. They emerged from a screening matrix of temperatures from 500 to 900 Kelvin and durations from 15 minutes to 1 hour, and they correspond to optimum balance between complete homogenization on the one hand and the suppression of secondary phase formation and excessive grain growth on the other. The base iron-nickel-cobalt alloy had composition of 1/4 iron, 1/4 nickel, and 1/2 cobalt. while the copper fraction X was varied between 0.1 to 0.5. We come now to the experimental results, which I shall present in 3 blocks: microstructure, elemental homogenization, and magnetoresistance. The first set of measurements concerns the crystal structure and the phase composition of the thermally stabilized films. On the right-hand side of the slide, you see in 3 pairs the bright field transmission electron microscopy images and the corresponding electron diffraction patterns recorded for 40 nanometer films at 3 representative copper fractions, 0.5, 0.2, and 0.1. 2 observations follow. First, all of the compositions studied are polycrystalline, with mean grain sizes in the range of 10 to 50 nanometers. That is, in the generally nanostructured regime. Second, the diffraction patterns exhibit a set of rings whose interplanar spacings are consistent with a single face-centered cubic phase, identified through the indices 111, 200, 220, and 311. The corresponding lattice parameter, refined from these rings, lies between 0.357 and 0.358 nanometers, and it is essentially independent of the copper fraction within the range studied. We therefore conclude that all of the films, irrespective of the composition, are single-phase FCC solid solutions of iron, nickel, cobalt, and copper, in agreement with previous results in the literature. The picture obtained from electron microscopy is complemented by 2 further results, shown on this slide. On the left-hand side, the mean crystallite size, denoted L, is plotted as a function of the copper content for 2 total thicknesses, 80 nanometers curve 1 and 40 nanometers curve 2. In both cases, the grain size grows with increasing copper fraction up to a value of approximately 0.3 and then saturates. This trend reflects the dominant role of diffusion-driven recrystallization during the 700 Kelvin anneal. Copper, being a slow diffusing species in this matrix, promotes the development of larger crystallites until the structure becomes sufficiently homogeneous and grain growth is no longer favored. On the right-hand side, the depth resolve concentration profile, measured by secondary ion mass spectrometry for the iron-nickel-cobalt 0.6, copper 0.4 composition, demonstrates that the normalized concentration of cobalt, copper, nickel, and iron remain essentially constant across the film depth, within a narrow band between 0.85 and unity. We may therefore state with confidence that the thermal treatment results in complete intermixing of the constituent atoms, and that no residual compositional gradient remains from the original multilayered geometry. I now turn to the magnetoresistive measurements, which constitute the central experimental result of this work. Panels A and B of Figure 4 present the relative change of resistance against the external magnetic field induction for the iron-nickel-cobalt 0.8, copper 0.2 composition, with a thickness of 40 nanometers at 300 and at 100 Kelvin respectively. In every measured curve, the longitudinal magnetoresistance is positive and exhibits a minimum in the vicinity of zero field, whereas the transverse magnetoresistance is negative and exhibits a maximum at the same point. Both curves show a pronounced magnetoresistive hysteresis. This combination of signs and shapes is the canonical signature of anisotropic magnetoresistance, traceable to the spin-orbit interaction. Figure 5 shows the size dependence. As the film's thickness grows from 20 to 80 nanometers, both the longitudinal and absolute transverse magnetoresistance increase monotonically, reaching approximately 0.8 and 1% at room temperature. It is worth noting that the well-known Néel-to-Bloch domain wall transition, which is in pure ferromagnetic films produces a local extremum near 55 to 65 nanometers, is not observed here. This feature is most probably shifted to larger thicknesses by the non-magnetic copper component. The complementary part of the magnetoresistive study examines the dependence of the effect on temperature and or on copper content. Figure 6 on the left shows the temperature dependence between 120 and 400 Kelvin. The magnetoresistance decreases by a factor of 2 to 5 with rising temperature. This is the natural consequence of the simultaneous decrease of the saturation magnetization and of the magnetic anisotropy constant with temperature. Figure 7 on the right presents the dependence on copper fraction at 300 Kelvin for a 40 nanometer film. Both the longitudinal and the absolute transverse magnetoresistance decrease nearly linearly with increasing copper content. The maximum magnetoresistance is therefore reached at the lowest copper fraction, where the longitudinal component is approximately 0.8% and the absolute transverse component reaches 1%. Both trends are again consistent with a reduction of the saturation magnetization, caused by a dilution with the non-magnetic copper component. Allow me finally to summarize the principal conclusions of the work. First, all of the thermally stabilized films with copper content up to 50 atomic percent are polycrystalline, with grain sizes in the 10 to 50 nanometer range, and they form a single-phase FCC solid solution with a lattice parameter between 0.357 and 0.358 nanometers. Second, anisotropic magnetoresistance is a generic feature of this medium-entropy alloy, with a positive longitudinal and a negative transverse component, and absolute values between 0.1 and 1%, depending on copper content, thickness, and temperature. Third, the maximum magnetoresistance is reached at the lowest copper fraction studied, namely 10%, and at thickness of 80 nanometers, where the longitudinal component approaches 1% and the absolute transverse component reaches approximately 1.2% at room temperature. Fourth, the magnetoresistance falls by a factor of 2 to 5 upon heating from 120 to 400 Kelvin, which is consistent with the reduction of the saturation magnetization and of the magnetic anisotropy constant. Fifth, the magnetoresistance decreases nearly linearly with increasing copper fraction, an effect attributable to the dilution by the non-magnetic component. From practical standpoint, these results suggest that by appropriately tuning the fraction of magnetic atoms, it should be possible to obtain multi-component thin film alloys with relatively low coercive force and saturation field, which is attractive for sensor and spintronic applications. Before concluding, I should like gratefully to acknowledge the financial and institutional support of the partners listed on the slide that made this work possible. I thank you for your kind attention, and I should now be very pleased to address any questions, comments, or suggestions you may wish to raise. My contact details are displayed on the slide, and I remain at your disposal for further discussion.
Dear colleagues, my name is Andriy Brels, and today I would like to present our work entitled Plasma-Driven Synthesis of Copper-Nickel Oxide Nanostructures in Copper Surfaces. This work was performed at National Aerospace University in Kharkiv, Ukraine. Let me begin with general context and motivation of this research. Copper oxide nanostructures attract considerable scientific and technological interest because they combine low cost, chemical stability, and useful semiconductor properties. Such materials are actively investigated for applications in gas sensing, catalysts, photocatalysts, electrochemical energy conversion, and energy storage system. At the same time, it is well known that the functional performance of oxide nanomaterials strongly depends on their morphology, dimensionality, surface area, and defect structure. Plasma-assisted synthesis is especially active for nanostructure fabrication because plasma provides a high non-equilibrium environment with energetic ions, reactive spices, and localized heating. This enables rapid oxide growth without catalyst or multi-step chemical proceedings. However, hollow cathode discharges are inherently a non-uniform system. In such discharges, plasma density, ion flux, and thermal load vary strongly and radial direction. As a result, different ranges of same sample may experience completely different growth conditions. The key scientific question in our work was therefore the following. Can the unrestricted plasma non-unfolding of hollow cathode discharge be used as a controllable mechanism for creating specialty graded oxide nanostructures? The aim of this work was to investigate how the
Especially non-uniform environment of a nickel hollow cathode oxygen discharge influence the formation, morphology and composition of mixed copper-nickel oxide nanostructures on copper substrates. To achieve this aim, we formulated several research tasks. First, we synthesized oxide nanostructures on copper samples exposed to oxygen plasma inside a nickel hollow cathode. Second, we analyzed radial evolution of morphology using scanning electron microscopy. Third, we determined the elemental composition of the plasma growth layer using EDS analysis. And finally, we correlated the observed morphologies with the expected radial distributions of ion flux and thermal load inside the hollow cathode plasma. We also formulated two hypotheses. The first hypothesis was that radial plasma gradients impose a predictable sequences of nanostructure growth requirements. The second hypothesis was that nickel eroded from the hollow cathode participates directly in the formation of mixed copper-nickel oxide structures. Now, I will briefly describe the experimental methodology. The synthesis was carried out in cylindrical stainless steel vacuum chamber. A graphite cathode supported a copper sample placed at this center. A thin nickel hollow cathode structure was positioned directly above the copper substrate, while a graphite anode was located along the chamber axis. Oxygen was introduced into the chamber and a glow discharge was generated between the electrodes. The hollow cathode geometry created strong plasma confinement and pronounced radial non-uniformity. The discharge was operated at an oxygen pressure of 280 pascals with voltage of 540 volts and current of 0.80 amperes. The treatment duration was 30 minutes. During processing, the copper substrate temperature reached approximately 540 degrees Celsius, while the nickel hollow cathode reached nearly 918 degrees Celsius. After plasma treatment, the samples were cooled under vacuum and then characterized using SEM and EDS. Now let's move the experimental results. SEM analysis relevated the formation of continuous but strongly non-uniform oxide layer across the copper surface. The morphology changed systematically and from the sample edge toward to the discharge axis. At the peripheral region, which corresponds to point 1, we observed the dense arrays of elongated filamentary nanostructures. These structures had lengths between approximately 8 and 15 micrometers, with expected ratios reaching values up to around 18. Moving towards the center, the structures became progressively thicker, more branched, and partially coalescent. In the intermediate regions, we observed shorter columnar structures with lower aspect ratios. Finally, near discharge axis, the morphology transformed into a compact nanocrystalline oxide layer composed of agglomerated grains with size approximately between 80 and 200 nanometers. Therefore, the morphology evolved continuously from anisotropic nanowire as a periphery to defense regularized oxygen aggregates at the center. This transition occurred over radial distance of only about 2.5 millimeters. The observation can be explained by the radial plasma distribution inside the hollow cathode discharge. At the sample periphery, the plasma energy density and ion bombarded are moderate. Such conditions for kinetically controlled atmospheric growth which promotes the formation of long oxide filaments. Closer to the charge axis, both ion flux and local heating increase significantly. Under these conditions, surface diffusion and regularization become dominant. As a result,
in immediately anisotropic nanostructures gradually thicken, merge, and finally transform into compact oxide layers. Thus, the observed morphology directly reflects the spatial plasma distribution. EDS analysis confirmed that the synthesized layer contains oxygen, copper, and nickel. The measured composition was approximately 45.5 atmospheric percent oxygen, 28.9 atmospheric percent copper, and 23.2 atmospheric percent nickel. These results confirm that nickel from the hollow cathode is actively transferred to the copper substrate during plasma processing. Therefore, the plasma doesn't simply oxidize copper, but instead creates mixed copper-nickel oxide nanostructure. The oxygen-rich composition is consistent with the formation of nickel oxide and copper oxide phases. Our results are also consistent with the previously reported studies on plasma-assisted oxide growth. Earlier works demonstrated that plasma-assisted oxidation of copper strongly depends on ion bombardment, local heating, and plasma density. The formology transition observed in our experiments agrees with these establishment mechanisms. At the same time, our work extends exciting knowledge because we demonstrate that hollow cathode plasma non-uniformity itself can be used as a tool for engineering specialty-graded oxide nanoarchitectures in a single technological step. Of course, this work also has several limitations. The study mainly focuses on morphological and compositional characterization, directs the plasma diagnostics such as the measurements of electronics density, ion energy distribution, and reactive oxygen species concentration were not performed. Therefore, the plasma conditions were inferred indirectly from the observed morphology evolution. Future work should be combined SEM and DS analysis with detailed plasma diagnostic and in situ growth monitoring. Finally, let me summarize the main conclusions. We demonstrated that nickel hollow cathode oxygen discharge enables one-step synthesis of mixed copper-nickel oxide nanostructures on copper substrates. The radial plasma non-uniformity creates a reproducible morphology gradient ranging from high aspect ratio nanofilaments and dense nanocrystalline oxide layers. The transition is governed by increasing ion flux, thermal load, and surface diffusion towards the charge axis. EDS analysis confirms the nickel eroded from the hollow cathode participates directly in the formation of mixed nickel oxide and copper oxide structures. Overall, the results show that hollow cathode plasma can be used as a controllable reactor for fabrication of specialty graded functional oxide surfaces for future sensing, catalytic, and electrochemical application. Acknowledgement. Project funded by the Ministry of Education and Science of Ukraine and NATO Science for Peace and Security Program. Thank you very much for your attention.
Improving energy efficiency of a milk jet homogenizer. Alexander Kovalov, Alexander Lameyka, Dmitro Motorny, Tavria State Agro-Technological University, Vitaly Koshulka, Oleg Tertishny, Dnipro State Agrarian and Economic University, and Natalia Slivka, Stepan Gzhitsky, National University of Veterinary Medicine and Biotechnologies, Lviv. Introduction and major challenges. Ukraine's integration into the European economic space requires increasing the energy efficiency of domestic industry, especially in the machine building sector, which is currently in critical condition. Energy costs at Ukrainian enterprises are significantly higher than in European countries. making energy saving an important factor for economic development. In the dairy industry, one of the most energy-consuming operations is homogenization, which is necessary for obtaining a stable milk emulsion and improving product quality. The most common equipment used for this process is wall homogenizers, which ensure the required size of fat globules but consume more than 8 kW of energy per ton of product. Existing alternative homogenizers either also require higher energy consumption or cannot provide the necessary homogenization quality. Modern research shows that efficient dispersion can be achieved by creating a high-velocity difference between skim milk and cream phases. Jet homogenizers, based on this principle, reduce energy consumption by 5 to 8 times compared with wall homogenizers, although their homogenization efficiency still requires improvement. Aim and research tasks. In recent years, several energy-efficient homogenizer designs have been developed, reducing energy consumption by 3 to 4 times, although the resulting fat globule size remains relatively high. To further decrease energy use, researchers proposed a method based on maximizing the velocity difference between milk phases and supplying them separately, which led to the development of jet-type homogenizers. One design created at Metromotorny Tavria State Agri-Technological University injects cream into milk through slot channels, but it provides insufficient homogenization quality due to inaccurate dosing and uneven hydrodynamic action. Other designs improve cream ejection using slot gaps, confusers, diffusers, or movable elements, yet some still require high pump pressure, cannot fully ensure the required product quality. Another promising approach involves counter-current feeding of cream and skim milk, which improves fat globule dispersion and allows accurate control of fat content. Therefore, the purpose of this study is to investigate the energy consumption and quality performance of an improved jet slot milk homogenizer in order to achieve higher energy efficiency and product quality that meets technological standards. Research methodology. An important stage of the analytical study was the selection of a methodology capable of providing reliable data on the main dispersion parameters of the jet slot milk homogenizer. The main factors influencing the energy efficiency of the system were identified as the annular slot width and the fat content of the cream. Analytical calculations showed that the optimal slot width ranges from 0.1 to 0.9 millimeters, since smaller values reduce productivity, while larger values increase the size of fat globules after processing. Experimental studies were therefore conducted at slot widths of 0.1, 0.5 and 0.9 millimeters. The fat content of cream was selected within the range of 10 to 50% based on the operating experience of similar homogenizers. Lower fat content increases specific energy consumption because of higher feed rates, whereas cream with fat content above 50% requires additional homogenization stages and causes excessive energy use. The design solution of the homogenization chamber, according to the proposed method, is shown in the figure. Initially, milk is separated in a cream separator to obtain milk plasma and fat phase, cream. Then skim milk is supplied by a metering pump into the central channel of the jet homogenizer, which provides separate cream feeding. The channel profile creates a zone of maximum constriction. In the middle part of the central channel, cream is injected into the skim milk flow through special channels using a feed pump. Due to the counter-arrangement of cream feed channels, cream enters as an annular flow directed opposite to the main flow. The studies were performed on a laboratory prototype of a jet slot milk homogenizer with a modernized homogenization chamber according to the scheme shown in figure. After switching on the packet switch, a high-velocity flow of the dispersion medium is supplied from tank by the drive of motor and pump. This is ensured by coordinated throttling of valves and using the pressure-reducing valve. Under high pressure monitored by gauge, the dispersion medium is directed to the central part of the homogenizing unit, which represents the zone of minimum flow cross-section. In this zone, forming an annular slot between the end surfaces of the confuser and diffuser, a specified amount of dispersed phase, cream, from tank is added. Its supply is regulated by motor, metering pump, and valve. The required dispersion effect, homogenization of milk fat, is achieved by ensuring the calculated sliding velocity of fat globules relative to the milk plasma, creating the necessary Weber number values. After processing, homogenized milk is discharged through pipeline. Results. Typical fat contents of 3.2% for milk and 20% for cream were used during the analytical calculations. The required velocity of skim milk was determined using the Weber criterion, taking into account surface tension, milk density, and slot homogenization conditions. The geometric parameters of the homogenization chamber and the annular slot width were also calculated, with the adjustable slot range selected as 0.1 to 0.9 mm and the base value set at 0.6 mm. Analytical expressions were additionally obtained for determining cream feed velocity, excess pressures, and the power required for skim milk and cream supply pumps. The power dependencies of skim milk and cream feed pumps, as well as total power on skim milk flow rate, exhibit an approximately linear character. At 1000 liters per hour and height 0.6 mm, the skim milk pump power exceeds the cream pump power by 6 times. Compared to the base jet slot homogenizer, where this dependence is hyperbolic and the ratio reaches 8, the modernized design demonstrates improved energy distribution. Experimental results confirmed analytical calculations, with measured values exceeding theoretical predictions by 5 to 12% due to mechanical losses in pump drives. The results show that achieving the required technological dispersion is possible with the minimum slot width and cream fat content of 50%. The best dispersion is observed at height 0.1 mm due to high sliding velocity over most of the cream jet cross-section. However, reducing slot width significantly increases energy consumption, requiring further optimization. Overall, the modernized jet homogenizer demonstrates energy consumption comparable to the base design, with a 5 to 10% potential for further reduction through optimization. At the same time, the average fat globule diameter decreases by 5 to 7%, while ensuring accurate cream dosing and uniform supply. Analytical studies confirmed the possibility of further increasing energy efficiency through modernization of a jet milk homogenizer with separate cream feeding. The results demonstrate improved product quality achieved by upgrading the base design and installing metering pumps for cream supply. The energy consumption of the proposed homogenizer is approximately equal to that of the base design. However, there remains a reserve for further reduction through parameter optimization. A research methodology was substantiated and analytical expressions were obtained for determining skim milk and cream feed velocities, pressures, and pump power. It was established that at a capacity of 1000 liters per hour, the power of the skim milk feed pump exceeds that of the cream feed pump by a factor of 6, which was confirmed experimentally. Experimental data allowed constructing the dependence of average fat globule diameter on slot width and cream fat content. Conclusions. The results show that achieving technologically required dispersion is possible at minimum annular slot width. However, due to increased energy consumption, determining the optimal value requires further research. A cream fat content of 50% was identified as optimal, although this parameter also requires optimization considering all conditions in the annular slot zone. The modernized design demonstrates approximately the same power consumption while reducing the average fat globule diameter by 5 to 7% compared to the base version, confirming the feasibility and prospects of the proposed modernization for further energy efficiency studies. Thank you very much for your attention.
Dear participants of the 9th International Conference on Design, Simulation, Manufacturing, the Innovation Exchange DSMIE-2026, let me to present to your attention a report on the topic Justification of Nozzle Parameters of a Counterjet Homogenizer for Emulsion Preparation. The preparation of fine dispersed emulsions is widely used in many industries, including mechanical engineering, agriculture, the food industry, cosmetology, pharmaceuticals, and the chemical sector. In the food industry, such emulsions are essential for producing milk, cream, ice cream, sauces, and other products. The most common method is higher pressure homogenization using a valve seat design, which provides particle sizes of about 1 micrometers. However, this method is characterized by high energy consumption, 7-8 kilowatt-hour per ton, which significantly increases production costs. This issue is particularly important in the dairy industry, where milk is a typical fat in water emulsion, leading to additional costs of up to €200 million per year in Europe. Therefore, there is a need to develop more energy-efficient homogenization methods. One promising approach is counterjet homogenization with coaxial nozzle arrangement. The main objective of this study is to investigate the influence of nozzle arrangement on the quality of milk emulsion. To achieve this objective, the following tasks were defined: to determine the effect on the angle between the nozzles on the degree of homogenization and verify it experimentally; to investigate the influence of the distance between nozzle outlets on homogenization quality; to examine the dispersion characteristics of the obtained milk emulsion. An experimental sample of a counterjet homogenizer was developed at the Dmytro-Motorny Tavria State Agri-Technological University, which is shown in this slide. The device is made in the form of a welded frame, in the lower part of which a rotary pump is located, and in the upper part the working chamber with installed nozzles, which are mounted in the adjustment units by a hinge method. The connection of the nozzles with the pump is carried out by means of hydraulic hoses. Pressure control in the system is provided by the manometric head. The nozzles are equipped with conical inserts with a cone angle of 49 degrees and interchangeable nozzle outlets. During the experiment, milk was supplied under controlled pressure to the nozzles, where opposing jets were formed. At the point of their collisions, intensive dispersion of fat globules occurred, after which the processed milk was discharged by gravity. The experiments were carried out at a temperature of 65 degrees Celsius with a nozzle diameter of 1 millimeter and a coaxial nozzle arrangement. It was established that maximum efficiency is achieved when using conical inserts with a cone angle of 49 degrees. Each experiment was conducted in triplicate. Statistical analysis included Cochrane tests, Student's t-test, and Fisher's test at a significance level of 0.05. The results were evaluated by determining the degree of homogenization, standard deviation, and fat globule size, as well as by microscopic analysis of the emulsion structure. The reliability of the results was confirmed by a coefficient of determination of at least 0.95. This slide shows the influence of the angle between the nozzles on the degree of milk homogenization at a pressure of 6.5 megapascal and a temperature of 65 degrees Celsius. According to the analytical results, the maximum homogenization degree is achieved at an angle of 180 degrees, which corresponds to a coaxial nozzle arrangement. The experimental data confirm this dependence and are in good agreement with the theoretical model. The coefficient of determination is 0.95, indicating a higher reliability of the results. Thus, the optimal configuration of the homogenizer is the coaxial arrangement of the nozzles. This slide shows the influence of the distance between the nozzle outlets of the degree of homogenization at different pressures. As can be seen with an increase in the distance, the degree of homogenization first increases, reaches a maximum, and then decreases. The optimal distance is in the range of 7 to 12 millimeters. This is explained by maximum pressure and jet collision intensity and the optimal distance, while further increase leads to energy losses and reduced efficiency. With increasing pressure, the shape of the curves remains the same, but the maximum shifts toward larger distances. This slide shows the influence of excess pressure on the degree of homogenization at different inter-nozzle distances. The experimental results follow the same trends as the theoretical model. The degree of homogenization increases with increasing pressure. However, in practice, the values are slightly lower due to energy losses after the jets exit the nozzles. At low pressure, a nonlinear behavior is observed, which is explained by insufficient energy for fed global breakage and the possibility of their re-adhesion and agglomeration. Thus, increasing pressure improves homogenization, but real conduction must be taken into account. This slide shows microphotographs of milk before and after counter-jet homogenization. After processing, fat globules become smaller and more uniformly distributed, with the average diameter decreasing from 2.49 micrometers to 0.83 micrometers. The degree of homogenization reaches 3.4, 3.5, indicating high dispersion quality. Compared to Wolf-type homogenizers, efficiency increases by 12%, while energy consumption is reduced by about 30%. The productivity of the equipment is 2,000–2,500 kilograms per hour, which meets industrial requirements. The conducted analysis of the existing homogenizing equipment made it possible to distinguish a promising and efficient type of apparatus, counter-jet homogenizers. The structural features of this homogenizer ensure the formation of conditions under which, during the collision of jets existing from two coaxially arranged nozzles, intensive dispersion of the emulsion occurs. The results of the experimental studies showed that in order to achieve the highest degree of homogenization, 3.4, 3.5, the use of conical narrowing inserts with a cone angle of 49 degrees and their coaxial arrangement is required. The conducted studies showed that for each volume of excess pressure, there exists an optimal distance between the nozzles, which ensures the highest degree of homogenization, 7 to 12 millimeters. The results of the experimental studies also demonstrated that after milk treatment in the counterjet homogenizer, the degree of homogenization increased by 12% compared to the values obtained during homogenization in a valve-type device, while the energy consumption in the presented homogenizer was 30% lower. In addition, a decrease in the value of dispersion was recorded, which further confirms the higher quality of the emulsion after the counterjet method of homogenization. Thank you for your attention.
Hello everyone, I want to present my article on the topic Synergistic effects of geometrical parameters and material selection on the mechanical performance of FDM 3D printing components. FFF and max additive manufacturing technologies are increasingly used for producing lightweight polymer components with a complex international geometries. However, the mechanical performance of these parts strongly depends on both the selected material and the shape of internal openings. This study focuses on understanding how these factors influence tensile behavior and structural reliability. One of the main challenges in FDM printing is the interaction between material properties, geometry, and stress concentration effect. Smooth geometry are expected to distribute stress more uniformly, while sharp internal angles may accelerate Clark initiation. Limited studies systematically compare these effects under identical manufacturing conditions. The aim of this study was to experimentally investigate the combined influence of polymer materials and hole geometry on tensile strength, ductility, and fracture behavior. The research task included mechanical testing, compression of geometries, analysis of structure mechanisms, and development of practical design recommendations. In this experiment, 4 different FDM materials were selected: PLA Pro, ABS, PETG, and wood fiber composite. A total of 80 standardized specimens were manufactured using identical printing parameters. 4 different internal geometric were tested to evaluate the interaction between structure and material. Tensile testing was carried out using the testometric universal testing machine according to ISO standards. During the experiments, maximum force, tensile strength, elongation at break, and ductility were measured. The obtained stress strain data allowed comparison on mechanical behavior of the tested samples. This slide presents the internal geometries used in the specimens. Rectangular and oval openings were designed to provide smoother stress distribution, while the hexagonal structure represent a lightweight lattice configuration. The hypothesis assumed that smooth geometries would reduce stress concentration and improve tensile performance. The results showed clear differences between the tested materials. PLA Pro achieved the highest tensile strength but exhibited brittle fracture behavior. Page shows the best balance between strength and ductility. ABS provides moderate performance, while wood fiber demonstrates the weakest mechanical properties due to structural discontinuities. The geometry of internal openings significantly influenced mechanical behavior. Rectangle and oval geometries reduce stress concentration and reversed higher tensile strength. In contrast, hexagonal openings generate localized stress peaks and cause early fracture initiation, especially in less ductile materials. This slide summarizes the tensile strength results for all tested materials and geometries. The highest values were achieved by PLA Pro with rectangle geometry, while PG demonstrates balanced mechanical performance with high ductility. Overall, strength decreased as geometries become more open and axial. A limitation of this study is that only static tensile loading was evaluated. Dynamic loading, fatigue behavior, environmental exposure, and numerical simulation were not included. Future work will therefore focus on long-term reliability analysis and firm-based prediction of structural behavior. In a conclusion, the study confirmed that the tensile behavior of FDM printed parts depends on the combined interaction between material type and internal geometry. Smooth geometries improved stress distribution and reduced failure risk, while angular geometry increased stress concentration. The findings provide practical recommendations for design reliable and lightweight FDM structure. In conclusion, I want to say that this study showed that the mechanical behavior of FDM printed parts depend on the combined effects of material properties and hole geometry. This work was supported by Slovak Research and Development Agency and by the Ministry of Education, Science, Research and Sport of the Slovak Republic. Thank you very much for your attention.
Synthesis of rope pulley for elevator, winch of parallel structure. Traditional elevator winches with worm gearboxes and two-speed asynchronous motors have long been widely used due to their reliability, simple maintenance, and acceptable passenger comfort in medium-rise buildings. However, modern requirements for energy efficiency and dynamic performance have revealed significant limitations of these systems. The main disadvantages are low energy efficiency and high inertial losses. The efficiency of worm gearboxes is only 60%, while asynchronous motors operate inefficiently at reduced speeds. In addition, a large amount of energy is consumed to accelerate the heavy moving parts of the lifting mechanism, and energy recovery during braking remains ineffective. Another important limitation is the restricted cabin speed. Problems with smooth motion and accurate positioning appear at speeds above 1 and 6 meters per second. Therefore, modern elevator systems increasingly use improved gear transmissions or gearless winches to achieve higher efficiency, better dynamic performance, and improved passenger comfort. This work is aimed at analyzing the drawbacks of traditional elevator winches and exploring modern approaches to improve energy efficiency, dynamic behavior, and passenger comfort. The study includes an analysis of the operational features of traditional elevator winches, identification of the main sources of energy losses and speed restrictions, and the review of modern geared and gearless drive systems. In addition, a comparison of their efficiency, reliability, and overall performance is carried out. For an elevator with a friction drive and a gear winch, when starting the drive when lifting the cabin, the engine must overcome a torque, which consists of two parts, a static component and a dynamic inertial component. During startup, the magnitude of dynamic loads, other things being equal, depends on the diameter of the traction pulley. Therefore, reducing the diameter of such a pulley will significantly reduce energy costs for driving the elevator lifting mechanism. However, reducing the diameter of the rope pulley leads to an increase in excessive rigidity of the hoisting rope, which reduces the strength of the rope. In accordance with the requirements of international and Ukrainian standards, the ratio between the design diameter of the pulley and the nominal diameter of the suspension ropes, regardless of the number of strands, must be at least 40. Thus, a contradiction appears during developing the design of a rope pulley. On the one hand, the diameter of the pulley must be reduced to reduce the pulley moment. On the other hand, the minimum value of this diameter is limited by the requirement to ensure the strength of the rope. To resolve this contradiction, it is proposed to use the idea of arranging a machine with parallel structure mechanisms. Designing machines using the ideas of arranging them with mechanism of a parallel structure makes it possible to apply the principle of multithreading to implement a rational redistribution of loads between several mechanisms and their components along parallel paths, which ensures minimization of the masses of moving elements, reducing energy costs for moving the links of the mechanism and the executive body. The proposed traction pulley design, based on the principles of machines with parallel structure mechanisms, operates by distributing the load across multiple small-diameter rotating pulleys arranged concentrically and fixed to a stationary metal frame. The rope passes over these pulleys, forming a quasi-continuous driving surface that functions as a large-diameter pulley while maintaining a reduced individual pulley size, which lowers the inertia and energy required for startup. Rotation is transmitted from a gear motor through a clutch system, one part of which doubles as a brake pulley. This arrangement ensures uniform load sharing among the pulleys, reduces dynamic stresses on the ropes, preserves rope strength, and allows precise control of cabin movement. By combining multiple parallel paths, the design minimizes moving mass, improves the system's dynamic response, and enhances overall energy efficiency while meeting international safety and traction requirements. The diameter and number of small rotating pulleys are determined based on two criteria. The first criterion: the diameter of these pulleys should be minimal, but at the same time provide a specified speed of movement of the elevator car, for example with single-stage helical gearbox. The second criterion: the total angle of the ropes wrapping all small pulleys must provide the required traction capacity at the selected coefficient of friction between the rope and the cylindrical surface of the pulley. The determination of the pulley-ready ratio is based on well-established mechanical principles and verified through the equality of kinetic energy between the actual elevator system and the equivalent simplified model. This approach ensures that all inertial and dynamic effects of the moving components, including the motor, gearbox, traction pulleys, cabin, counterweight, and suspension ropes are accurately reflected in the calculations. By accounting for energy losses due to friction and mechanical efficiency, the resulting pulley dimensions and the number of small rotating pulleys are both theoretically justified and practically reliable, providing confidence that the design system meets the required traction, strength, and dynamic performance criteria. To obtain the speed of movement of the elevator car using the dependence between the pulley radius and rotational speed, the required parameters of the pulley can be determined. Choosing an asynchronous motor with an appropriate synchronous speed as the drive motor, together with a pulley of the selected radius and rotational speed, it is obtained that the cylindrical single-stage transmission of the gear motor must provide the required gear ratio. The traction capacity developed by the pulley strands depends on the friction coefficient between the ropes and the pulley grooves, as well as on the rub angle of the ropes around the pulley. This relationship is described by Euler's formula. The total angle of wrapping of small pulleys by ropes depends on the angle of wrapping of the rope of each small pulley and the number of these pulleys. If at the Girth angle electrical degree the traction capacity will not be ensured, then it is possible to increase the friction coefficient by using wedge grooves and installing non-metallic liners for the rim grooves. Research has shown that when using the developed design of a traction pulley, the efficiency of the mechanical part of the winch for steady motion increases. The proposed design of the rope traction pulley will also significantly reduce the maximum rope tension along the arc of contact of the traction pulley, which will increase the durability of suspension ropes, reduce the load on the rope slip page, and accordingly its wear. An innovative design and parameters of the traction sheave for advanced parallel structure elevator hoisting machines have been proposed. The analysis of preliminary results show that the developed multi-motor elevator hoisting machine has a number of advantages. Efficient power distribution. Instead of one bulky drive motor, several smaller ones with better mass dimensional characteristics can be used. Reduction of hoist speed, which can be achieved through the use of small rotating sheaves and a single-stage cylindrical gear transmission. This significantly increases the equivalent efficiency coefficient from 0.71 to 0.94 for steady motion and from 0.45 to 0.63 during startup. Control flexibility, which implies the possibility of connecting-disconnecting drive motors depending on the current elevator cabin load. Redundancy, which allows, in case of failure of one of the motors, to partially maintain the operation of the hoist with another motor. Significant reduction of the maximum rope tension along the arc of contact of the traction sheave, which ensures increased durability of suspension ropes. The features and difficulties of a multi-motor hoisting machine include the synchronization of its motors. They must operate at the same speed and torque, otherwise load distortions occur. Due to differences in motor characteristics, oscillations and vibrations of the lifting mechanism may arise. Thank you very much for your attention.
Dear colleagues, your attention is presented with a report on the topic, Substantiation of the Parameters of Trunnion Distributors of Orbital Hydraulic Motors in order to improve their output characteristics. Introduction and Major Challenges. The development of hydraulic drives for self-propelled vehicles is accompanied by increasing demands to the actuators of mechatronic modules, represented by low-power hydraulic motors with small displacement, high speed, and high starting torque. This issue is addressed by using bearingless orbital hydraulic motors with Trunnion fluid distribution and a power rating of up to 10 kW. The Trunnion-type fluid distributor of these hydraulic motors also functions as a plain bearing, ensuring stable rotation of the hydraulic motor shaft. This design solution eliminates the need for rolling bearings supporting the hydraulic motor shaft, significantly reducing its size while simultaneously providing low power of up to 12 kW. A literature review revealed that over the past 10 years, there have been very few publications devoted to the calculation, modeling, and design of low-power orbital, planetary, hydraulic machines. Therefore, research into the influence of operating processes occurring in the Trunnion distribution system of an orbital hydraulic motor on changes in its output characteristics is a relevant research area in the field of energy-efficient hydraulic drive. Aim and research tasks. To substantiate the parameters of Trunnion distributors of orbital hydraulic motors, in order to improve their output characteristics for the creation of energy-efficient mechatronic modules for hydraulic drives of self-propelled vehicles, it is necessary to study the processes occurring in the Trunnion distribution system of the orbital hydraulic motor, develop a calculation scheme and mathematical apparatus for determining the geometric parameters of the Trunnion distribution system, and also develop a structural and functional diagram for modeling the influence of the geometric and kinematic parameters of the Trunnion distribution system on changes in the output characteristics of the orbital hydraulic motor. Research methodology. The Trunnion-type distributed device of the orbital hydraulic motor consists of a housing 1 with radial and end openings and a shaft 6 with grooves and slots on its Trunnion surface for supplying and discharging the working fluid. Housing 1 of the hydraulic motor has an axial Trunnion opening, which is connected to an inlet opening 2 and an outlet opening 3, through which the working fluid is supplied, discharged to the Trunnion surface of shaft 6. The working fluid passes through the inlet grooves 4 and drain grooves 5 on the shaft 6, then through the radial holes 7 and end holes 8 in the housing 1, into the working chambers 9, form toothed contours of the outer 10 and inner 11 rotors. The working fluid supplied to the working chambers 9 of the hydraulic motor, with the help of a Trunnion distribution system, creates a rotating hydraulic field that ensures the movement of the inner rotor 11, and, as a consequence, the shaft 6. The operation of the Trunnion-type distributed device can be represented by a shaft 1, with injection 2 and drain 3 slots, which is installed in a housing 5, where radial holes 4 are made. When the Trunnion distributor system is in operation, shaft 1 with the discharge 2 and return 3 grooves cut into it rotates and is installed in a fixed housing 5 with distribution holes 4. Let us assume that housing 5 is the fixed distributor and shaft 6 is the movable distributor. Grooves 2, 3 on the movable distributor, and distribution holes 4 on the fixed distributor are conventionally called the distribution windows of the movable and distributors. In this case, the width of the groove of the movable distributor is equal to the diameter of the window of the fixed distributor. The angles of the distribution windows, the radial openings of the fixed distributor, and the injection and drain grooves of the movable distributor are determined similarly to the corresponding angles of the end distribution system with segmental and cylindrical windows. To determine the capacity of the Trunnion distribution system of the orbital hydraulic motor, and the overlap area of the distribution windows of the movable and fixed distributors, a calculation scheme has been developed. The developed mathematical apparatus allows for modeling the influence of changes in the geometric parameters of the Trunnion distribution system on changes in the output characteristics of the orbital hydraulic motor. Results. to simulate the change in the output characteristics of an orbital hydraulic motor, depending on the geometric and kinematic parameters of the Trennian distribution system, taking into account the adopted assumptions and initial parameters. A structural and functional diagram of the dynamic model of the Trennian distribution system of an orbital hydraulic motor was developed. The accepted initial data describing the geometric and functional parameters of the Trennian distribution system of the orbital hydraulic motor are presented. Block 1. Block 2 determines the current angles of the distribution ports of the movable and fixed distributors, described by expressions 1 and 2, as well as the angles between their centers, and the angles limiting the geometric parameters described by expressions 3 and 4, respectively. Block 3 is designed to determine the overlap area of the distribution ports of the fixed distributor with the input and drain ports of the movable distributor, described by expression 6-8. Block 4 displays the dependence of the change in the throughput capacity of the Trennian distribution system on the kinematic diagram. An analysis of the conducted studies showed that the orbital hydraulic motor maintains its operability with different kinematic schemes, 5/4 and 5/6 of its Trennian distribution system. When using the 5/4 kinematic scheme, the average cross-sectional area of the Trennian distribution system is 14 mm, which is 21% greater than when using the 5/6 kinematic scheme, 11 square millimeters. Typical for the end distribution system of orbital hydraulic machines. It was found that distribution systems with a 5/6 kinematic scheme have an amplitude of oscillations of the cross-sectional area equal to 2.5 square millimeters, and with a 5/4 kinematic scheme, twice as much, 5 square millimeters. It should be noted that at hydraulic motor shaft speeds greater than 500 rounds per minute, the amplitude of the flow area oscillations does not affect the uniformity of the hydraulic motor shaft motion. Therefore, for Trennian-type distribution systems of orbital hydraulic motors, it is recommended to use kinematic schemes in which the number of discharge ports on the moving distributor is one less than on the fixed one. Conclusions. The conducted research revealed that the Trennian distribution system of the bearingless orbital hydraulic motors is a key element determining their output characteristics, reliability, and energy efficiency. The developed mathematical apparatus allows for the determination of the flow area of a Trennian distribution system, taking into account the geometric and kinematic parameters of the moving and fixed distributors. Simulation modeling showed that the kinematic design of the distribution system has a significant impact on the average value and amplitude of the flow area oscillations. It was found that, when using a 5/4 kinematic scheme, average flow area of a Trennian distribution system is 14 square millimeters, which is 21% greater than the 11 square millimeters oscillation amplitude for a 5/6 kinematic scheme. Furthermore, distribution systems with a 5/6 kinematic scheme have a flow area oscillation amplitude 2.5 square millimeters, while those with a 5/4 kinematic scheme have a flow area oscillation amplitude of twice that, 5 square millimeters. The obtained results can be used in the design and optimization of low-power orbital hydraulic motors for energy-efficient mechatronic modules of hydraulic drives of self-propelled vehicles. Thank you very much for your attention.
Good day, esteemed colleagues. Today, I am pleased to present our research titled 3D printed metal parts quality assessment by X-ray diffraction. This is a collaborative project between Trinity College Dublin, Odessa Polytechnic National University, and Odessa State Agrarian University. Our work addresses a critical challenge in advanced manufacturing. How do we ensure predictable performance in 3D printed titanium alloys? As you know, selective laser melting, that is SLM, completely
changed how we make complex shapes. But to use these parts in high-stakes fields like aerospace and medicine, we must verify their internal structure without destroying them. Today, I will show you how non-destructive X-ray diffraction gives us deep, quantitative insights into phase evolution, crystallite size, and internal stress. This slide shows introduction and major challenges. Let's start with the two main approaches to quality control. First, we have the traditional method. This involves cutting the part, preparing polished microsections, and inspecting them under an optical microscope. It works, but it destroys the component. Second, we have the modern approach. This relies on non-destructive X-ray diffraction, or XRD. For our research, we utilized advanced equipment, specifically the Bruker D8 Advanced Powder Diffractometer System. Slide 3. Introduction and major challenges. Now, let's look closer at selective laser melting, that is SLM. On the one hand, SLM offers incredible benefits. It allows for mass customization, extreme design flexibility, and it minimizes material waste. But on the other hand, the process has significant technical hurdles. For instance, first, the final properties depend heavily on printed parameters like laser power, scan speed, and cooling rates. Second, common material defects frequently pop up, such as unmelted powder, boiling, porosity, cracks, and high residual stresses. Third, because of this, the industry is moving toward real-time diagnostics and online monitoring of the printed process. Slide 4. Aim and research tasks. This brings us directly to the core objective of our work. Our goal is simple. We want to demonstrate how non-destructive XRD can quantitatively evaluate the physical properties of titanium parts. Crucially, we do all of this within a single, unified experimental setup using the Bruker D8 Advanced system. Slide 5. Aim and tasks. This is continuation. To achieve this goal, we broke our research down into 3 specific tasks. Tasks 1. Identify the exact phase composition and track the highly non-equilibrium martensitic transformation alpha prime. Task 2. Measure how crystallite sizes vary using both the Scherrer equation and Williamson-Hall profiling. Task 3. Quantify internal lattice microstrain variations under different printing conditions. Slide 6. Research methodology, parts, material, equipment. Let's talk about our methodology. For this study, we selected 3 distinct components, which you will see on the next slide. These parts were manufactured using both 3D printing and traditional casting techniques. The first, the material used is titanium, 6, aluminium, or vanadium, which is the absolute structural workhorse of the aerospace and biomedical industries. Second, to print them, we used a Renishaw REN AM500S machine operated under strict AMS 7015 powder specifications. Slide 7. Research methodology, 3D printer, and samples. Here is the visual look at our setup. On the left, you can see the Renishaw 3D printer. On the top right, we show the 3 specific parts we tested. At the bottom right, you can see our actual test samples, both with and without grinding and polishing. Our sample matrix consists of 2 main categories, about sample 1, 2, and 3. These are as-built SLM parts printed with incrementally decreasing laser power profiles, about sample 4 and 5. Sample 4 is as-built without heat treatment, while sample 5 went through a full annealing cycle at 950 degrees for 1 hour, followed by a slow furnace cool. Slide 8. Research methodology, XRD equipment, and setup. The heart of our analytical setup is the Bruker D8 Advanced Powder X-ray diffractometer, shown on the left. The image on the right details our multi-sample loading configuration. Let's look at the technical settings. The system uses copper-potassium alpha radiation with a stable wavelength of 1.5405 angstrom. To ensure high data fidelity and clean signals, the generator was meticulously locked at a constant 40 kilovolts and 40 milliamperes. We used a Bragg-Brentano theta-to-theta configuration, scanning a wide window from 30 to 90 degrees. Slide 9 shows results, namely heat treatment effects on crystallite geometry. Next, let's dive into our results. This upcoming section highlights some very important findings regarding post-processing heat treatment. Over the next 3 slides, we will look at how thermal annealing fundamentally alters the material's geometry and phase structure. Slide 10 shows also results, namely anomalous microhardness and crystallinity shifts. Let's look at some anomalous behavior we observed regarding microhardness and crystallinity. First, in the as-built state, repeat quenching yields a highly unstable, fine acicular alpha prime martensite phase. Second, thermal decomposition occurs during annealing at 950 degrees, which breaks down those fine needles into a coarser, relaxed duplex alpha plus beta morphology. Third, looking at our diffraction refinement, the heat treatment induces noticeably sharper diffraction peaks and Enemans drop in the full width at half maximum, or FWHM. Slide 11 shows results also, namely XRD patterns and samples microstructure. This slide visually demonstrates the impact of heat treatment on our XRD patterns and phase morphology. First, as mentioned, the peaks become sharper, meaning the so-called full width at half maximum, or FWHM. This parameter drops significantly. Second, look closely at the phase morphology transformation. We see a clear shift away from prior beta grains and acicular alpha prime phase over to alpha lamellae and semi-equexed alpha grains. This is the last slide with our results, namely hardness, aberrations, and crystallinity. Here is the experimental data comparing sample 4 and sample 5, meaning before and after heat treatment. What does the data show? First, about crystallite coursing. The average crystallite sizes expanded by a factor of 2.13, growing from 21.41 nanometers up to 42.25 nanometer. Second, about crystallinity gains. Annealing increased the global crystalline fraction from 65.3% to 72.4%, significantly dropping the amorphous background. Third, about hardness shift. Paradoxically, the microhardness actually climbed from 369.6 HV as built, up to 391.1 HV post-heat treatment. Slide 13 shows additional results, namely influence of 3D printing laser power. Now let's shift our focus to the influence of 3D printing laser power. The first, about laser control. By progressively lowering the laser power from sample 1 down to sample 3, we successfully increased the localized cooling rates. Second, about structural refinement. This power drop changed the structure completely. High power created a coarse basket weave. Medium power produced a refined basket weave, and low power yielded an ultrafine, highly homogeneous martensitic structure. Third, about quantitative metrics. Our metrics show that prior beta grain boundaries dropped from roughly 100 millimeters down to just 30 millimeters. Meanwhile, alpha prime layer thickness thinned out from over 2 micrometers to 1 micrometers. About trends. Crystallite and hardness trends. The average crystallite size shrank from 26.84 nanometer down to 15.55 nanometers, driving or which drove the microhardness up from 332.3 HV to 366.3 HV via or through boundary strengthening. Ultimately, this analysis highlights some pivotal opportunities for the XRD method. It can be found on the XRD pattern. First, analyzing surface quality impact. Second, assessing heat treatment effects. Third, effect of 3D printing parameters on XRD pattern and optimizing 3D printing parameters, and comparison as cast and as built 3D printed samples. Slide 14. This is the first slide with conclusions. To wrap things up, we have completed a comprehensive study on the quality of 3D printed metal components using non-destructive XRD. We have just highlighted the new capabilities of this setup. Now, let's look at our main overarching conclusions on the final slide. Finally, slide 15 gives the main conclusions. Let's summarize our key takeaways. First, non-destructive XRD is a highly valuable diagnostic tool. It successfully quantifies internal phase transformations, crystallite growth, and microstrain relief in SLM parts. Second, post-processing at 950 degrees effectively doubles crystallite dimensions, increases overall crystallinity by 11%, and removes lattice stress. Third, we can control the structure parametrically. Lowering the laser power increases cooling rates, refines the alpha layer's width, and boosts material hardness. Finally, from an industrial standpoint, pairing non-destructive XRD with standard microscopy gives us a powerful, efficient way to inspect and optimize components for aviation and medical applications. Slide 16, about acknowledgement. Before I finish, I would like to express our gratitude. This research was carried out at the National X-ray Laboratory within the Center for Research on Adaptive Nanostructures and Nanodevices at Trinity College Dublin. This work was done under the project Developing X-ray Analysis Methods for Characterization of Materials, and it was proudly supported by the Research Island Supplemental Grant for displaced researchers from Ukraine. We are deeply grateful to Research Island for funding this initiative. Finally, I can say thank you very much for your time and your attention. You can see our contact information. I am now open to any questions or comments you may have.
Greetings from Bihać from Bosnia and Herzegovina. My name is Ermin Husak, and I will present paper entitled AI Enhanced Mobile and Collaborative Robotic System for Continuous Monitoring and Automated Maintenance of Production Processes in Real Time. Authors of the papers are Isak Karabegovic, Ermin Husak, Predrag Dašić, Volodomir Tankonogi, Ljubov Bovnegra, from Academy of Science and Arts of Bosnia and Herzegovina, University of Bihać, Bosnia and Herzegovina, Engineering Academy of Serbia, and Odessa Polytechnic National University from Ukraine. The development and implementation of advanced technologies have been recorded in recent years through the implementation of Industry 4 concept, which is reshaping traditional production processes into smart, connected, and autonomous systems. Very implementation of Industry 4 in own manufacturing processes requires high efficiency, greater protection and safety, which increasingly imposes the need for autonomous maintenance of production processes and equipment. The motivation for the approach of
Autonomous maintenance arises from increasingly frequent unplanned downtime and limited equipment monitoring, which pose a significant challenge to the operational productivity and financial sustainability of production processes themselves. Likewise, the integration of autonomous mobile robots and collaborative robots or cobots, together with advanced artificial intelligence algorithms, represents an innovative and advanced solution for continuous condition monitoring and automated maintenance in real time. The implementation of advanced artificial intelligence algorithms into robotic systems gives them the capability to analyze large amounts of data in real time, predict failures before serious downtime occurs, and optimize the entire production processes. Such integration also contributes to worker safety by reducing the need for direct intervention in hazardous parts of production. Likewise, the application of the machine learning algorithms and digital twins enables the simulation and testing of different maintenance scenarios without disrupting production in industrial processes. This paper proposes such a system, or intelligent mobile and collaborative robotic systems enhanced with artificial intelligence algorithms, with the aim of optimizing production processes, reducing unplanned downtime, and increasing the quality of production. The research objectives include the development and application of robotic systems for real-time monitoring, the evaluation of its functionality in an industrial environment, and the quantitative analysis of its impact on the maintenance of production processes. Autonomous systems, including autonomous mobile robots and collaborative robots, represent a set of technologies and products such as smart sensors, actuators, microprocessors, communication, which enables devices to independently recognize the environment, make decisions, and perform tasks with minimal human intervention. By implementing Industry 4 technologies, we are moving towards smart production processes, and the maintenance of the equipment in this system can no longer rely on the traditional approach to maintenance, but must shift to predictive maintenance. Predictive maintenance and monitoring and surveillance of the production processes rely on continuous data acquisition, which are vibration, temperature, pressure, sound, extraction of the health indicators, and models that predict the probability of failure or the remaining useful life. The implementation of service robots for professional use is increasing year by year, especially in the last few years. Statistical data on the implementation of service robots for professional use are used from the International Federation of Robotics, United Nations Economic Commission for Europe, and the Organization for Economic Cooperation and Development, which is shown in figure left. In 2014, around 32,000 service robots for professional use were applied worldwide, and in 7 years, in 2024, around 291,000 robot units were applied or installed each year. Analyzing the trend of the implementation of service robots for professional use, we see that the highest application is in transport and logistics, with about 130,000 robot units, which is shown on figure right. In second place is the application robot in hospitality with about 56 robot units, then professional clinic with about 49,500 robot units, agricultural with about 27,500 robot units, and finally security with about 6,000 robot units. The trend of application shows that the largest share of professional service robots is in transport and logistics. The trend of the application of service robots in transport and logistics is continuously increasing year by year. Such growth trend in the application of service robots in transport and logistics is the result of combination of factors including chronic labor shortage, the need to increase the precision and efficiency of task execution, and the accelerated implementation of Industry 4 technologies in which robotics represents a key basic components. In figure, we can see trend of implementation of service robots for logistics in the world in period 2014 to 2024 in 1000. Collaborative robots or cobots communicate with the environment, understand the environment through models, automatically generate programs based on planned tasks, understand human action, and follow human social norms. The trend of application of collaborative robots increases every year. In 2015, around 11,000 robot units were applied worldwide, and in 2024, around 68,000 robot units. In only 8 years, the increase amounted to the 6 times. In 2024, it was 12.5 in comparison to traditional industrial robots. The implementation of autonomous mobile robots and collaborative robots with AI algorithms in the production processes enables continuous monitoring of equipment conditions and automatic execution of maintenance intervention in real time, which significantly improves the reliability and availability of production systems. The experimental setup is presented in real industrial environment, including defined testing scenarios and performance metrics. The experiment was conducted in a metal processing company that uses high-capacity CNC machining, where frequent micro stoppages and tool failures occur due to intensive loading. The autonomous mobile robot is responsible for autonomous transport of tool and spare parts between the warehouses and work shelves, while the cobot performs manipulation, visual inspection, and simple corrective actions on the machine. The artificial intelligence anomaly detection model is integrated in the manufacturing execution system and connected to vibration, temperature, and drive current sensor. When we talk about inspection and maintenance scenarios, there are 3 key experimental scenarios defined. Scenario A, visual inspection and AI real-time detection. The cobot uses a computer vision system based on deep neural networks to detect irregularities on the tool cutting edge and surface of the workpiece. When degradation is determined, the AMR automatically initiates the delivery of a new tool. Scenario B, predictive maintenance. It combines AI models to remaining useful life prediction with the trend analysis of vibration acoustic signals. Maintenance is triggered before a stoppage occurs, thereby reducing the total downtime. Scenario C, automate reactive maintenance. In the case of sudden failure, the AMR and the cobot performs emergency part replacement actions with minimal operator involvement, which is in line with the concept of intelligent Industry 4 facilities. Each scenario was tested over a period of 13 working shifts in order to ensure reliable performance evaluation. Evaluation metrics. The assessment of system efficiency was carried out using standard maintenance performance indicator, which are overall equipment effectiveness, analysis of availability, performance and quality, mean time between failures, average time between failures, and mean time to repair, which is average repair time, and downtime total time of unplanned machines. Table on the left side presents the economic effects of automation implementation through a comparative analysis of key indicators before and after the system application. A significant reduction in monthly maintenance cost from 80,500 euros to 50,200 euros is evident, as well as decrease in production downtime, losses from 32,000 euros to 21,500 euros. This confirms the overall improvement in system efficiency and better equipment availability. Additionally, the achieved return on investment of 21 months demonstrates the economic viability of the implemented solution. Based on the visualized chart on the right side, a clear trend of the cost reduction and increased overall production efficiency can be observed. The most significant result is a 45.2% increase in mean time between failures, which means that the system now operates longer between failures. At the same time, mean time to repair decreases by 37.8%, indicating a much more efficient intervention by the cobot and operators. The overall equipment effectiveness increased by 40.7%, which represents a highly significant improvement in industrial practice. For conclusion, we can say that this paper confirms that integrated autonomous mobile robots, or AMRs, and collaborative robots, or cobots, enhanced with advanced artificial intelligence algorithms provides an effective and sustainable solution for autonomous monitoring and predictive maintenance in smart manufacturing. Based on the reduction of downtime and decrease in OEE, the estimated financial effects include increase in production capacity around 11%, reduction in maintenance cost around -18%, less waste and material damage, fewer emergency service intervention. Projected return on investment is around 18 to 24 months. The following implementation limitations were identified: need for high-quality sensor data, integration of multiple equipment suppliers requires additional middleware modules, higher initial investment in mechatronics and AI infrastructure. The system still requires supervision by qualified technicians. Additional testing with a large number of workstations and a longer analysis period is planned. Thank you very much for your attention.
Hello dear organizers and participants of DSMIE. Today we would like to present the results of our research entitled Optimization of Combined Thin Layers Silane Coating. The research is focused on the development and optimization of two-layer protective silane coatings for cellulose-based paper materials. Paper-based packaging materials are widely used because they are environmentally friendly, recyclable and biodegradable. However, cellulose materials have several important limitations. They absorb moisture, lose mechanical strength under humid conditions, and may be affected by mold and fungal growth. Therefore, improving the protective properties of paper is an important scientific and practical task. In this study, we propose a multifunctional two-layer organosilicon coatings that provide hydrophobicity, biocidal resistance, and preservation of mechanical properties. The aim of this research was to optimize the composition of combined silane coating for cellulose-based paper materials using an experimental design approach. To achieve this aim, several tasks were performed. First, we developed model coating formulations. Second, we investigated their hydrophobic, mechanical, and biological properties. Third, we constructed regression models, described the influence of coating composition of material properties. And finally, we determined the optimal component ratio for the coating systems. The proposed coating has a two-layer structure. The first layer is an adhesive biocidal sublayer. It contains potassium methylsiliconate and copper zinc amino methyl complex. The second layer is a protective siloxane top layer based on polyalkyd hydride siloxane dispersion. In simple terms, the structure can be presented as follows: paper substrate, adhesive biocidal sublayer, and protective siloxane top layer. The adhesive sublayer improves fixation of the coating and provides antifungal protection, while the outer siloxane layer increase hydrophobicity and reduce moisture absorption. To optimize the formulation, we used a central composite rotatable experimental design. 3 formulation factors were selected. The first factor was the content of potassium methylsiliconate. The second factor, X2, was the content of the copper zinc amino methyl and the third factor, X3, was the content of polyalkyl hydride siloxane. For response parameter, we evaluated water contact angle, moisture absorption, tensile strength, and fungal resistance. 3 indicators characterize the hydrophobic, barrier, mechanical, and biological performance of the treated paper. This slide presents the experimental metrics. In total, 15 model coating compositions were prepared. Each composition had a different ratio of the 3 main components. The table includes both coded factors levels and real component contents in weight percent. I will not focus on every individual row of the table. The main point is in this experimental design allow us to evaluate not only the individual effect of each component, but also interaction effect between the components. Experimental data were processed using regression analysis. Second-order mathematical models of the composition property type were used. Their model described the relationship between the coating composition and the functional properties of the treated paper. Regression models were obtained for 4 indicators: contact angle, moisture absorption, tensile strength, and fungal resistance. The adequacy of models was confirmed using by Fisher's criterion, which means that the model can be used for prediction within the studied experimental range. This slide shows the experimental results for all 15 coatings composition. The results demonstrate that the composition of the coating has a significant influence on all studied properties. For example, samples with a higher content of polyalkyl hydride siloxane generally showed a higher water contact angle and lower moisture absorption. At the same time, the presence of the copper zinc complex contributed to better fungal resistance. Thus, the experimental data confirmed that the coating performance depends on the balance between all three components. This slide presents the final regression equations. These equations were obtained after removing statistically insignificant coefficients from the individual models. Each equation describes one response parameter, water contact angle, moisture absorption, tensile strength, or fungal resistance. The models they are then used to build response surface plots and to determine the optimal region of the coating composition. In practical terms, these equations allow us to predict the properties of treated paper without testing every possible formulation experimentally. This slide shows the response curves for factors x1 and x2, while x3 is fixed at the central level. Here we can evaluate the influence of the adhesive sublayer components. Potassium methylsiliconate mainly contributes to hydrophobicity and structural stabilization of the coating. The copper zinc amino methylsilicate complex is especially important for biological resistance. Response curves shows that the components of the adhesive sublayer interact with each other and influence the final properties of the treated paper. Therefore, it was necessary to find a compromise optimal range. The optimization was carried out using several target criteria. The required water content angle was from 100 to 105 degrees. Moisture absorption had to be in the range of 5 to 6%. The destructive force had to be from 18 to 85 newtons, and fungal resistance had to be from 0 to 1 score. Using the response surface method, we identified a compromise optimal region. The optimal point corresponded to 2.67 weight% of potassium methylsiliconate, 2.02 weight% of copper zinc amino methylsilicate, and 15.44 weight% of polyalkyl hydride siloxane. Based on the optimization results, the recommended composition of the adhesive sublayer is from 2 to 3 weight% of potassium methylsiliconate and from 1 to 2 weight% of copper zinc amino methylsilicate complex, and the protective layer should contain about 15 weight% of polyalkyl hydride siloxane. This optimized coating provides a water contact angle of 100 to 105 degrees, moisture absorption in a region of 5 to 6%, and tensile strength of 18 to 85 newtons, and fungal resistance of 0 to 1 score. Thus, the proposed coating provides a balanced combination of hydrophobic, mechanical, and biological protection. To conclude, regression models were developed for 4 coating performance indicators. The adequacy of these models was confirmed by Fisher's criterion. The optimal coating range was identified from 2 to 3 weight% of potassium methylsiliconate, from 1 to 2 weight% of copper zinc complex, and about 15 weight% of polyalkyl hydride siloxane. The optimized coating achieved the required values of contact angle, moisture absorptions, and destructive force and fungal resistance. Future research will focus on long-term durability studies, scaling of the coating process, and application to packaging and other cellulose-based materials. Thank you for your attention.
Good day, everyone. We'd like to present Clever AI Logos, an intelligent decision support ecosystem for healthcare based on machine learning models. The talk is about automating routine clinical laboratory work. Modern medicine runs on an enormous and fast-growing body of knowledge. New research and updated clinical protocols appear faster than any clinician can physically keep up with, and the result is cognitive overload, which in turn amplifies the human factor in the quality of care. We focus on the clinical laboratory because most of its work is tied to instruments that could have been automated since the 1980s, yet in many countries automation is still weak. Over those decades, each analyzer grew its own data format, ASTM, HL7, and a vendor proprietary, so even just unifying how these devices communicate is already a meaningful gain. On top of that, manual transcription of results is a critical source of errors, and generative AI, the obvious assistant here, brings its own risks. Hallucinations are unacceptable in medicine, and fine-tuning simply doesn't scale when guidelines change. Our aim is a modular medical information system that runs end-to-end from the analyzer to an evidence-based report. It breaks into 5 tasks: a unified ecosystem for lab automation, the connection driver, a universal adapter that abstracts heterogeneous analyzers, a bilingual knowledge layer with semantic search over Ministry of Health protocols and the literature, an AI service that uses RAG to ground recommendations in approved protocols, and mathematical validation logprop-based safeguards against hallucinations. The architecture is service-oriented, with 2 levels joined by a single contract. The lower one is the hardware abstraction layer, our universal connection driver. It integrates with heterogeneous analyzers, normalizes and maps their codes, and buffers results locally, so nothing is lost in a network outage. Whatever the device speaks ASTM, HL7, or a vendor binary lives as one unified JSON. The upper level is the reasoning API. It analyzes those results, runs RAG over the relevant guidelines, and returns evidence-grounded conclusions for the clinician. The driver is a desktop application that launches automatically with the laboratory workstation and immediately starts reaching each instrument over its transport layer, TCP as host or client, serial or file. It speaks to every device in that device's own low-level protocol and exposes a single universal protocol upward to the MIS-LIS. So it sits between the information system and the hardware, absorbing the complexity of hundreds of vendor protocols. The orchestration lives in the device class on the right. It wires one callback chain communicator, protocol, parser, result processor, so raw bytes flow up into a unified result, while orders flow back down to the analyzer. The link is bidirectional, it both dispatches orders and collects results. And it's built for the lab floor. A local SQLite database, detailed logging, and fully autonomous operation with no internet, buffering everything against data loss. Here are 3 raw outputs from similar hematology analyzers. They run essentially the same blood count, yet each transmits it in a completely different format: ASTM, HL7, and the vendor's own plaintext frame. The driver's unified parser collapses all 3 into one, and the same JSON object, the single contract the AI service consumes. This video shows a simulation of the driver receiving data from 2 veterinary analyzers, a hematology unit and a biochemistry unit. In this scenario, the driver is working with both devices at the same time. The biochemistry analyzer is on the top half of the screen, the hematology one is on the bottom. To run the simulation, I'm going to feed the driver a raw byte stream. These are the exact bytes that were previously captured from real devices, sent in one-to-one, the way they would actually arrive from the analyzer over the wire. As you can see, the driver supports what we call a clarification window, a small dialog that lets the operator enter or adjust a few fields before the result is finalized. A typical case is the species of the animal. Once the operator confirms the clarification, the driver processes the result and automatically opens a ready-to-print report in Word format. It can also just save the Word or PDF file from a template, send it straight to the printer, or push the results to an external API depending on how the lab wants to wire it up. You can also see that the driver automatically calculates the deviation from the reference range as a percentage. This is convenient for a quick visual scan. It makes it easy to see what should get the clinician's attention first. The next case is a simulation of data coming in from the hematology analyzer. The flow is exactly the same. The only difference is that the printed report now also includes a set of 4 histograms transmitted by the device. The driver can either pass through histogram images directly from the analyzer or reconstruct the plots from the raw point data. Some analyzer models send the data points instead of a finished image. This is far from everything the driver can do, but the goal of this video was just to show the basic one-way scenario from a raw byte stream on the wire to a printed report on the desk. Now we move to the second service, the AI service. This is where the system builds a vector knowledge base from medical sources, Ministry of Health protocols, guidelines, articles, and textbooks. On top of it, a clinician can search that knowledge directly by keyword and get help reasoning through real cases interpreting lab results against the evidence. Under the hood, it's a 4-stage pipeline, shown stage by stage in the next slides. Ingestion fills the base. RAG retrieval finds the relevant passages. A 2-level reasoning step produces the answer, and a confidence layer checks it before it reaches the clinician. Ingestion uses multi-representation indexing. The chunks you search against are not the chunks you feed the model. The closest analog in the RAG literature is parent document retriever. Every document is cut into roughly 300-word chunks in 2 passes. The overlapping chunks go to the vector store, where the overlap improves recall at chunk boundaries, but that same overlap would hand the model duplicated text. So for the answer, we use clean, non-overlapping chunks, a precise, non-redundant context window that keeps us from overloading the model and wasting tokens. In the current pilot, this runs as a single store, with the clean relational mirror still on the roadmap. On this video, we've selected a folder that contains 50 medical protocols from the Ukrainian Ministry of Health, together roughly 82 megabytes of PDF documents. As soon as I press Upload, the system takes the whole folder and processes the documents in 5 parallel threads, so all of them are handled at once. And in about 8 seconds, it has worked through all 82 megabytes of PDF data. Here we can see the system has just finished ingesting 50 medical protocols. It reports back the document count, the number of chunks produced, the embedding token spent, and a few other ingestion metrics. So the knowledge base now contains our protocols. Let me show you a short video of vector search on practice. The service also supports plain keyword search against the knowledge base. Here we queried hypertension and heart disease. Each term gets its own results, group average, similarity score, number of chunks, search time, and every chunk shows the source protocol, the text itself, and the page it came from. This is the RAG core, end-to-end. A clinical query, the patient plus their tests, is embedded into the same vector space as the guidelines, and a cosine search returns the closest passages. A strict score threshold and top K filtering cut the noise, and every retrieved chunk carries its document, page, and citation, so the answer is grounded and traceable to the source. But retrieval alone doesn't eliminate hallucinations, and that's why the final stage is a set of trust layers. This is the class that wires those steps together: retrieval, augmentation, reasoning, and validation from 3 injected services. The one detail worth pausing on: the trust layer is conditional. Confidence validation runs only when the case didn't require a reasoning model, because the log probability math we rely on isn't exposed by today's reasoning APIs. It's a real limitation, and we're upfront about it. Today, the reasoning core uses just 2 agents. The first is a cheap, fast context agent. It reads the case, decides whether it's a medical query, extracts the search terms for retrieval, and forms a preliminary hypothesis, including a flag for how hard the case is. That flag drives the second analytical agent, which does the deep clinical reasoning over the augmented data. Simple cases stay on a fast and expensive model. Complex ones escalate to a dedicated reasoning model, so cost versus depth is decided per request. Each agent is locked into a narrow role by its own system prompt and a strict JSON schema, so its output is constrained, not free-form. For the cases that allow it, we built a purely mathematical confidence gate. It reads the model's token-level log probabilities and turns them into a single score from perplexity, entropy, and how diffuse the uncertainty is. Risk penalties pull the score down when those signals look bad. A lens normalization step keeps answers comparable and only answers above a 0.55 threshold pass. No second model, no extra prompt, just math over the numbers the model already gives us. But this math has one hard requirement. The model must expose those token log probabilities, and most closed API-only services, including reasoning models, simply don't. So the field falls back to the other methods shown here, a second model acting as a judge: self-consistency, RAG faithfulness, schema, guardrails. None is a silver bullet. Each closes a different class of problems. The catch is they all raise quality but also raise the cost per request, since they need extra model calls. To evaluate the driver in the real world, we deployed it in about 10 laboratories, 4 of them veterinary clinics, and then sent a questionnaire to 21 operators and lab technicians, 10 biochemists and 11 hematologists. The results were clear. 16 of the 21 specialists freed at least an hour of working time per shift, with reported savings ranging from 1 to 4 hours. Median processing time per patient dropped from about 6 minutes to under 30 seconds. And transcription errors fell to 0, not by training people to be more careful, but because the manual data entry step is architecturally removed. Now let me show you a short video where we test the AI system on 3 real patient cases. It's all walked through there. The first patient is a 70-year-old woman. Her biochemistry panel shows elevated creatinine, high uric acid, and most importantly, a glomerular filtration rate of 44, well below the normal threshold of 60. Everything else is within range. And here is the analysis result for the first patient. The context model produced several search queries, and the corresponding chunks were retrieved from the protocols. The model also decided that this case requires deeper reasoning, so the request was routed to the O3 reasoning model. O3 then produced a step-by-step plan and a formatted clinical report. The second patient is a 24-year-old woman with no real pathology. A couple of values sit right at the edge of the reference range, but nothing clinically meaningful. As you can see, the context model did not invent any alarming differentials and did not search the knowledge base at all. It also recognized that this case does not require complex reasoning and routed to the cheaper GPT 5.2 model for the diagnostic summary. The output is in the same formatted report style as before. Patient 3 is a 72-year-old man with marked dyslipidemia, high total cholesterol, high LDL, an elevated atherogenic index, and elevated fibrinogen. As with the first patient, the system retrieved the relevant protocol chunks and routed to the reasoning model. The result is a step-by-step plan with explicit references back to the chunks that were retrieved, plus a formatted clinical report. If we open the full analysis output, we can also inspect what the context model produced, the mathematical confidence score on its work, and the exact chunks that were pulled from the knowledge base. So, this video walks through the minimum flow for medical analysis: 2 agents working together, a context model and an analytical model, each running on a strict prompt with its own rules. The plan is to expand this into a full team of medical agents, a dedicated gastroenterology agent, a trauma agent, and so on. So, the main analytical model can consult neuro specialists on the harder cases and produce higher quality reports. But even with just 2 general-purpose agents, the current flow already gives meaningful results. To wrap up honestly about scope, the clearest, most measurable win came not from the AI, but from the deterministic driver, real-time saved per shift, transcription errors removed. The RAG core adds grounded, cited answers, and trust is handled in layers rather than assumed. What's still open is data and calibration. The real bottleneck is expert-labeled reasoning data. The confidence math is silent on reasoning models, and the current threshold is a heuristic, not a calibrated guarantee. So, the bottom line, this is a research-grade pilot, not a clinical decision system. Every recommendation stays advisory, with a clinician in the loop on every read. Thank you very much for your attention. I'd be glad to take any questions.
Dear ladies and gentlemen, my name is Vitaly Kolos. Let me demonstrate our research with the title Artificial Intelligence for the Design and Optimization of the Technological Equipment a Review. This research study was carried out with Anna Burdyuk, Joseph Zayats, and Vitaly Ivanov. Introduction and major challenges. The combination of advancement in machine learning, deep learning, and big data analytics has developed the automation and optimization industrial process. This enables a company to reduce its time to market for new products while increasing its manufacturing flexibility. At the same time, integration AI technology into a manufacturing system supports and the implementation of the Industry 4.0 concepts, in which digital technology and intelligent solutions form the foundation for creative smart factories. The application of AI technology enables predictive maintenance, adaptive process control, and intelligent quality inspection, thereby significantly reducing the risk of equipment failure and product downtime. An equally important aspect is improving energy efficiency and environmental stability of manufacturing engineering process through real-time big data analysis. Today, AI has become the foundation of digital transformation. AI assists in improving operation, promotion, automation, and creating new products and services. AI has now become the foundation of operations in different sectors, including finance, manufacturing, healthcare, and retail. The figure shows the distribution of AI adoption across sectors worldwide as of 2024. Aim and research tasks. The research aims to analyze current scientific and engineering approaches to the application of AI in the design and optimization of manufacturing equipment. Particular emphasis is placed on identifying trends in the development of AI-based methods for designing, optimization, and digital twinning, which enable more efficient, reliable, and adaptive operation of manufacturing system. Another important aspect concerns the integration of intelligent and adapted system into computer-aided design, computer-aided manufacturing, or computer-aided engineering environments. This kind of integration will help move from the traditional operator-dependent design process to fully automated, knowledge-driven engineering environments. The possibility of integration AI algorithms for pattern recognition, prediction, and optimization will enable autonomous parameter optimization. This not only automates the design decision-making process, but also improves the accuracy and consistency of engineering solution. In addition, the combination of AI-based optimization and digital twin technologies helps improve product quality. It helps engineers reduce development time by simulating the process before implementation. Research methodology. The review is based on a systematic research of database and publications up to 2025. This includes assessing the problems, methodology, and results present in the literature in manufacturing engineering and related industry. To this end, an assignment is made of the full contents of this publication, encompassing all scholarly work, including reports, conference paper, and journal papers. The literature search was divided into two broad categories. The first related to AIM methods and the second to manufacturing engineering. The following sets of keywords include artificial neural network, or artificial intelligence, or deep learning, or reinforcement learning, and the second is manufacturing engineering or flexible fixture. Multi-stage filtration process was carried out. In the first stage, duplicate records and non-English publications were excluded. The next is the second stage of filtering papers that did not directly related to the design, modeling, and optimization of manufacturing equipment and system were excluded. Finally, only those papers that contained applied or experimental results of interest to manufacturing engineering were selected for in-depth analysis. The search strategy used in the study is illustrated in the figure, which outlines the methodological process using a flowchart. As a result of this filtering process, a refined and representative body of the recent papers was obtained. Results. The analysis of recent study on AI implementation in mechanical engineering has revealed a set of emergency technologies that determines the current direction of industrial digital transformation. Those technologies, including machine learning, deep learning, computer vision, digital twin, and intelligent decision support system, play a key role in automating design, production, and quality control process. The table presents a structural overview on the most important intelligent technology in manufacturing engineering. Machine learning and deep learning technology are primarily used for predict maintenance, process optimization, and quality control, and have attained the high technology readiness level. This is because the majority of this industry use the intelligent technology maintained above. Computer vision and digital twin technology are used for real-time monitoring and simulation of the mechanical system, helping reduce errors in the design and production process. The intelligent decision support system and the intelligent knowledge-based system facilitate a faster, more efficient decision-making process in engineering. Generative design and reinforcement learning technology are used to automating the design process. From the research paper present in this section, it is clear that there has been an increase in the use of optimization technology, machine learning, and hybrid integrational system for fixture design optimization, deformation reduction, and improving machining precision. The data in this table shows that the materially of the process AI technology for design and process decision is high, with most approaches already at technology readiness level from 6 to 9. The most significant effects are observed in the automation of design decisions, the reduction of setup and machine time, and the increase in the precision and flexibility of production system. The trend of using AI algorithms with computer-aided design or computer-aided engineering system and digital manufacturing platforms is avoided, enabling is the development of intelligent, adaptive, and self-optimization system to increase efficiency and achieve Industry 4.0. Conclusions. The review demonstrated that AI technologies such as machine learning, deep learning, optimization algorithms, and digital twins are actively applied in manufacturing engineering and have already reached technological readiness level of from 6 to 9. AI improves the efficiency, precision, flexibility, and reliability of manufacturing system. Study shows that AI-based maintenance system can increase system availability by up to 14% and reduce maintenance cost by 25%. In addition, reinforcement learning and optimization methods improve fixture design, position accuracy, and assembly quality. The integration of AI with computer-aided design or computer-aided engineering system enable faster optimization of complex manufacturing configuration and increase productivity. Future research will focus on developing AI-based automatic design models and implement that in real manufacturing and computer-aided design and computer-aided engineering environments. Acknowledgements. The research was carried out with the Ivan Vyhovsky Research Fellowship founded by the Center for East Europe Studies at the University of Warsaw. Also, it was created within the project research of advanced technology for increasing the efficiency of multi-level engineering system for sustainability industry development, co-founded by the European Union under the program Slovakia. Also, this papers was elaborated in the framework of the project and granted by the Ministry of Education, Research, Development and Youth of the Slovak Republic. The research was particularly supported by the International Association for Technological Development and Innovations and the International Innovation Foundation. Thank you very much for your attention. Bye bye.
Scientific work presented in the article "Evaluation of Physical and Mechanical Parameters of Minced Sausage Mass with the Introduction of Transglutaminase Enzymes" was developed by a team of authors consisting of Doctors of Sciences Palamarchuk Ihor, Dyomin Alexander, Vladimir Wojciechowski, Alexandra Chervotkina, Olena Prokopenko. Food technologies are reaching a completely new level in our time. Considerable attention is paid to the development of combined food products, which are based on the conversion of part of the meat raw materials with vegetable proteins. At the same time, the task is to preserve the original properties of the product, which have a sufficiently high nutritional value, which will fully satisfy the needs of a human body. The relevance of the research is in the technological aspect as a modern way to increase the biological and consumer value of the resulting product, ensuring maximum balancing of the content of nutrients in food products and creating effective product models for the implementation of healthy nutrition. In the technical and economic aspect, as a measure to reduce the cost of a food product. In the scientific plan, as determining the effectiveness of applying the theory of similarity for modeling the mathematical algorithm as the relationship of the main technological and physical factors of studying the process of preparing minced meat mixture, which allows predicting the influence of the studied parameters on changing the quality of the resulting mixture, as well as justifying effective operating models for its preparation. The purpose of this study is to obtain analytical and graphical dependencies between the main physical and mechanical parameters of the process of forming the structure of minced meat with the enzyme admixture based on transglutaminase by applying the necessary experimental base, similarity theorems, and the theory of dimensions. To achieve this goal, the following tasks were set. To analyze the experience of modern food enterprises in the production of semi-finished meat products and finished products with admixtures of raw materials of plant origin. To obtain on the basis of experimental studies the properties of product samples obtained when applying such a technological measure necessary for modeling. Taking into account the main physical and mechanical and technological factors that determine the process of preparing minced meat, using transglutaminase to select the necessary evaluation criteria from similarity numbers. Based on two theorems of similarity theory and dimension theory, to compile a criterion equation of the process under study, to determine the patterns of change in the main parameters of the process under study. Experimental work was carried out in the laboratory conditions of the Department of Technology of Meat, Fish and Seafood Products of the National University of Agriculture and Food Science of Ukraine, as well as in the Ukrainian Laboratory of Quality and Safety of Agricultural and Industrial Complex Products. In vegetable protein, we determined the content of protein, fat, ash, moisture, quantity and quality of gluten. in accordance with GOST and DSTU. In activated water, we investigated such indicators as pH, permanganate oxidation, total iron content, dry residue, nitrate, chloride, sulfate, calcium, magnesium, total hardness, hydrocarbonate ion content, electrical conductivity, and microbiology. Using the enzyme preparation of transglutaminase, we investigated the effect of activated aqueous media on the activity of preparation itself. Using the penetration numbers obtained in the experiments, the values of the ultimate shear stress Tg of minced masses for the corresponding samples were found. The modeling was carried out using the second Federman-Buckingham similarity theory and the method of dimensional theory, on the basis of which, using the main factors of the studied process, a matrix was constructed. According to the method of dimensional theory, it is adequate to represent the main function of the studied mass transfer process. Beta equals f of rho epsilon tau TL in the form of a power series. The constructed dimensional matrix allowed us to obtain the initial three equations showing the relationship between the power coefficients presented above in the power equation. As a result of the intermediate mathematical transformations of the power equation and the graph analytical method of determining power coefficients, a general expression of the criterion mass transfer equation of the studied process was obtained. Using the developed models in the form of mathematical algorithm of criterion equation in the Excel software environment, the desired graphical relationships between the main physical, mechanical, and technological characteristics of the mincemeat preparation process with the addition of transglutaminase were obtained. The relationship presented on poster 9 shows a linearly decreasing pattern of change in the mass transfer coefficient from the technological time of the studied mincemeat mixture preparation process. For a processing time of 300 seconds, a decrease in the density of mincemeat by 200 kilograms per cubic meter caused an increase in the mass transfer coefficient by 0.1 seconds per meter, which is explained by a decrease in the resistance of the raw material mass. The dependence of the mass transfer coefficient, beta in seconds per meter, on the concentration of transglutaminase in partial units over the time intervals of preparation of the mincemeat mixture, T makes it possible to access the course of the intensity of mass transfer of the studied process. This characteristic cyclically decreases with an increase in the content of transglutaminase in the mixture by 1%. The dependence presented on the poster 11 shows a linearly increasing pattern of change in the density of the mincemeat mixture depending on the content of transglutaminase in it. When the concentration of transglutaminase in the mixture increases from 4 to 8%, the density of the mixture increases from 800 to 1,500 kg per cubic meter. That is, adding 4% of this admixture increases the density of the minced meat by 88%. The conducted studies showed sufficiently high physical and mechanical characteristics of the minced meat mixture with a processing time of 300 seconds, a transglutaminase content in the mixture of 8%, a mass transfer coefficient of 0.6 seconds per meter, which allows obtaining a minced meat density of 1500 kg per cubic meter. These characteristics are closest to the third studied sample of the developed recipe. Based on the conducted research, the following conclusions can be noted. To increase the biological value, physical, mechanical, and technological characteristics of the minced meat mass of sausages, reduce the cost of production, a food additive based on transglutaminase with a concentration of 3.57 to 10% was added to the studied meat semi-finished product. The use of selected similarity numbers of Rode, Euler, Fourier, and Sherwood allowed us to take into account when modeling the head velocity of convective and diffusion flows at the boundary of the separation of interacting phases. Inertial forces, weight, pressure, which ensured the intensification of the mass transfer process during the preparation of the minced meat mixture with an admixture of transglutaminase. Based on the compiled criteria equation of the minced meat preparation process and the developed program, a recommended number of operating mode parameters for the minced meat preparation process was determined. The results of the research showed that the addition of transglutaminase to the product allowed to improve the physical and mechanical properties of the products, which are associated with the shear stresses and density. Thus, the following characteristics of the sausage minced meat preparation process can be recommended. Processing time 300 seconds, transglutaminase content in the mixture 8%, mass transfer coefficient 0.6 seconds per meter, which allows to obtain a minced meat density of 1500 kilograms per cubic meter. These characteristics are closest to the third studied sample of the developed recipe. To confirm the adequacy of the results obtained, the following arguments can be presented. The transglutaminase enzyme preparation used in the studies takes an active part in the formation of additional bonds in protein molecules. In addition, transglutaminase improves the physicochemical properties of products related to consumer perception of consistency, namely texture, density, cuttability, elasticity, and others, as shown by the conducted studies. This study substantiated the use of transglutaminase in the studied product samples. The modeling was carried out using the second Federman-Buckingham similarity theory and the method of dimensional theory. The peculiarities of the course of the studied process determine the expediency of using the following similarity numbers in modeling. The Freud criterion FR assumes consideration of the interaction of inertial and weight forces. The use of the Sherwood criterion makes it possible to estimate the parameters of the intensity of mass exchange flows at the boundary of the separation of interacting phases. The Euler criterion allows you to adjust the pressure forces and head velocity. Thank you for your attention.
The state of formation of energy efficiency competence in professional colleges of the construction sector of Ukraine. Introduction and major challenges. The report of the European Commission Clean Energy for All Europeans, COM 2016, 860 final, dated November 30th, 2016, proposed the fourth energy package, which provides for increasing the share of electricity production from renewable energy sources to 50% of total production by 2030. The tabled package pursues three main goals: putting energy efficiency first, achieving global leadership in renewable energies, and providing a fair deal for consumers. In accordance with the requirements of this energy package, Ukraine introduced a new energy strategy, 2023. The document reflects the objectives of the European Green Deal and is based on the principles of a comprehensive approach to the formation and implementation of energy policy and the creation of conditions for sustainable economic development in Ukraine. In particular, the strategy takes into account the consequences of the full-scale war of the Russian Federation against Ukraine, the strengthening of the role of energy security and resilience of the energy system. The results of Ukraine's energy system synchronization with the European network of transmission system operators for electricity and the deepening of its integration into the pan-European system. the introduction of the latest technologies, global trends, and innovative solutions that meet environmental safety requirements in accordance with EU standards and Ukraine's commitments, Ukraine's international obligations regarding energy efficiency, the use of renewable energy sources, and the reduction of greenhouse gas emissions, and the decentralization of electricity generation across the country to improve the stability and reliability of energy supply. The fourth energy package states that buildings account for 40% of total energy consumption. Therefore, the formation of energy efficiency competence of construction sector specialists for the green recovery of Ukraine becomes a strategic priority. Aim and research tasks. The purpose of the article is to determine the state of formation of energy efficiency competence in institutions of professional pre-hire and vocational education in Ukraine. Research methodology. To achieve the research objective, determining the state of formation of energy efficiency competence in construction institutions of professional pre-hire and vocational education in Ukraine, a set of interrelated research methods was applied. Theoretical methods, analysis, synthesis, generalization, were used to study the results of scientific research on energy efficiency formation, educational and methodological literature on environmental protection, and to clarify the state and level of development of the research problem. Comparison and juxtaposition were used to compare researchers' approaches to solving energy efficiency problems and to substantiate the conceptual and categorical framework. Systematization and generalization were applied to formulate conclusions and educational forecasting. Empirical methods included questionnaires, testing, pedagogical observation of participants in the environmental educational process, and interviews with future builders, employers, educators, and stakeholders to study the features of energy efficiency competence formation in construction institutions of professional pre-hire and vocational education in the context of modern eco-oriented education. An analysis of the formation of energy-saving competence was conducted based on the educational and professional program, finishing of buildings and structures, and building design of the separate structural unit. Chernivtsi Professional College of the Lviv National University of Environmental Management developed in accordance with the standard of professional pre-hire education for the degree of professional junior bachelor in the field of knowledge, architecture and construction. Specialty 192 Construction and Civil Engineering, as well as the educational program for the profession Tyler of the Municipal Vocational Education Institution, Novovolinsk Center for Vocational Education, of the Volyn Regional Council, developed on the basis of the State Educational Standard for Profession 7132 Tyler, approved by order of the Ministry of Education and Science of Ukraine dated March 8, 2024, number 289. Using the example of the educational program for the profession Tyler, we observe that the state standard includes the key competence KC6, environmental and energy efficiency competence. This involves the ability to rationally use energy resources and consumables in professional activities or everyday life, as well as to use energy-efficient equipment and comply with environmental standards in professional activities and everyday life. This competence is also included in standards for other construction professions such as bricklayers, carpenters, and joiners. As a result of expert evaluation, 3 pedagogical conditions were identified as having the greatest influence on the formation of energy efficiency competence of future builders. The availability of teachers possessing energy efficiency competence and their professional development in energy-efficient technologies, the use of active teaching methods, project-based learning, case methods, etc., and the creation of an appropriate creative educational environment that promotes the formation of energy efficiency competence. These conditions can be created and implemented by teaching staff in construction institutions of professional pre-hire and vocational education. Results. The results of a survey of teachers in vocational and pre-hire education institutions, 250 respondents, show that the issue of developing energy efficiency skills in future builders is relevant and is being partially implemented in educational institutions, but needs to be further strengthened and systematized. Most teachers have significant professional experience. 46% of respondents have over 20 years of teaching experience, indicating a high level of professional awareness. Participating institutions represent a wide regional spectrum of Ukraine, with the largest representation from Kharkiv, Kyiv, Vinnytsia, Sumy, and Khmelnytsky regions. The responses show that teachers clearly understand the key principles of energy efficiency. Priority measures include building modernization, thermal insulation, and the role of modern technologies in reducing energy consumption. The most important modern technological solutions identified were energy-efficient equipment, 47.4%, smart management systems, 24.6%, and building automation systems, 28%. The vast majority of respondents support the integration of renewable energy sources in construction, primarily solar energy, 62.1%. Teachers highly assess the importance of thermal insulation materials and innovative structural solutions to ensure building energy efficiency. They believe that curricula should include topics such as fundamentals of energy efficiency, 28.4%, methods of improving energy efficiency, and practical case studies, 25.3%. Most educators, 83.5%, report that their institutions teach disciplines aimed at forming energy efficiency competence. However, the level of knowledge and practical skills acquisition by students is predominantly assessed as medium, over 70%, indicating the need to improve content and teaching methods. The most effective teaching methods identified were practical workshops, 41.8%, and interactive trainings, 31.2%, highlighting the need for a practice-oriented approach. Cooperation with specialized organizations, 65.6%, was identified as the most important factor for teachers' professional development. Despite significant efforts, only 22.5% of educators believe that educational programs fully meet labor market requirements for energy efficiency, while 70.8% consider them partially adapted. Similarly, the quality of educational materials is mostly assessed as satisfactory, confirming the need to update resource provision. Participation in real projects, 65.3%, increasing the number of practical classes, 50.9%, and cooperation with employers are considered the main factors that can significantly increase student motivation and learning outcomes. Based on studies, the concept of energy efficiency competence of future qualified construction workers has been further developed. It is defined as an integrated professional quality of a future builder that combines a dynamic set of knowledge, skills, practical abilities, experience, professionally significant qualities, and environmental values. Responsible attitude to energy saving during professional activities, ability to apply energy-efficient technologies, materials, and equipment in construction works, awareness of environmental consequences of professional activity, and adherence to sustainable development principles. The structure of energy efficiency competence includes value motivational, informational cognitive, organizational activity, and personal reflective components. The diagnostic toolkit for studying the formation of energy efficiency competence has been improved. According to the components of energy efficiency competence, 4 criteria for assessing formation levels were identified: motivational, cognitive, activity-based, and reflective, with corresponding indicators characterizing 3 levels of development: high, average, low. The distribution of results shows that at the ascertaining stage, a medium level of formation of energy efficiency competence prevails across all components, which once again confirms the necessity of improving teachers' qualifications in the field of energy-efficient technologies. Figure 1. Overall, the survey demonstrates a high level of awareness of the importance of energy-efficient training of future builders, while indicating the need for systematic updating of curricula, increasing the practical component of education, developing partnerships with business, and introducing modern technologies and materials into vocational training. Thus, the issue of forming energy efficiency competence of future builders for the post-war green reconstruction of Ukraine becomes especially relevant. One of the objectives of the article is to consider the developed methodology for forming energy efficiency competence of future qualified construction workers. The developed methodology for forming energy efficiency competence of future construction specialists at the second level of education, with acquisition of complete general secondary education, includes the following interrelated stages. Value motivational stage involves a cycle of classes during general and professional training that familiarize future builders with energy saving and energy efficiency, including issues such as priority thermal modernization measures for residential buildings, selection of equipment for using secondary energy sources in households, and technologies for converting renewable energy into other forms. Solar collectors, photovoltaic cells, equipment for direct combustion of biowaste, biogas plants, etc. Formative technological stage focuses on the formation of energy efficiency competence. The Ministry of Education and Science of Ukraine integrates energy efficiency topics into school curricula as part of the broader initiative to introduce green energy education within the LEARN Project 2024. Educational modules are planned to be developed and integrated without increasing student workload. Integration is also recommended for model curricula such as exploring nature, STEM, environment, technologies, natural sciences, entrepreneurship and financial literacy, and economics. Limitations. Reflective corrective stage involves evaluation and adjustment of the results of purposeful formation of energy efficiency competence. According to the competence components, for evaluation criteria are use motivational, cognitive, activity-based, and reflective, with indicators corresponding to 3 levels of development: high, average, low. Conclusions. In general, the survey demonstrates a high level of awareness of the importance of energy-efficient training for future construction professionals, as most teachers note that their institutions teach disciplines aimed at the formation of energy-efficient competence. However, the level of knowledge and practical skills of students is assessed mainly as average, which at the same time indicates the need for systematic updating of educational programs, increasing the practical component of training, participation in real projects, increasing the number of practical classes, developing partnerships with business, and introducing modern technologies and materials into professional training. In addition, at the ascertaining stage, the average level of formation of energy-efficient competence prevails in all components: value motivational, informational and cognitive, organizational activity, and personal reflective. To increase the level of formation of energy-efficient competence at the formative stage, it is necessary to introduce a methodology for the formation of this competence in future construction specialists. The methodology for the formation of energy-efficient competence for future construction specialists is a structured system of knowledge about the principles, general and specific, content. Educational components aimed at the formation of competence, methods. The most effective teaching methods were identified by teachers as practical seminars and interactive trainings forms, and pedagogical technologies for the development of the quality under study. The proposed methodology includes the following interrelated stages: value motivational, formative technological, and reflective corrective.
Dear ladies and gentlemen, let me introduce our research dedicated to the topic Analytical and Numerical Evolution of Multifunctional Spatial Trusses on Certified Truck Frames. The materials were prepared by Konstantin Holenko, Alexander, Maxim Dykha, Vladimir Datinyuk, and Mikhail Buryan. We are the part of the Khmelnytsky National University and Lviv Polytechnic National University accordingly. Introduction and major challenges. Specialized truck platforms require multifunctional modular equipment. Thus, off-road vehicles such as Mercedes-Benz Unimog are widely used for custom-mounted technical systems. Additional special trusses must be installed without modifying the certified truck frame. Major engineering challenges. UNEC certification restrictions prohibit drilling or welding of the original frame after certification. At the same time, loads from mounted equipment generate a complex multi-directional reactions in both joints of the frame. Incorrect load distribution may cause local yielding, excessive deformation, or overload of frame attachments. Finally, full transient finite element analysis of all design variants is computationally expensive during early stage development. Thus, the core challenge was how to predict both reactions and structural response of a multifunctional spatial truss before resource-intensive VA while preserving certification compliance. Aim and research tasks. Research aim was dedicated to the development and validation of the combined analytical numerical methodology for evaluating the structural integrity, bolt reactions, stresses, and deformations of multifunctional spatial trusses mounted on certified truck frames without modifying the original chassis structure. The research tasks were the next. The first one was to develop a variational mathematical model for the prediction of bolt reactions. The second, to determine optimal bolt placement, minimizing stress concentration in the mounting systems. Third, to create a FEA model for the spatial truss mounted on the Unimog frame. Fourth, investigate structural response under uniaxial and complex three-dimensional loading modes. Fifth, assess stresses, deformations, safety factor, and load distribution in bolted joints. And the last one, to evaluate compliance with certification-related structural limitations of the truck frame. Research methodology. Variational prediction of bolt reactions was based on the variational approach. Before computationally intensive FEA verification, a predictive variational model was developed to determine the optimal bolt configuration for attaching the spatial truss of the truck to frame. The formulation minimizes the global stress functional of the mounting system for the case of 8 bolts, given on the image below, and it was based on the appropriate equation. The mounting system was considered as a functional depending on bolt positions and external loads. The equilibrium configuration corresponds to minimization of the global stress load functional. And finally, the objective was to determine bolt reactions, minimizing reactions in the mounting system. Variation of the functional was based on the quotation and especially on the bolt cross-section area, reaction vector in bolt, and variation of the reaction vector caused by bolt position accordingly. Research methodology. Equilibrium model of the bolted mounted system and mathematical model assumptions. The spatial truss was mounted using 8 certified bolted joints marked by the text A to H shown on the image below. Each bolt transfers internal loading generated by mounted equipment masses. The simplified model considered vertical reactions along the y-axis. Equilibrium equations. The bolted reactions were determined from force and momentum equilibrium conditions shown below, with the parameters like the internal force from mounted unit, vertical reaction in bolt and bolt coordinate. Optimality conditions was based on the analytical solution yielding shown below with the parameters Lagrange multipliers which quantify the effect of constraints variations of the objective functional. Finally, engineering interpretation was based on the points. First of all, the bolt reactions depend on bolt position and external bolt distribution. Secondly, the model enables preliminary prediction of overloaded joints before FEA verifications. And finally, the model was fixed by the fixed support constraints in the text A to H. Research methodology. The next step was to verify the mass modeling approach using FEA along with measuring other practically important indicators based on boundary conditions applied to the assembly model shown below. Its mesh consists of more than 200,000 nodes and more than 100,000 elements of the predominant tetra type and a finite element size of 5 mm with localization up to 2 mm. The assembly consists of the oil tank, inverter box, radiator, and motor unit. Overall, 4 loading modes were analyzed using the different dynamic coefficients CD and directions of internal loads defined as follows for each unit mass accordingly. CD acts as a multiplier of gravity G when calculating reactions along the XYZ axis. The next boundary conditions in ANSYS were applied, and the example shows its data for the mode 3.1. as an example accordingly. The next materials were applied in ANSYS to the assembly. The first one was the structural steels S235 and S275 with yield strengths of 253 and 297 megapascals accordingly. And the second type of the material was the aluminum alloy T4 for radiator plate with yield equal to 126 megapascals. All of them used nonlinear isotropic Hadron curve according to the ANSYS Granta educational pack data. And finally, the results. Stress distribution and structural integrity. The highest stresses were observed in the complex diagonal load in mode 3.1. Maximum von Mises stress reached up to 307 megapascals and occurred at time of 0.7 seconds. Localization of critical stresses. The maximum stress zone was located in the bend region of the C-shaped profile. At the end of the loading process, the stress concentration migrated towards the L-shaped mounting bracket. Local yielding slightly exceeded the yield strength of S275 steel, which is equal to 297 megapascals. Structural assessment. The observed region was highly localized, less than 5 mm. Plastic deformation penetration depth was of approximately 1 mm. So no critical loss of global stiffness or structural integrity was observed. Global structural response. Despite a local stress concentration, the average stress level remained relatively low, of 15 megapascals. Continuing the results discussion. Solve the deformation behavior and safety assessment with maximum deformation response data. The largest deformation was observed in the diagonal load in mode 3.1 with the value of 15.7 mm. The mirror-loaded mode 3.2 demonstrated significantly lower deformation of 7.3 mm. Finally, the increased flexibility in some uniaxial modes is associated with the lower section modulus of flat structural elements within the scope of the assembly, and the obtained deformation levels remained within the manufacturer clearance requirements. Clearance verification. Required cabin truss gap should not exceed 50 mm. Maximum predicted deformations was obtained at the level of 15.7 mm. So semi-tab there is no interface between the truss and cabin which was predicted. Finally, the stresses and deformations data is consolidated in the table shown below. So finalizing the results. Safety factor and bolt reaction analysis. No critical red zones were detected in the uniaxial load in mode 1.1. The minimum safety factor was observed near the oil tank support hole with the value of 0.94. Safety factor maps enabled identification of structural regions requiring a local reinforcement of transition from S235 to S275 steel. Bolt reaction distribution. Significant non-uniformity of reactions was observed between mounting joints. The largest reaction increase occurred in the joint D. The value increased from 2447 to 8545 newtons. The extreme load asymmetry was also observed in the joint H with the value 12,600 newtons. The validation of analytical model. Predicted versus finite element reaction ratio for the joints DA. So 1.16 the prediction versus 1.27 the FE results. And the difference is within 9%. Engineering implications. Bolt reactions govern both bolt selection and truck frame loading safety. High-strength bolts are required for extreme load cases, so bolts with the class of higher than 8.8, and to be specific, 10.9 up to 12.9 are recommended. So finally the conclusions. First, a variational formulation was developed for preliminary prediction of bolt reactions in multifunctional truck-mounted special trusses before resource-intensive FEA. Second, the analytical model demonstrated good agreement with FEA in uniaxial loading modes with deviation below 9%. Third, the critical structural condition was identified in the complex diagonal loading mode 3.1 with the maximum von Mises stress equal to 307 MPa and deformations of 15.7 mm. Fourth, complex multi-directional loading governs the structural assessment of truss under off-road operation conditions. 5. Despite local stress concentration, the structure maintained sufficient global strength with a safety factor higher than 13. 6. Significant non-uniformity of bolt reactions requires optimization of fastening zones and application of high-strength bolts with a class up to 12.9. And finally, the proposed methodology enables practical optimization of custom track-mounted equipment while preserving the UNEC certification compliance and avoiding frame recertification. Thank you very much for your attention.
Dear participants, I would like to present to your attention the report Improvement of the Combined Tuber Roots Cleaning Process and Development of Equipment for its Implementation. It was prepared by author Dmytro Dmitrievsky, Grigory Denichenko, Mushfit Bakirov, Dmytro Motorny State Agricultural University and State Biotechnology University Ukraine, and Dmytro Khorelkov, Vitaly Chervony, Karazin Kharkiv National University. The process of primary mechanical and technological processing of vegetable raw materials occupy an important place in the overall structure of production at food industry enterprises and restaurants establishment. Among them, the cleaning operation plays a specific role. Since it is at this stage that significant losses of raw materials are formed, the quality of semi-finished products and the overall economic efficiency of the production process are determined. Despite the relative technology simplicity, the process of cleaning vegetable is characterized by increased material and energy consumption and requires constant improvement, taking into account modern requirements for resource conservation and product quality. Analysis of scientific and technical resources indicates an insufficient number of complex experimental studies devoted to substantiating rational parameters of combined cleaning of vegetables, taking into account their physical and mechanical properties. The lack of generalized data on the influence of steam pressure, duration of heat treatment, and intensity of mechanical additional cleaning on the quality of cleaning and loss of raw materials significantly complicates the development of energy-efficient equipment of a new generation. The process of cleaning vegetable raw materials is one of the most resource-intensive operations in the technology lines of the food industry and restaurants industry. In scientific research of recent decades, considerable attention has been paid to improving cleaning methods in order to reduce raw material losses, improve the quality of the clean surface, and reduce energy consumption. Comprehensive experimental studies that simultaneously analyze the effect of steam pressure, duration of thermal treatment, and parameters of mechanical post-cleaning on the quality of cleaning and raw materials losses are presented in limited quantities in the literature. They complicate the formation of generalized recommendation on rational regimes of combined cleaning of tuber crops. The analysis of the literature indicates the presence of significant scientific and practical interest in improving the processes of cleaning tuber roots, in particular by using combined thermal and mechanical effects. At the same time, the insufficient number of comprehensive studies devoted to substantiating the rational parameters of such processes and developing compact energy-efficient equipment for their implementation determines the relevance of further research in this direction. Within the framework of the conducted research, a combined method of cleaning tuber roots was developed and experimentally investigated, which combines thermal treatment with excess pressure steam and subsequent mechanical surface cleaning of the product. This approach is based on the principle of preliminary weakening of the connection between the peel and pulp of vegetables as a result of short-term intensive thermal exposure, which allows to significantly reduce the energy consumption and duration of mechanical cleaning and minimize the loss of raw materials. The main goal of the experimental research was to determine the rational parameters of the combined cleaning process, namely, the duration of thermal treatment of tuber roots with excess pressure steam, the value of the steam pressure, the duration of mechanical cleaning, establishing the influence of the specified parameters on the quality of surface cleaning, and the percentage of raw material losses. Research tasks were to investigate the influence of steam pressure and treatment duration on the surface layer of crops, to determine the effects of mechanical cleaning, duration of cleaning, quality, and raw materials losses, to establish rational parameters for the combined cleaning process, to develop equipment capable of ensuring efficient peel removal with reduced energy and water consumption, to evaluate their effectiveness and reproducibility of the proposed cleaning method. Before the start of the experimental, the serviceability of the installation and the water level in steam generator was checked. After tuning of the electric heating element, the steam pressure was gradually increased to the set value, which was controlled by a manometer. After the steam generator entered the operating method, the prepared tuber roots were loaded into the vacuum chamber. Heat treatment was carried out in the steam pressure range of 0.3–0.7 megapascals with a step of 0.1 megapascals. The duration of treatment varied with 10 to 70 seconds. After the specified time, the steam supply was stopped, after which the steam was instantly released from the working chamber. A sharp decrease in pressure led to intensified evaporation of moisture localized in the subcutaneous layer of tuber crops. As a result of this process, internal stresses arose, which violated the adhesive bond between the skin and the pulp, which created favorable conditions for further mechanical cleaning. It was found that with a treatment duration of less than 10 seconds, the effect of weakening the surface layer is insufficient, while exceeding 70 leads to excessive heating and increased losses of raw materials due to damage to the edible part of the product. Similarly, steam pressure below 0.3 megapascals did not provide the necessary effect of peeling, and values about 0.7 megapascals were considered inappropriate from the point of view of energy efficient and operating condition of equipment in catering enterprises. Mechanical cleaning was carried out on a working surface made of steel and made in the form of a wavy profile. Cleaning took place due to friction forces and interaction between individual tuber crops and the working surface. The duration of mechanical cleaning varied in the range of 30 to 110 seconds and was determined by the moment of complete removal of the skin from the surface of the product. Analysis of the presented data shows that with increasing duration of heat treatment, there is an increase in the depth of heating of the surface layer of tuber crops. The obtained graphical dependency demonstrates a clear influence of both vapor pressure and duration of the process on the intensity of thermal action, in particular an increase in vapor pressure in combination with a longer treatment time leads to an increase in the depth of thermal action, which is due to the intensification of heat transfer and partial destruction of the cellular structures of surface tissues. The calculated dependencies and experimental data also confirm the assumption about the influence of the storage period of tuber crops on the depth of thermal treatment of their surface layer. With increasing duration of storage, the physical and mechanical properties of tissues change, which is reflected in the nature of their reaction to the thermal action. Within the framework of the combined process of cleaning vegetables, it can be stated that an excessive increase in the depth of thermal treatment leads to an increase in the loss of raw materials during mechanical cleaning. This is due to the fact that part of the softened surface layer is removed along with the peel. At the same time, reducing the duration of heat treatment and reducing the steam pressure aimed at limiting the depth of heating can negatively affect the efficiency of skin separation. Given the above, for a comprehensive assessment of the impact of heat treatment of the surface layer of tuber crops raw materials, it is advisable to use an additional indicator, the skin separator force. The parameter allows you to quantitatively assess the degree of disruption of the bonds between the skin and the pulp after thermal explosion. The dependence of the skin separation force on the duration of heat treatment and steam pressure shows in these results. With increasing steam pressure and duration of heat treatment, there is a gradual decrease in the peel separation force. Mechanical cleaning is the final stage of the combined process of cleaning vegetables. To improve the quality of cleaning and minimize raw materials losses, it is necessary to take into account all the factors affecting this stage, in particular the duration of mechanical input. With an increase in the time of mechanical cleaning, the intensity of the action of the working bodies on the surface layer increases, which can lead to increased losses. At the same time, excessive reduction of the process duration worsens the quality of cleaning. The results of the study showed that the depth of heat treatment directly affects the percentage of raw material losses, while the peeling force determines the proportion of completely cleaned the tuber crops. The experimental data shows that for a peeling force for 1.1 Newton and a mechanical cleaning duration of 30 seconds, the percentage of completely cleaned vegetables is about 91%. If this force is increased to 7 Newton, the proportion of cleaned raw materials decreases to 68% and for 15 newtons to 47%. Under such conditions, achieving the required cleaning quality is problematic, which makes the use of the corresponding raw materials impractical. Increasing the duration of mechanical cleaning to 70 seconds allows you to increase the percentage of clean tuber crops by 4 till 9% and up to 110 seconds by another 4 till 50%. At the same time, as shown in this result, with an increase in the duration of mechanical impact at the depth of thermal treatment, the percentage of raw material losses increases significantly. At the depth of thermal impact of 110 meter, the losses change slightly. Thus, the criterion for the quality of the cleaning process was reasonably chosen to achieve the maximum share of clean tuber crops with the minimum possible mass loss of the finished product. The generalized dependencies of the quality indicators of mechanical cleaning on the depth of heat treatment and the duration of the process are shown in these results. To implement the proposed cleaning method, it is assumed to use a specialized installation for cleaning vegetables, which is presented in these results. The operation of the installation is carried out as follows. At the initial stage, the raw material is fed to the working drum 4 through the loading hopper 5. During the cleaning process, the surface of the tubers is simultaneously affected by working elements made in the form of cleaning rolls 3, which differ in shape and geometric dimensions. Due to the variety of shapes and sizes of the rolls, effective cleaning of vegetable tubers is ensured regardless of their configuration and dimensions. The cleaning rolls are covered with a layer of special rubber and rotate around their own axis, as well as together with the rotating shaft on the drum tube. This nature of the moment intensifies the mechanical effects of the rolls on the surface of the tuber and increase the efficiency of the cleaning process. The working drum 4 is driven by an electromotor 8, the transmission of torque from which is carried out using a Whipple transmission 6. Simultaneously with the mechanical action of the rollers, the tubers are affected by a vapor environment of excessive pressure. Steam is supplied directly to the working chamber through steam supply nozzle tap. This approach allows to minimize the depth of thermal impact on the surface layer of tuber crops and significantly reduce the duration of heat treatment. The storage period of raw material and dry matter content were also shown to affect the intensity and duration of mechanical cleaning, which should be considered when selecting operating mode. Based on the generalization of experimental data, rational parameters for the implementation of the combined cleaning process have been determined. It is recommended to perform steam treatment at a pressure of 0.3 MPa for 35 till 60 seconds, followed by a mechanical cleaning for 70 till 105 seconds, with adjustment according to storage duration and physico-chemical properties of tuber crops. Under this condition, peeling completeness reached approximately 94 till 95%, while raw materials did not exceed 9 till 10%. Statistical analysis confirms the significance of the obtained results, and coefficient of variation did not exceed 6 till 7, indicated higher reproducibility and process stability compared to conventional mechanical and steam-only methods. The proposed combined approach demonstrates improving peeling quality and reduced material losses. The development equipment eliminates the need for abrasive working bodies, reduces energy consumption, and enables processing of tuber crops of various shapes and sizes.
Dear participants, we present to your attention a report on the topic Thin Absorbent Paper from Cotton Eucalyptus Cellulose. The pulp and paper industry faces environmental challenges due to high use of wood, energy, and water, which drives the search for sustainable fibrous materials. Cotton cellulose is a promising option for Ukraine because of its high purity and suitability for sanitary and hygiene paper, as well as its growing strategic importance for domestic production. This study optimizes the composition and refining combinations of cotton and wood pulps for produce thin absorbent paper with improved properties. The research aim is to substantiate the optimal fibrous composition and technological conditions of pulp preparation to ensure improved absorbency, mechanical strength, bulk, and whiteness of thin absorbent paper. Research tasks were to investigate the feasibility of using cotton cellulose as an alternative fibrous raw material for thin absorbent paper production and to evaluate its combination with bleached sulfate eucalyptus pulp. To determine the influence of the grinding degree of cotton cellulose and eucalyptus pulp, as well as their component ratio on the formation of paper structure and on absorbency, bulk, mechanical strength, and whiteness. To establish the optimal fibrous composition and technologically feasible pulp preparation conditions for producing a low basis weight absorbent paper with balanced functional properties for sanitary, hygienic, and specialized applications. Paper samples were produced from the composition of the paper pulp based on bleached cotton cellulose and bleached sulfate eucalyptus wood pulp. The components are mixed in the composition regulations until they are homogeneous. The paper production process included several steps. First, cotton cellulose and bleached eucalyptus pulp were ground and prepared separately. Then they were mixed with water in set proportions to form a fibrous composition. After that, a fiber suspension was prepared from this mixture. Finally, sheets were formed from the suspension and then cribbed and dried. The reference sample is made from a mixture of cotton cellulose fibers, bleached softwood sulfide pulp, and bleached hardwood sulfate pulp. Using standardized methods and equipment, the following indicators of paper samples were determined: weight of 1 square meters of paper, breaking force in the machine and in the cross directions, capillary absorption, paper bulk, and whiteness. Table 1 shows that cellulose fibers vary depending on the plant source, which affects paper properties. Softwood fibers are long and strong, but contain more lignin and have a lower whiteness. Hardwood and straw fibers are shorter and form a more uniform but weaker structure. Bast fibers and cotton have a high length-to-width ratio, high cellulose content, and low lignin, which gives a high whiteness and purity. Cotton is especially suitable for absorbent paper due to its high whiteness, 80–90%. High cellulose content, 84–98%, very low lignin, up to 0.3, and good softness, absorbency, and strength. In Table 2, you can see that experimental paper samples were prepared with controlled fiber composition and different refining levels. Sample 1 to 5 contained 40–48% cotton cellulose and 50–58% bleached eucalyptus pulp. grinding to 36 degree Chopin-Regler and 1723 degree Chopin-Regler to study the effect of long and short fibers on structure formation. The reference sample had a more complex mixture of cotton cellulose, softwood sulfide pulp, and hardwood sulfate pulp with higher grinding. This increases strength but reduces uniform porous structure, which is important for high bulk and absorbency in thin paper. In Table 3 you can see that experimental paper samples made from cotton cellulose and bleached sulfate eucalyptus pulp showed better properties than the reference sample. At similar basis weights, they had a lower density and higher bulk, indicating a more developed macroporous structure important for absorbent paper. The improved bulk did not reduce strength. Breaking force increased to 6.4 Newton in a matching direction and 3.2 Newton in cross direction, while capillary absorption rose from 36 to 41. Whiteness remained high to 84–86%. The combination of long fiber cotton cellulose and short fiber eucalyptus pulp provided an optimal balance of bulk, absorbency, softness, and mechanical strength, whereas the reference sample formed a denser and less absorbent structure. As a conclusion, we note the following. The study confirmed the feasibility of using cotton cellulose for thin absorbent paper production. Combining cotton cellulose with bleached sulfate eucalyptus pulp ensure high absorbency, bulk, strength, and whiteness. Optimal properties were achieved at grinding degrees of 36–46 degree Chopin-Regler for cotton cellulose and 17–23 degree Chopin-Regler for eucalyptus pulp, with component ratio of 42–48% and 52–58%. This composition formed a macroporous structure with improved capillary absorption and mechanical strength. The work established optimal grinding regimes and fiber ratio for producing low basis weight absorbent paper and can be applied in sanitary, hygienic, and specialized paper materials. Thank you very much for your attention.
My name is Thomas Lenka, and I would like to present the results of our research titled Performance Evaluation of Roller Press for the Watering Lime Softening Sludge. This work investigates the application of JT-type multi-disc roller press for dewatering inorganic lime sludge generated during municipal water treatment. The study was carried out under real operating conditions at full-scale water treatment facility. Our research focuses on improving sludge management efficiency, reducing operation problems, and evaluating the potential of pressure-based dewatering technology for mineral-rich sludges. Slide 2. Introduction and major challenges. Lime softening remains one of the most common methods used in municipal water treatment for hardness removal. However, this process generates significant amount of lime sludge, which is mainly composed of fine calcium carbonate particles. This sludge presents several major challenges. First, it contains extremely high moisture levels, often between 95 and 99%. Second, the particles are very fine and retain water strongly. Third, the sludge is highly abrasive, which accelerates equipment wear. Because of these properties, conventional dewatering technologies such as belt-fill press, centrifuges, drying beds, and vacuum filter often perform poorly. Typical operation problems include clogging or filtration media, unstable operation, excessive maintenance, and low cake dryness. At the same time, there is still limited industrial-scale research on the use of multi-disc roller press technology specifically for lime softening sludge. This forms the basis of our study. Aim and research task. The main aim of this research was to evaluate the efficiency and operation stability of JT-type roller press for dewatering lime softening sludge under real plant conditions. To achieve this goal, several research tasks were defined. First, we evaluate the dewatering efficiency and achievable cake dryness. Second, we analyze the influence of chemical conditioning on the sludge behavior and filtration performance. Third, we investigate operation stability, including resistance to clogging and abrasive wear. Fourth, we measured solid capture, efficiency, and filtered quality. Finally, we assessed sludge volume reduction and the practical advantages of implementing this technology at water treatment facilities. Research methodology, pilot facility, and sludge characteristics. The study was conducted at a municipal lime softening water treatment plant in Lima. The sludge generated at this facility consisted mainly of finely dispersed calcium carbonate particles. The incoming sludge concentration varied between 4 and 6% dry solids. The sludge exhibited poor settling characteristics, high water retention capacity, and strong abrasive behavior. To evaluate the technology under realistic conditions, a full-scale pilot installation of the JT multi-disc roller press was operated continuously during the testing campaign. Chemical conditioning. Preliminary testing showed that efficient dewatering required two-stage chemical conditioning. The first stage involved the addition of metal salt coagulant and approximately 400 parts per million. This step neutralized particles, charges, and promote aggregation of ultrafine particles. The second stage involved dosing a high molecular weight cationic polymer and 12 to 15 pounds per dry ton. The polymer was mixed in flocculation tank where strong and shear-resistant flocks were formed. To optimize the reagent combination and dosage, jar tests were performed. The results confirmed that dual-stage conditioning significantly improved flow stability and filtration behavior. After conditioning, the sludge entered the JT roller press. The system used intermesh stainless steel and resin disc arranged in the counter-rotating rollers. Several design features are important. First, the roller gap gradually narrows, creating progressive compression of the sludge. Second, the system includes a gravity thickening zone before the compression stage. Third, the alternating disc geometry creates a self-cleaning effect that prevents clogging. Unlike belt-fill presses, the system does not use filter cloth, which eliminates blinding and falling problems. In addition, the roller operates at low rotation speeds, typically below 1.5 revolutions per minute. reducing mechanical wear and energy consumption. Performance indicators. Several operation parameters were monitored during the pilot study. This included cake dryness, filtrate total suspended solid, solid capture efficiency, polymer consumption, and sludge throughput. Cake samples were dried to constant mass at 105 degrees Celsius. Filtrate quality was evaluated by measuring suspended solid concentration. To ensure measurement accuracy, all tests were performed in triplicate. Flow meters were calibrated, and mass balance calculations were used to verify polymer dosage and solid capture. This validation procedure ensured reliable and reproducible results. Dewatering performance. The pilot study demonstrated stable and effective dewatering performance. The roller press produced sludge cake dry with dry solids concentration between 32 and 45%. This is significantly improved considering that the incoming sludge contained only 4 to 6% dry solids. At the same time, sludge volume was reduced by approximately from 7 to 15 times. Solid capture efficiency exceeded 95% throughout the testing period. These results indicate that the pressure-based multi-disc system can be effectively remove water even from highly mineral and difficult to dewater sludge. Filtrate quality and stability. Filtrate analysis showed suspended solids concentration between 800 and 1200 milligrams per liter. These values were lower than those typical observed for centrifuges system operating at the same facility. Operationally, the system demonstrated excellent stability. No clogging, torque instability, or process interruptions were observed after parameters adjustments. The press also remained stable despite moderate variation in sludge concentration and polymer dosage. This operation robustness is especially important for treatment plants where sludge properties change over time. Influence of chemical conditioning. Chemical conditioning played a critical role in achieving high dewatering performance. The combination of coagulant and polymer improved particle aggregation and reduced filtration resistance. The formed flocs were dense and resistant to mechanical shear during compression. As a result, the sludge maintained structural integrity during dewatering, leading to high solid capture, low filtrate turbidity, and stable cake formation. The optional reagent dosage was approximately 400 ppm coagulant and from 12 to 15 pounds of active polymer per dry ton. This value remained consistent throughout the pilot operation. Results, engineering and economic advantages. The study also demonstrates several engineering and economic advantages of the JT roll press. The system consumes relatively low energy and does not require wash water. Because of the low rotation speed, mechanical wear is minimized even when processing abrasive sludge. The self-cleaning disc geometry reduces maintenance requirements and prevents operation downtime. The significant reduction in sludge volume improves transport efficiency and lowers disposal cost. These advantages make the technologies suitable not only for municipal water treatment sludge, but also for industrial mineral slurries and abrasive residues. Result discussion, comparative summary. Overall, the results demonstrate that pressure-based multi-disc dewatering is a reliable solution for lime softening sludge. The gradual compression mechanism allows efficient water release without destroying floc structure. Low shear stress helps preserve particle aggregation and improve solids retention. The combination of optimized chemical conditioning and mechanical robust design enables stable operation even under difficult sludge conditions. Therefore, the technology successfully overcomes the traditional limitation associated with mineral-rich sludge, including fine particle size, high water retention, and abrasiveness. Conclusions. In conclusion, the JT-type roller press demonstrated high efficiency and operation stability for dewatering lime softening sludge. The system achieved 32 to 45% cake dry solids, more than 95% solids capture, and 7 to 15 times sludge volume reduction. The roller press operated continuously without clogging or major maintenance issue. The combination of two-stage chemical conditioning and self-cleaning disc geometry provide highly effective for treating abrasive mineral sludge. These findings confirm the strong potential of pressure-based multi-disc dewatering technology for modern sludge management system. Future research should focus on long-term industrial operation, energy optimization, environmental assessment, and testing with other sludge types. Thank you for your attention.